Okay. Good morning. So, welcome to ServerlessDays Hamburg 2020. Let me find my slides. Here they are. So, this is your host. This is Jonas and me. Hi, Jonas. Can you say hello as well?
Hello, good morning, everyone.
And yes, so we got you through the conference. And before we start, actually, I want to give you a brief overview, a quick history lesson about the Serverless Hamburg journey. And actually, this started back in 2017. And in 2017, this guy, Alex Casalboni, you might know him as he is also a little bit famous in the serverless community. He asked me if I could speak at the conference he organized at this time, the JeffConf Milan, so in Italy. And yeah, I accepted, and this was a really cool conference. And at this conference, I actually met these two guys and Paul, and they are the organizers of JeffConf and now Serverless London, and they actually had this idea of the JeffConf. So we thought, hey, why not, after a quick chat, we thought, hey, why not do a third JeffConf, and this time in Hamburg? And so I kind of pre-announced at my talk that we would do a JeffConf Hamburg. Yeah, but then actually the real work started. So announcing is easy, but now we have to do all the work. We have to find sponsors, we have to find a location, we have to find speakers, we have to find organizers. And as you know, everything in Serverless Days is so it's a non-profit event, and so we needed to find volunteers and so on. But after only, I would say, like 4 months or 5 months, we had it up and running in 2018, and we had a really cool conference location in a museum in Hamburg, in Altona. And this was a lot of fun. We had to not so much in the serverless mindset, but we had to custom build much stuff. We had to bring this projector by ourselves, and we also so we had to do much things on our own. But which was really cool, we had managed to get Simon Wardley as a keynote speaker. This was really cool. So he's I would say, like, Mr. Serverless is more about business and not about technology man. So really check out his Wardley mapping if you've not heard of it. And we had 200 attendees, 17 talks, so really packed. So this was really cool and great. And in the end, we had a little surprise. So in the end of the conference, then Stanley joined us again. So one of the fathers of JeffConf and Serverless Days. And there he revealed that from now on, JeffConf would be called Serverless Days. And from there on, it actually exploded. So we had Serverless Days all around the world. And so this was really cool for us. And in Hamburg, we also continue to have Serverless Days. So our second conference and the first official Serverless Days in 2019, we again were in a museum, but this time in the Stadium Museum of the famous FC St. Pauli. This was again really cool. We had great weather, like this was in February, and it was really warm and really cool. So people were there in t-shirts, and so this was really nice. And again, we had a great conference. We had about over 200 people. We had 10 talks or so. Yeah, so this was really great. Then 2020. So what happened in 2020? We already were set up. We had again chosen a really great location, this time the Schmitz Tivoli, a theater in Hamburg. But then, as you all know, everything became different. and then we had to make a decision. And so the decision was like cancel the conference, move it. So what to do? And actually, in the end of June, we made the decision to move the 2020 edition fully virtual, fully online. And so this was a really hard decision. And we are really glad that most of the sponsors are still with us. And I want to really shout out to our sponsors. And our sponsors are AWS, Cthulhu, CodeCentric, Lumigo, Sinner Schrader, Global Data Net, Opitz Consulting, Sandra, Kreuzwerker, and Cellular. So thanks again. This is really cool. You make this happen along with the attendees. Thanks again. And now I want to do a little bit more of shout outs. So also shout out to our org team. So first of all, we have Teresa. She's our main event organizer. She does all the coordination, and we're really happy to have her. Hendrik is our marketing person, and he does all the things, marketing and sponsors. So thanks. We have Jojo. He created the entire virtual setup for us and tested it. Unfortunately, he cannot be us today because he got sick. We have Till. He helped us among other stuff with diversity tickets. We have Jonas, your co-host together, who is another multi-talent. So among moderating stuff, he's also very savvy in technical stuff. And my humble self. Another shout out goes to our call for papers. I always call them like committee. Susanne, Ben, and Boris, they had to go through 100 submissions, and this is really hard work. So thanks again. Our code of conduct. We have a code of conduct in place. You all agreed to it when you got your ticket. We take this very serious, and we have a dedicated team for this. We have Nina and Sebastian. They are also on the Discord server, and you can find them there. So if you have anything, please, they are your go-to persons. We also have an email address, so there are 2 contact methods. And the long version is here, and also the contact information is also on this link. Jonas, can you share this link in the YouTube channel, please? And yes, thanks. So, and as I already said, save the date. So we try to be back in a physical or hybrid mode in 2021. We are optimistic, so we have chosen the May 6th and 7th to be back. We don't know yet the exact setting, but please save the date. And your tickets which you bought for 2020 are also valid as a special gift for 2021. So yes, please save the date. We also have, as you probably already know, we have a Discord server. This is the only server we have at this conference. It's very funny that it's called a Discord server on a serverless conference. But jokes aside, this is our main entry point for discussion and QA. You can ask speakers there. They will be live for Q&A after their talk. And we also send this link again on in the YouTube comments for you. We have a hashtag, and this is very easy. It's Serverless Hamburg. So if you want to tweet, please use this hashtag. Thanks. And actually, this is our agenda for today. You can also find this agenda on the website. We will share the link as well with you. And we have 3 breaks. one bigger lunch break and 2 smaller like coffee breaks. And in between we have the talks and live Q&A with the speakers. So, and now last but not least, I have an announcement from one of our sponsors, Global Data Net. So they are inviting you to a serverless beer tasting, and you can register at the URL beer.globaldatanet.com. I think this is the easiest one. And now I'm actually finished with my introduction slides. And let's see. So we now have a little. I have talked very a little bit. I should have talked a little bit slower. Okay, but so Jonas is there. Yes. So yeah, I would say we start in 1 minute or so with the first talk. Okay.
Yes, that sounds good. So in the meantime, a very warm welcome and good morning from me to everyone as well. Nice to see that there's so many people online already. And I'm going to give a short introduction about Vadym, Vadym Kazulkin, who is going to give the first talk in just a few minutes. Vadym is the head of technology strategy at IP Labs from Bonn, and I think it's safe to say that he's also a long-standing part of the serverless family, as he is the founder of the serverless group in Bonn. So he's actually one of these little animals that you saw on Sönke's worldwide map before. He is focusing on highly scalable and available solutions, serverless and AWS cloud in his work. And he's going to talk very soon about the visible and invisible benefits of the serverless paradigm. The talk is called FaaS or Not to FaaS, so it's going to be a little bit philosophical as well. What's important is that there is for every talk a dedicated Discord channel as well online. So for every talk, there's going to be an extra channel, which is going to be announced in the general channel of our Discord server. So you can ask questions there. The speaker is going to be online in these channels as well. And me and Sönke, we are going to pick some of your questions in there and present it to the talkers, to the speakers in the live Q&A. So make sure to go there. The FaaS channel is already online. Vadym is online there as well. So you can have some nice discussions and in-depth questions there without disturbing the general channel. And now let me pull up the talk of Vadym. There it is. And as it's almost 9:45, I would say we jump right into it.
Hello and welcome to my talk, FaaS or Not to FaaS, Visible and Invisible Benefits of the Serverless Paradigm. My name is Vadym and I will present this alone due to the short format, but Christian, my colleague, and me created this talk initially. And we both work for the company called IP Labs in Bonn, where we provide software for creating and purchasing of the photo products like calendars, photo books, prints, and so on. And we've gained a lot of experience with serverless, especially on AWS, since the beginning of 2018. And many things I will talk about also fit for other serverless solutions, but all practical examples will be from the AWS cloud. So as a guy who lives and works in Germany, I'm really proud to present on this German event. So first of all, we would like to talk about the value proposition of the serverless and draw the total cost of ownership of this paradigm. So it starts with that we don't need to manage and operate the infrastructure. And you as a company should ask yourself, is this your core competency? So if you are the data center or cloud provider, probably yes, but otherwise it should be no. Other thing is auto-scaling and fault tolerance built in. So ask yourself, can you get capacity planning and auto-scaling right? Do you want to solve the hard problem of fault tolerance by yourself? And also the answer may be probably no. And serverless enables this by default. So do more with less. And what I mean by this, by heavily relying on the managed services, you need fewer engineers to start implementing your new ideas, some kind of proof of concept, and you can do also more with the same amount of people. Lower technical debt, and I really love this quote from Paul Johnson, who is very known in this serverless area. Whatever code you write today is always tomorrow technical debt. So the less code you write, the less maintenance you have to do, and also this lowers technical debt. And also ask yourself what time and effort you invest in implementing the solution and then maintaining this solution. I will probably argue that 75% will be invested in maintaining. So the maintenance cost should be lowered. This enables us also focus for other things. And this is focus on business value and innovation. And every organization wants exactly this. They all want to be innovative. And this also enables faster time to market. And this is the key differentiator in today's business, but you should also ask yourself, what is your core and what is commodity, which can be bought as software as a service and so on. So you really retain the focus on your core business. And serverless enables this, as we have seen. So, but generally, if we ask ourselves, FaaS or not to FaaS, in our industry is everything trade-off. There is no silver bullet. So what I will present you is some kind of decision checklist, the things you have to understand, you have to ask yourself, because it depends on your environment and your company and your culture and so on. I will also talk about the challenges and especially how you can tackle these challenges with the AWS serverless offerings to help you make the decision. So the first thing you have to understand is your application lifecycle. And it can be divided in two parts. The first one is explore and the second is exploit. And in the explorer phase, you want to quickly validate your hypothesis, rapidly experiment, run experiment cheaply as possible. Some kind of greenfield, and serverless is really perfect fit. So you can start small, you can iterate, you can look if your hypothesis is right or not, and it's really cheap. You don't want to invest in the infrastructure where you pay on demand or even reserve to save costs, but you don't know if the idea will really shine or not. So the serverless is really cheap approach and also valid approach. But of course, if you have built something that already provides customer value, you want to build it at scale, and you want to build a profitable product around this. And there is no single correct answer what the solution will be the best, or some kind of mixture architecture probably. But the things you have to consider, you have to ask yourself is, how much stake do you want to own to be able to deliver business value, on what can you outsource? And by outsourcing, I mean SLAs, compliance, price, and the roadmap to your service provider. And sometimes, especially by outsourcing roadmap, you can be disappointed if you're a small company. So all your feature wishes may be not taken into account. So sometimes you need to go fast and own a bit more as you would like for your special solution. But of course, we also have existing applications. You can't magically move them all to service providers, especially to the serverless architectures. But you can try to modernize parts of your application or do things differently. And there is a stronger pattern coined by Martin Fowler probably 15 years ago. And the idea is that you can put a proxy above the layer and then try to do things differently or refactor the existing solution, applying different architectures. And with AWS, you can put API gateway or even also application load balancer and then call Lambda. So shift this to the serverless architecture from some specific point. So that's all for the application lifecycle. Let's talk about understanding your workloads. And by meaning this, there is natural fit for serverless architecture, and this is event-driven architecture. Also, API-driven architectures are really good fit. We will also talk about pricing because they may be expensive, but also bad job. And think of this, at IP Labs, initially we have done some kind of application which consisted of all batch jobs. The problem with this was that they all run in the midnight. And it also created some scaling issues. With the serverless solution, you can simply ship each batch job individually, and then it will be scaled automatically. And it's a huge advantage. Also, internal tool, how it started at IP Labs the beginning of 2018, we had to write one tool which had to do heavy computation by only one time per month and then only occasionally in between. And it was also the perfect fit because we also saved a lot of money running this also only on demand. But there are also some other architecture or workloads like machine learning, big data. I didn't see a lot of usage of serverless there, but there are also new features or relatively new features like Lambda layers and Lambda runtime that you can ship your own Docker container, which can contain tools like TensorFlow or MXNet. Then you can do machine learning, artificial intelligence, and so on there. And also recently released feature that you can attach Elastic file system to a Lambda also enables you to install the programs because Elastic file system speaks NFS protocol. So there are a lot of possibilities there because you can't install simply the programs on S3 bucket. But of course, there are also other things to consider. Do you require GPU access? It's possible with containers, with EC2, but not possible for Lambda. And that's for the good reason, because GPU is sometimes slow and it doesn't really match well for the serverless architectures. Another thing is if you use serverless and then you choose your RAM, you will get a CPU and network proportionally. So if you double your RAM, the CPU will also be doubled, but not every application needs this proportionally. Sometimes you have RAM-bound CPU, even network-bound application. So sometimes you may probably overpay. It doesn't mean that it's not good, but you have to think about this. Also, do you need constantly high performance? So sometimes you need response time below 100 milliseconds for bidding or gaming platforms. It's not impossible, but it's kind of difficult to achieve with serverless architectures, with cold starts and so on. There are ways to work around this. We will talk about this, but this is generally, if you need really constant high performance, serverless maybe not a good fit for you. Also, do you need the high throughput? And the situation is that Lambda network bandwidth is really limited and order of magnitude lower than a single modern SSD, and it's shared between all the functions backed on the same VM. So people also measured how long it took to write from Lambda to S3, and also Elastic file system, the throughput is not that good. If you have throughput intensive application, you may pay penalty in form of response time. Also, if two Lambdas need to communicate with each other, functions are not directly network accessible because the IP addresses changes and so on. So they must communicate via intermediary service. So the all payload have to be serialized and then deserialized. And it also causes latency. If it's not a problem for you, like this is asynchronous communication, then everything is fine and you don't really need to call one Lambda from another. You can also put API gateway, event bridge, or something in between. But if the latency plays a huge role, so think if you can merge two functions or not, so that you don't need to call them one from another. So now we are coming to the programming model, and what really made me start the situation is that every function AWS may fail and have to be retried. So for some asynchronous communication, asynchronous calls will be retried automatically 2 times, I think. And there is also only at least once delivery guaranteed. So if this is true for events like S3 or even SQS. And this means that your Lambda should be idempotent. It sounds simple, but it's really difficult to guarantee. Think of this. Do you write every piece of your logic that is idempotent? I think not. So sometimes it's really easy to achieve, or this is some kind of, if you call the computation several times with the same input, they will produce the same output. So if you occasionally do it twice with the same result, then who cares? But sometimes you save the thing, something on S3 or also in the DynamoDB, and if the function fails in between, so you may have some inconsistent state. So this shifts the complexity to the developers, which have to think about that idempotency, and it's really hard. It may be really hard for some use cases. And of course, if you use other solutions like Kafka, you have at most once delivery, or even essential or exact one delivery, which is really hard to achieve, but you have more options to choose. And this is some kind of thing that if a serverless solution will provide some kind of atomicity, it will ease the life of the developers. Now we will talk about some broader topic like platform limitations. And of course, there is a cold start. I won't spend too much time on this, but you have to think with cold starts with only Lambda or Lambda behind the VPC, because you use Elastic Cache, Elasticsearch, or RDS, which requires VPC with some exceptions. And we had the situation last year that Lambda behind the VPC had additional cold start because of the VPC of 10 seconds. It was fixed, and now it went below 1 second, and it's really a huge advantage and a huge win. Of course, you may run in the problem that if you use the relational database, that you may run out of connection, and this is connection pool and connection pool management with Lambda is not really a good fit. So there is another solution, Amazon Aurora Serverless Data API. There you can access your relational database, MySQL or Postgres, via HTTP, the similar as you access DynamoDB. But even after 1.5 years, it's still in beta as far as I know, and there are some problems with latency and also the huge payload. Jeremy Daly, who is also a speaker here, wrote the blog post where he explained all those challenges, but it may be the solution for the future. Also, you may use provision concurrency to lower your cold starts or to eliminate it initially, and it's really a good solution for programming languages which will be executed very quickly, like Java, like C#, but they suffer cold starts. And of course, if you send some newsletter at 9 o'clock and you know that you will have a huge spike there, then sometimes it's really good that you pre-provision the concurrency. Of course, you pay for this, but it will be guaranteed that you can scale. Also, there are other solutions with languages like Java. Especially for Java, you have ahead-of-time compiler with GraalVM or even Substrate VM with native image, and frameworks like Micronaut, Quarkus, or Spring Boot, which offer support for GraalVM. So there are solutions to lower the cold start even for Java. But generally, don't be scared of cold starts. So you can't avoid this. You can do this, but you overpay or over-provision. You will also have them with your containers. Despite of bin packing, sometimes the containers are full and you need to spin another one, and it takes many seconds to spin another EC2 instance. And so also you will suffer from them also there, or you scale out quickly and then you overpay. So in general, cold start don't really matter if you make the call asynchronously. So other limitations, there are a lot of them. Each service has a huge list. Lambda duration is currently limited to 15 seconds. An API gateway timeout can be configured with between 1 and 29 seconds. So if you put Lambda behind the gateway, then API gateway will still time out, and Lambda may run a bit more. But API gateways for the public-facing API, and you don't probably want your customers to wait even for 29 seconds. So think about this, what is the appropriate response time, and then what you can do to deliver the response quickly and then produce the logic asynchronously. And also you can assign only 3 gigabytes currently of memory to your Lambda functions, which is enough in most cases. So other limitations are the maximum amount of concurrent invocations of all Lambda per account. It depends on the region. This is between 500 and 3,000 parallel executions. This is the soft limit. You can raise the limit, but the thing that how many, even to 10,000, but you only can get 500 additional invocations per second below, above this limit. So think about this also in advance, or you may use different AWS accounts to split your Lambdas into services and then host the services in different accounts and then somehow manage your accounts with AWS organization and so on. So there are solutions, even valid and correct solution to do this. And also this max connection limit with the relational database. So the connection limit is factor of your RAM. So if you have M5 X large database, you will have so many connections. If you increase this to 2x, then you will have double of connections. But generally, Lambda and relational database that don't match too good with each other, then you have this RDS proxy solution. Postgres users can think of this like PG Bouncer. You also have already mentioned Data API for serverless, or the best fit is to use NoSQL database like DynamoDB with Lambda. Now we will come to another topic, and this is cost, or even cost at scale. And this is the typical invoice for serverless application. You see Lambda cost is not nearly 1% of the total cost. So what are other factors? So API gateway may be expensive, because it's priced by $3.50 per million calls. And if you have heavily API-driven architecture, it may cost you money. And you can also use application load balancer, but then you will lose some features like throttling, which are provided by API gateway. But generally, there is another alternative called HTTP APIs, which is still in beta. It may be 70% cheaper and also faster, but there is currently no feature parity with API gateway, but this is the goal. And I see a lot of new releases in HTTP APIs in the recent months or even days. Also, DynamoDB provides currently on-demand mode, because with the provision mode, you had to calculate read and write capacity units and think of auto scaling. And now this work is taken away. But of course, you have to think about the cost. If you have constantly high workload, then it may cost you the seventh of the provisioned concurrency. But of course, you don't have the high load generally all the time. So in the night, you probably don't have anything. So it may even be much cheaper to use on demand. So on demand, there is also logging costs and also monitoring costs, both with CloudWatch. So you have to take this into account. And also there are other things like data transfer costs. This is a really huge topic and not that easy to understand the cost within one availability zone or even between regions. So there is a diagram how these costs are calculated. Also, X-ray can add up to costs. Step functions is probably one of the most pricey services because you pay $25 per million state changes. If you activate caching, like in API Gateway or DAX, the caching solution for DynamoDB, then Memcached or Elasticsearch will be spinned off, and they are not priced as serverless because they run all the time. So this also will add up to your costs. If you do some remote calls outside from AWS, so you use something like PagerDuty or some other payment API. So if you wait synchronously, you will also pay for this wait time. If the provider has problems, you will also pay for this. So think about the timeouts or even asynchronous processing. And there are also third-party services which we use. We will talk about this for monitoring, for alerting, and they also have their own price model, and they also sometimes even all the time extract your data like from CloudWatch and so on, so that you pay outgoing traffic and also API calls for CloudWatch. Now we will come to one of the most sensible topics, and this is organizational environment. And what I mean by this is the structure and responsibilities in your company, knowledge, and also culture. And the first thing you have asked yourself, do you have DevOps knowledge or do you have classical system administrator? And they won't probably be too happy if you go serverless because there is no server and there is also no agent to install. So the question arises where they can provide value in those environments. And I really love the talk from Tom McLaughlin, who is also very known in the serverless community. What do we do when the server goes away? And there he talks about monitoring and alerting, and the application also consists of not serverless parts or even data center parts, but you have to have some general monitoring and alerting. And the DevOps people can take charge of this. Also, chaos engineering and organizing game days is part of the story. Infrastructure as a code should also be tested because there are some renamings and also deprecations, and this infrastructure as code, which is very essential, may break. So also these people can take care of this. And the probably most important part, they can help developers understand constraints of AWS services and choose the right one for now, for the near future. And only one example to mention, event sources like Kinesis streams, SNS, SQS, or even Event Bridge, you can use one of them or even the combination, and they have both. All of them have different trade-offs. For example, SQS and SNS are charged for requests, and Kinesis is charged for shards hours plus put requests. So if you have only one message per second with 1 kilobyte, then you see the pricing, and Kinesis is the most expensive service. But now if we will have 1,000 messages per second for a month and not one message, then we have a different picture. So now the Kinesis will be the cheapest one because otherwise other services are priced by number of requests. And this is the question arises, what is good enough architecture for now and for the future? And I think the op people are really great at understanding and looking at those constraints because they have done this for the servers, for the databases, for the storage, and so on. They are very, very sensible about this. But generally, and this is what Simon Wardley says in his map, if something has the evolution from genesis to commodity, and now the Lambda is execution framework, which abstracts away the execution environment of your language and even the web application server, it's now became commodity. Everybody can use this, but if you want to have success with this, then you will also experience co-evolution of practices. So you have to unlearn things and do things differently to be successful in this space. And we want to share with you some practice in which we think will contribute to your success. And the first thing is true DevOps or even DevSecOps. Below is the link to the team topologies, DevOps topologies, and the people who describe this, they describe best patterns, anti-patterns, devs working with ops. And probably the truth is, for the serverless world, the best practice is they have fully shared responsibility. So dev also do ops and ops also do dev, and ask yourself, can you implement this in your environment? Because otherwise, if you will have some separated DevOps team in the serverless, that won't work. Another thing is that the FinDev responsibilities should also go into the team. So they can track the cost of the whole application, even for individual functions or individual features or services. And cost optimization becomes also like a feature. So you can trade off this with security, with performance, or even with other features, and also show you there is a responsibility for the saving. How should I prioritize this? And this also should be doable in your organization. The chief financial officer will allow this. Complete infrastructure automation, I think everything is clear. Chaos engineering game days, we already talked about this. And with serverless, each team or even each developer can get its own AWS test staging account, because with serverless it's that cheap. You pay only for what you use plus storage, but you don't have too much storage capacity used in your test or staging environment. So you can do this, that the people test on the cloud. And what I really see, that there is no much local testing going on with serverless, or even only quick functional testing. And this is some kind of shift because developers like to debug. And this is possible with Thundra, with Stakery. There are solutions, but generally, when you test local, you can do this with same local and so on, but it's difficult to replicate the constraints of the services or IAM permissions and so on. So it's really advisable to talk in the to test in the real environment. And another pattern which I see, this is testing in production. So even if you have staging environment, you don't have too much traffic, too much data there. So real testing is only possible with testing in production. I can offer you to see this talk by Michael Brijik. The link is below. A lot of useful insights there. And what I also see that a lot of integrations with the third-party services are really used, and EventBridge allows this to integrate with PagerDuty, Zendesk, Shopify, and so on without using of webhooks. And then you can embrace a lot of solutions, software as a service within your solution. And this is really a nice integration. So now we'll go to another topic, platform and tooling maturity. It's really a huge topic, so I will only spend some time there. Ask for cloud provider infrastructure as a code. Is this mature or not? And for AWS, CloudFormation is really mature. What I really miss this is the integration of new features from the day one there. So you have to wait to fully automate. Also, CDK becomes mature. Terraform is probably not a very good fit for serverless, but otherwise also a very good solution. Development environment and framework maturity in AWS, you have SAM, you have Amplify, and also you have open source serverless frameworks. So a lot to choose. It's with this, it's a bit different. So CI/CD, probably the code commit is one of the weakest tools. It's way behind GitHub or Bitbucket, what feature richness and so on. And that's probably where the AWS may add features if they want this tool to be used by the community. Also, everything where we deal with observability and alerting, and I mean CloudWatch, they provide really good basic functionality. But if you would like to do more, to have more insights, to automate more alerts, then you will probably have to go outside and look for other software as a service solutions in this space, like Lumigo, Epsagon, Thundra. They provide really value, but this will add up to your bill. So then this is the question: can you afford this? It depends on how many lambdas and lambda invocations do you have. But generally, like PagerDuty is really good and mature solution for incident management. The same is true for security. Generally, if you are in the IoT space and you have MQTT and so on protocols, there are a lot of new vectors for the attacks. So PureSec and other companies provide also very mature solution there. And that's also the question how the AWS will proceed in this space. Will they make the tool mature, or they provide only basic, but they improve this? Even CloudWatch is really improved with search over many log groups, and even CloudWatch Insights or embedded metric format. So there are a lot of improvements, but they are still way behind other solutions. And also look if your cloud provider offers integration with third party. I've mentioned EventBridge, which really does exactly this for AWS. So that's all I wanted to tell you. I hope you enjoyed the talk, and I will be really happy to answer all your questions. Thank you very much.
Well, thank you, Vadym, indeed. And he is now here live with us for the short Q&A. Hi, Vadym, how are you doing?
Hi, thanks. Probably as everybody in these difficult times, I would say. If you have children, then you probably enjoyed them a lot in the last months at home. But I'm not very special, despite 3 children. How are you guys?
I think Zenke can confirm this.
Yes.
We're also doing good. Thank you very much. I think this was a very interesting talk. Thank you very much. We have now 10 minutes approximately for the live Q&A, and indeed there are already some questions in the chat. So the first one was by Markus Unger. I hope I pronounced the name right. And he wrote, only 3,000 parallel requests sounds very low. So is there a possibility to get that a little bit higher? What would you say to this question?
Account-wide limit. So you can split the functions across accounts if you have good boundaries and so on. So you will also reduce this. But generally, this is a soft limit. You can increase this limit even up to 10,000 and so. But as far as I know, there is another hard limit which says that you can only scale from the soft limit, for example, from 3,000 to higher only with 500 invocations in parallel per minute, something like this. So there is another limit you should consider, but generally you can increase this, and you have to think about the architecture, probably domain-driven design, different boundaries, and then different accounts, and then communicate between them via APIs and so on. So of course, and I think there are regions there, the limit is only 500, not even 3,000. So just a lot of consider. I hope
All right, thank you. I think this was a very in detail answer. Thank you for that. Paul also asked, is there a way to reduce the first connection time from Lambda to DynamoDB? The first query from a Lambda still takes around 100 milliseconds for us. Subsequent queries take 20 to 30 milliseconds. Have not tried DAX cluster yet, as it seemed like an overkill for a small app. Could you say something about that, about the performance of the DynamoDB?
The question I would ask, what programming language do you use? Because there is a known thing like enable HTTP keep alive for example, for Node.js and so on. This may reduce. I know that a lot of people which program Java with serverless struggle with exact this problem. And I know that there are a lot of tricks, I would say dirty tricks, because you can pre-initialize things in their static initializer block. And in this static initializer block, there will be the full CPU will be used for the 10 seconds. So you can speed up things. So you may make fake requests against DynamoDB to pre-initialize Jackson parser and so on, even if you don't need them. This is very dirty, but it enables you to, you reduce the cold start, and you spend a bit more in the static initializer phase, but there you have the full one core for 10 seconds. So depends on the situation. Probably the person who asked me can contact me via Twitter and so on, that we can discuss this in depth. Of course, you sometimes have this first request problem, which is how it works. Yeah. And that's
thank you.
Definitely overkill. Also, the latency is not that big. So, of course, you will probably overpay for DAX. Complexity.
Just a quick note on this. The Discord channel about this talk will stay online as well, so you can also get in touch with Vadym there for some follow-up questions. There has been another question by Jedray, I think I pronounced this wrong, sorry for this. He said, code commit may not be good use for DevOps. How about Lambda with code deploy?
Yeah, it's probably a very political question. Just I see a lot of folks which really use only code deploy and everything else by Circle CI with plugins and so on. So this is a very valid use case, because it's really, so you need code deploy because in the end you deploy cloud formation in some kind of, just with serverless and so on, this Terraform, SAM, in the end it's a cloud formation which has to be deployed. So this is of course valid situation. There are a lot of plugins, even by Jenkins, by GitHub, everything. So you can mix this up and not use everything with code suite of AWS. So this is just pretty valid.
Yes. Someone is writing right now in the channel, but I'm going to ask you anyway another question, because you again mentioned AWS. Your talk was very focused on AWS. Do you have any experience with other clouds in serverless, and anything that maybe works better on platforms than AWS? AWS, sorry.
Better is relative. So, I mean, no, I don't have any direct experience with Azure and so on. Of course, I hear a lot of things, and of course, we compare apples with probably oranges and so on. I know that you will get HTTP access to the Lambda for free in the Azure world, so you don't pay for API gateway or HTTP APIs. This makes things cheaper on this place, but probably more expensive on other places. So, but I don't have direct experience really with other cloud providers or even other solutions like everything on top of Kubernetes, which is serverless there, like trigger mesh and so on.
And a question from Sönke was if you have any experience with using Wardley maps with your customers?
I mapped this for myself and for my company to better understand the things. So I really enjoy the things, but sometimes, management requires strengths and weaknesses, so they are accustomed to other formats. But for us developers, it's really good, and I also really like team topologies. There you can map different cognitive load types to because the serverless, that's the topic of another talk from me, can reduce this cognitive load by delegating this to the platform. So we are trying to use these standards, or so-called standards, for ourselves.
Cool. So you have so you said you have another talk for this cognitive load topic. Cool. So if you can share it, please share it.
This is measure and increase productivity with the serverless. I gave it already last Friday on LWS Community Day in Germany.
Cool.
This was the second try, so we optimized according to the feedback. But this is somehow where I see huge value of serverless, especially because of reducing this cognitive load and this microservices world, which is really huge. If you can, you can go into the trap not shipping anything because of this cognitive load around. So that's why I really love serverless, and thanks for the invite to give the talk in the local serverless day. I would say for me local.
Yes. We are glad to have you here, and sorry, I'm not the moderator for this one, so I'm giving back to Jonas.
It's all good. There is some more discussion and some reactions in the FaaS channel on Discord, but no questions that I can see. But I can assure you that Vadym will stay online there and will also take part in the discussions there. So thank you again very much, Vadym, for this talk and for the Q&A. And I think you'll have some fun in the channel as well. And if there's nothing else that you would like to add, we would then proceed to the next talk.
Yeah. No, I'm done. So enjoy the rest of the day and other talks. There are really great speakers invited there. Hope to see you in person next year.
Yes.
Yes, hopefully.
Indeed.
All right.
See you soon. Bye-bye. Thanks again.
Thank you, Vadym.
Thank you.
Okay, then I would say let's continue with our next talk, and this is from Nicolai Buchwitz, and he has a background in industrial monitoring, and what I found very interesting on his biography is that he helped building a monitoring solution for all hydrogen filling stations in Europe, which sounds very futuristic. So, and now he will talk about a little bit other topic, and it's called Smart Garden 4.0 with AWS IoT and serverless. And I think this will be really cool, and we will see some really nerdy hardware stuffs there. So I'm very excited, and I would say we are on time. So let's go.
Welcome to this year's edition of ServerlessDays Hamburg and my talk Smart Garden 4.0 with AWS IoT and serverless. My name is Nicolai Buchwitz and I'm a technical product manager at Cthulhu. At Cthulhu, we develop serverless industrial IT solutions since 2018. We are based in Hamburg and do strategy and technical consulting, as well as development on AWS, Azure, Kubernetes, and also evaluating IoT business models for our customers. We are an AWS consulting partner and known for the development of the KSB Guard. The KSB Guard is an IIoT condition monitoring platform for industrial pumps. We developed for one of the biggest manufacturer of industrial pumps, KSB. Our mission for the future is the development of Cthulhu IIoT OS, the operating system for the digitalization of the industry. I think we can all agree that this year has been pretty crazy so far, and we had all plans for this year, which turned out different than we expected. And so we mostly stay at home since March and don't know until when, but we have to make it best of, right? So you have to stay and can't travel. What can you do? Time for a new hobby at home. So start gardening. Could be at home on a balcony or terrace, or if you're lucky enough to own a garden, in the garden. Grow your own vegetables. Build a green and relaxing oasis where you can stay and enjoy your holidays. This is what we are dreaming of. Green grass, fancy flowers, lots and big vegetables, and mostly without any effort and time spent, right? But the reality might turn out disappointing. So if you forgot about watering the plants or give them too much water or have any animals which shouldn't be in your garden, it could be very disappointing. Trust me, been there, done that, and there could only one solution. Automation to the rescue, because humans are lazy, and so maybe that's why we invented technology. And of course, we all work in IT, I guess. So what could be the easiest solution for us, right? To use some of the technologies we use for our day-by-day job and try to make our garden smart. For making our garden smart, we will use AWS IoT. So I will start with a quick introduction. What is AWS IoT? Introduce some of the important features. And in the second part of my talk, I will talk a bit about the solution I used to make my garden smart. What is AWS IoT Core? AWS IoT Core consists mostly out of 6 big components. The first component, identity service, then device gateway, a message broker, a rules engine, device shadows, and the registry. What is the identity service? The identity service handles all the device certificates and also is responsible for the provisioning and just-in-time registration of your devices which you want to connect to AWS IoT. For the certificates, it can use your own certificate authority. So if you have one, you can use it, or you can AWS IoT let handle all stuff for you. It also handles so-called device policies. Device policies are mostly like access control lists and configuration, which device can publish which kind of data and access which kind of service. And so you can have fine granular control for your devices. This is an example for an AWS IoT policy, which allows the device to publish under a specified topic, which is in our example DT for device telemetry, then greenhouse, and in the third part, it can use our client ID. So it's only possible to publish under this topic and nothing else. So our tomatoes can't publish for like our pumpkins. And also This IoT policy allows to subscribe to a topic, which is used to control maybe some relays or other stuff which are attached to our device. The second component is the device gateway. The device gateway handles all the device communication and does the encryption to devices. And the communication can be implemented with 3 different ways. So I think most of you will use MQTT for device communication, but it's also possible to use HTTP, WebSockets, and integrate a broad spectrum of devices with AWS IoT. The message broker is responsible for handling all the data in and out, and it's built around MQTT. MQTT is a very scalable and lightweight protocol, and also easy to implement. So lots of fancy and cheap microcontrollers supporting MQTT out of the box. Also industrial IoT gateways, routers, toys, and you find MQTT in a lot of devices. AWS has built a scalable and high available MQTT message broker, so you don't have to run this component on your own. It's a managed component, and it's perfectly integrated into AWS IoT. MQTT is basically the protocol of Internet of Things. It's also used in the industry all over America and other continents on the world. MQTT is the standard protocol for transferring data from devices to a cloud and the other way around. It's an ISO standard, and it follows the publish and subscribe pattern. So basically a device can send metrics to the cloud, but also subscribe to certain topics and receive like commands or updates. It has a customizable topic structure, so you can choose your own topics and align it to your needs, or maybe build up your hierarchy in the device topics. This is an example how communication with MQTT looks like. We have in our example 3 devices. One is a door, which has like status for a lock, which can be closed or not closed. We have a bike, which transmits a location, and also a coffee maker, which sends the fill level of the water tank. So we have a basic component in our topic structure, which is home. Then our client ID, which is the first example of our door lock, door, because the device is named door, and an attribute which is called lock. And so our full topic would be home/door/lock. The same goes for the bike, home/bike/location, and also for the coffee maker, home/coffee maker/water tank. The rules engine is a very powerful component when it comes to doing something with data. It's an SQL-like language for filtering and enriching your IoT data, and it's based on the topic structure we've seen before. It has full JSON support, so you can manipulate your JSON data structure. It has functions for date, ID, mathematical operations. You can modify timestamps, convert it, add time zones, and so on. You don't need a Lambda function for this. It all could be done in this kind of SQL-like language. The rule engine allows you to connect your IoT topics with different subscribers, like a Lambda function. You can send it to an S3 bucket, to a Kinesis data pipeline, use it in other services, and there are a lot of possibilities. To filter the data we want to use in our IoT rule, we can use the SQL-like query language. So basically, we select something data from something topic, where something filter. The last part with where and filter, we can spare if we want to select all data from a specified topic, but in most use cases, we want to filter by a certain condition. So in this example, we are selecting the timestamp. and also a star. Star is a wildcard operator which matches all of our fields in our data structure from the topic telemetry / hashmark. The hashmark is a wildcard operator which matches all levels of topic which comes after telemetry. So it would match telemetry / tomatoes / environment, or telemetry / water pump / sensor / rotation, and everything we could imagine. The next example, we basically select all data from our data structure. So we use this asterisk and say, okay, we want to select every data from telemetry, greenhouse, tomatoes, where the soil moisture is below 60. So only data would be selected which contain a field called soil moisture, and also only if the soil moisture value is below 60. In the third example, we select a field called sensor ID from our topic telemetry /+ environment. The plus sign is also a wildcard operator, which you can use to filter your topics. The difference to the hashmark operator is that the plus sign is only for one level. So it would match telemetry / tomatoes / environment, but it would not match telemetry / tomatoes / temperature. So it has to match telemetry and also environment, and in the middle, one level is matched by the wildcard operator. And also we are selecting only devices on sensor ID from it, where the temperature is higher than 30 degrees and also the humidity is higher than 90 degrees. For more information about the possibilities with the IoT SQL language, you can check out the documentation on AWS. There are a lot of examples and explanations on which functions you can use and how to modify data. I can say it's quite powerful. So in most use cases where you want to enrich your data with a Lambda function, maybe it could also be done in the SQL language, which costs no invocation of a Lambda function. This is an example how an IoT rule could look like. We have a payload on the left side, which mainly consists out of two fields. One is the temperature, which has a value 33 degrees, 0.5, and also humidity. And this is sent to our AWS IoT core engine. And we want to have a rule which saves the temperature and the humidity in an S3 bucket. So we have a SQL statement which selects temperature and humidity from a topic called DT for device telemetry /greenhouse1 /plus. So every device under this topic could be DT /greenhouse1 /tomatoes or /pumpkins would match this. And we say, okay, we want as an action, I want to store the data in a bucket named greenhouse bucket, and our key should be greenhouse key. So this could be a very easy example to persist your sensor data for further processing, or use it in an application or data visualization tool of your choice. The device shadow is a quite powerful feature when it comes to interaction with devices. The device shadow is basically a virtual, mainly JSON representation of device state, and it always is accessible. So even if your device is offline, it is possible to get the latest state of your device, and also when was the last update. And you could also set device status, because if you have a device like a pump controller or a low power device, and it's not always online, it could be hard to communicate with this kind of device, because application developers want to immediately send data to a device, and it should be persisted somewhere. So this is where the device shadow comes to rescue, because we can say, okay, in our device shadow, we want to turn on the fan or pump, and if the device is not connected, it's okay with us. The next time when the device comes online, it gets data from the device shadow and sees what the desired state is, and can turn on the pump or the fan. It also notifies the application and devices on updates. So if you have developed an application, you will get a message, okay, device is online again and has applied the certain attributes you ask for, like turn on the fan or pump. There can be one, it's called the classic device shadow, which has no specified name, or you can even have with newer versions multiple named shadows. It depends on your use case. Mostly one unnamed classic device shadow should be fine, but there are some certain use cases where it could make sense to have multiple named shadows, maybe for restricting certain attributes to certain applications. And yeah. There's a device SDK for, I think, a lot of programming languages. I mostly use it with Python, and also there's some C++ for running on microcontrollers, and it does mostly all of the work you need for interacting with the device shadow. So basically, it's publishing a JSON data structure with MQTT to a certain topic. This is an example how a device shadow data look like. We have in the first part, we have an attribute called state, which also contains 3 child attributes called desired, reported, and delta. The desired state is what our application has told our device shadow. So we want that the fan is off and the light is on. The reported state from our device is that the fan is running, so it's on, and also the light is on. And it immediately calculates the delta of the 2 states, and the delta state is fan on. So this can be used for the device to see, okay, since my last update, what has changed, what actions I need to take. So we also have the version, which is incremented with each update, and also a timestamp of the last update. There's also a client token, which can be used for securing things. The device registry helps to manage all your things or called devices. You can build like a hierarchy with groups and organize all your devices. You can assign policies, which we talked before, to things based on attributes or groups, and also have custom thing attributes like location, firmware, factorer, or model, which helps you to organize your device structure. So let's talk about how you can use AWS IoT to make your garden smart. Basically, we have to decide, okay, what we do have to monitor to have a helper in our garden. So one interesting metric could be the temperature, because it's very easy to get. We can monitor soil temperature or ambient temperature, which could be interesting for notifications, because we really don't want to turn on the irrigation in winter when it's very cold and the soil is near freezing. So could be an interesting metric to keep track of this. We of course want to monitor the soil moisture, because it's one of the most important metrics, because it's very easy for us to determine if plants need water. If we have something like a water tank, because we have tap water, then we can use like a sensor for the filling level of this water tank. And maybe we want to monitor the lighting situation. So imagine a greenhouse and you have a lot of plants in there, and also some illumination. And maybe if it's very cloudy for days and you decide, okay, plants need some light, you can turn on the illumination based on this kind of data. To build this, we can use lots of different hardware solutions. One of very cheap solution could be the popular Espressif ESP platform, which is mostly the older, the ESP 8266, which is less powerful, and it's requires some more work regarding the TLS implementation because it's not natively supported. But with the more powerful, the ESP32 microcontroller, this is also possible and integrated in all the libraries you have to find. It's very cheap. The ESP8266 is very cheap. I think it's around €3, and the more powerful ESP32 you can find for €5 to €8 on Amazon Retail. It has wireless LAN, so it could easily be integrated in your greenhouse. You only need some wireless LAN connection set. Also, Bluetooth is possible, so you can integrate sensors with Bluetooth if you find something. There's digital output, analog I/O, I2C sensors. There are a lot of popular sensors for temperature, humidity, lighting, and so on. Already talking I2C. So you basically need power connection for a sensor and 2 cables for sensor communication, and you can daisy chain all your sensors. So it's very easy. You only need 4 wires for your greenhouse, maybe. Also, there's a serial connection. If you have something which has a serial interface, you can attach it to a microcontroller. For example, I have a solar controller which charges a battery with solar panels on the roof of my garden house. This is connected via serial cable to an ESP microcontroller, and so I'm monitoring the yield of the solar energy I can use for watering my plants with the pump. So I can switch on the pump if it's very sunny, because the pump requires lots of energy, and so I can connect things. As I mentioned earlier, there are a lot of cheap sensors for temperature, soil moisture, light, and also relay boards. So you don't have to solar it by your own. Most of them are ready to use and connect with ribbon cables also. This is an example I built with a prototype board, which consists of 3 sensors. On the left, we have a popular BME 280, which is very simple and cheap sensor. Maybe not so cheap, but around, I think, €3 or €5, but it's affordable, I think. And it monitors temperature, humidity, and also air pressure. Air pressure is anything I'm interested when it comes to my garden. So it's maybe interesting when it comes to monitoring the position of some devices or the height of something, but not for our garden. So I only use temperature and humidity. There's also a BH 7050, which is a light sensor and gives me the current lighting situation in lux. And also I connected a capacitive soil moisture sensor. Beware of the cheaper ones, because mostly the cheaper ones, which have basically 2 legs and measuring the resistance to soil moisture, they start to rotting early and fading. So let's invest the €1 more, which the capacitive soil moisture sensors cost. So it's a good investment, trust me. With this prototype board, I attached an ESP microcontroller. I introduced last slide and implemented a small application which sends this kind of data. We see on the right side, which basically is a device ID and an attribute called data, which consists of the sensor data. So we have the light, which is 110 lux, temperature of 26 degrees, humidity of 36%, and soil moisture is given in volt. So it's around 2 volt. You have basically to experiment a bit which voltage means wet and dry. So it could be easily done. Take a glass of water, put some sensor in, write down the sensor value for dry, and also do the same with wet. This is how the sample application on my ESP microcontroller looks. I skipped some non-essential parts. So basically, we do some Wi-Fi connection and also set the certificates for AWS IoT. And then we say, okay, want to connect the AWS IoT endpoint. 8883 is the point for encrypted communication. And in the method called loop, we basically publish every 60 seconds a payload, which here only consists of temperature, which is a fixed value because, you easily can figure out how attached the sensor you may have lying around. So you can use this kind of template to implement your own device. But there's more than cheap microcontrollers. As I mentioned earlier, Cthulhu is a company which is specialized in industrial IoT. So we're used to powerful IoT gateways, PLCs, and all the fancy stuff which is mounted in industrial plants. And there's also a solution to connect this to AWS IoT. We can see on the left side the nice orange boxes, which is called the Rev Pi, which is short for Revolution Pi, which is an industrial IoT gateway, which runs a Linux distribution, and you can basically do anything you want because there's a nice Python implementation which easily allows you to connect with the digital imports, analog imports, field push protocols, and so on. And we installed AWS Greengrass on it and called it Industrial IoT Gateway on steroids because it's very powerful. What is AWS Greengrass? I haven't introduced it so far, so let me quickly introduce it to you. It's basically a software component you install on an edge device, which runs Linux. You can run Lambda functions locally. So it's in some use cases, you need edge computing power because you maybe want to interact with devices attached to your device, or you have some secret algorithms you don't want to see executed in the AWS cloud. So you can run this kind of Lambda functions locally on the edge device. You can isolate the Lambda functions with containers. So if it's not necessary, there's no interaction between all the components. It helps with the implementation of all communication and security. So everything with device shadow and so on is also abstracted by a nice device SDK. You can also manage your deployments and the over-the-air updates with AWS Greengrass. So basically, you publish a new Lambda function on AWS, say, okay, I want to make a new deployment on our edge device, and then magically, the new Lambda function is deployed on the edge device. In the background, there's some communication channels, and so this is how it's done. There's also a local device shadow, which keeps track of all the data model changes we have maybe. And there's also the possibility to interact with the local network and so on. And even if your device has no internet connection, the Lambda functions still run. So if you have like a not so great internet connection at some rural areas, or it's not possible to have 24 hours, 7 days a week internet connection, AWS Greengrass, it's perfect fit for it because you can basically do all your IoT stuff and it will submit the data to the cloud when internet connection comes available. There it's the main software component, which is called Greengrass Core, or short GGC, and also an IoT device SDK in various languages, so C++, Python, JavaScript, and so on. So you can develop your Lambda functions in a language you want to use. This is how AWS Greengrass fits into the big picture. On the left side, we have all our on-premise stuff like our device shadow or local Lambda functions, over-the-air updates, and it communicates with MQTT into device topics with the AWS cloud, where you can store it in S3, DynamoDB, do other Lambda processing, process it further in IoT topics to analyze with QuickSight and so on. So to run a Lambda function locally, you just need to start the device SDK you mentioned earlier, and then run this kind of Lambda function, which can be a long-running Lambda function, which steadily runs, and you have responsible on your own to manage the intervals and so on. It could also a Lambda function which is called by the green grass daemon in a specified period. So in this example, it's a long-running Lambda function which is basically running every 5 minutes and publishes to a topic called DT greenhouse 1 environment and sends a sensor data which comes from a strict sensor called temperature sensor. This is how my implementation at home looks like. At the beginning of the year, I started to build a small hardware box, which basically consists of one RevPy core module and also an analog card and a digital input module, relay for switching my 230 volts pump, energy meter, and also a push button for manual start of irrigation, and also an LED which signalized me or other people in the house that the water tank needs to be refilled. LED is not optimal when it comes to laziness, because I am not always checking for a red LED on my balcony. So I want notifications. How can we do notifications with AWS? So we can do notification with SNS topics. So basically, if we want a notification, if our soil moisture drops below 60%, we define in our SQL-like language a match for this. So we select our soil moisture from our device shadow in this example. So with the data structure we have seen earlier, which is state reported soil moisture, we name it soil, and also select the third part of our topic, which in this case, this is our device, from a topic which matches the device shadow. This kind of $AWS things /+ for our devices, then shadow, because we want to access device shadow, update and accept it, and only the data where soil moisture drops below 60. So with this, we have selected all the events we want to process, and then we send it to a Lambda function. This Lambda function does some additional processing, like prepare subject of the notification and also some explanatory text, and then we send it to an SNS topic, and the SNS listen to this kind of topic and send messages to all subscribers. Subscribers could be email, could SQS, could HTTP, it could be Lambda function. And yeah, a colleague of mine said, okay, with a Lambda function, you basically can send a man to the moon and notify someone there, because you can do every notification you could imagine with Lambda function, because you mainly can do everything with Lambda function. And because I also use the Messenger Telegram a lot, I said, okay, I'm not really want a notification via email, because I'm getting so much emails and could be quite problematic to keep track of all the emails and find the right notifications between the other stuff. So I decided, okay, let's use the Messenger Telegram, which also has a very nice documented API. And I built a bot for this. On the right, you can see some of my notification, which my home automation with AWS IoT sends me, like the first one, which reminds me that the fill level of my water tank is below 40%, and asks me if I would be so kind to refill. Also, it notifies me if the irrigation was started and stopped, and also sends me a warning when the irrigation was stopped, the pump was stopped, because the filling level of my water tank drops below 50%. This is how we could send notifications to Telegram. So basically, it's the same structure we have seen earlier with our notification with SNS for an email. So we just attach a new Lambda function, which listens to our same SNS topic and send the message to our Telegram API. So basically, with this architecture, our notification would be sent to our email account, and also to Telegram via this kind of custom Lambda function. This is how a quick Lambda function for this kind of task could look like. Basically, we're using Telegram API with our secret token, fetch the message from the SNS topic, and then send the message to my Telegram chat ID, which I also, like the token, have specified in environmental variables in my Lambda call. And then it basically sends a payload to the Telegram API and do some logging if the message sending fails. So I can see in my logs what is wrong with my Lambda function. There could be also more integration with Telegram, because I could easily send messages from Telegram to my AWS IoT and execute some things like start the irrigation. And with this, I have a basic architecture which consists of an API gateway and also a Lambda function, which is connected to this kind of API gateway. And so I can send a command with Telegram to the GraphQL API. This is processed by a Lambda function, and this Lambda function interacts with Greengrass via the device shadow and tells Greengrass, please turn on my water pump, and then the RefPy can switch on the relay, which switches on the water pump, and then my plants get water. This is an example how the communication could look like. I basically can say, okay, hello, here I am. And then with irrigation, I can start watering my plants. I'll get the feedback, okay, I got the command, plants are watering, and also decide, okay, it's enough, I can say stop and ask, how's the soil moisture? This is my water tank I have on my terrace. You can see also a flow meter, which gives me the current flow of my irrigation, some pipes, a lot of plants, and now plants get water because I turned it on with the Telegram command I showed earlier. And everything is connected with small pipes. It's called Gardena microdrip. It's perfect for automation. Also, if you're on vacation, you can easily put it in every plant. Don't have to go with a hose and put water in each plant. So, already stopped. But we also maybe want to store the data to analyze it at a later stage. What I've done, I basically have some IoT rule which selects the data I want to persist, a Lambda function which does some transformation and enrichment of my data, which runs in a Kinesis firehose, which is directly connected to a S3 bucket where all my events are persisted, and then attached AWS QuickSight for data analysis station. I don't know if you know AWS QuickSight. AWS QuickSight is a very powerful tool when it comes to data analysis. It's quite similar to a tool called Tableau, which is often used for business analytics and other topics. And AWS QuickSight is nicely integrated in all AWS solutions. So basically, I used an S3 bucket with my sensor data and connected it. And so I can build graphs and do analytics on my sensor data and find maybe some problems or some patterns and get to know my plants better. So in this example, I visualized the humidity and the temperature of some sensors. You can see humidity and also a temperature spike. So I guess, I closed the window or opened the window or something similar. So I would say mission accomplished. That is my garden at the current stage. Everything is green, everything starts growing. There were a lot of tomatoes and chilies this year. So I guess AWS IoT was the right choice. And So now I can easily go to vacation and also control my garden and get notified if something gets wrong. What's next? You could easily implement this kind of solution with a weather forecast. So irrigation won't be turned on if it's raining. You can do reporting on long term, how much water I spend on a certain plant. I can connect machine learning to find the right amount on light, water, and other metrics for a specific type of plant. And of course, also extend the solution with like a custom solution, which puts a fertilizer in every plant with a well-defined schedule. Or I could also sit back and relax and enjoy the time I have now and can sit in the garden, maybe have a beer and enjoy the sun. So thanks for listening. I hope you learned some insights on AWS IoT and how it could help you to make your own garden smart. If you have any questions, feel free to reach out to me. You can find me on Twitter. Nicolai Buchwitz is my name there. And also you can write me an email, of course. It's nicolai@cthulhu.io. Also, if you're interested in our company, you want to see what we are doing, or maybe want to check out our job offerings, please visit our website, cthulhu.io, or also write us an email or follow us on Twitter. If you have any questions, feel free to ask, and I'm happy to answer.
So, yes. Hello and hi. We have Nicolai live on stage now for questions. Hi, Nicolai. How are you doing?
Hi, everyone. I'm doing fine. Hopefully you too.
That's great. So yeah, we have a couple of questions. Unfortunately, we don't have that much time, but I think I picked two of them, and I think you can then answer the other ones in the Discord channel. So the first one would be from Nick. So if you want to start a small project on AWS IoT, where would you start?
You have basically some choices. One of the easiest choices, because I'm a hardware guy, I would buy some ESP microcontrollers and put some software on it and send MQTT to AWS. But you could also, if you want to start with Greengrass and a more abstracted way, you could spin up an EC2 instance, install Greengrass on it, and use this sensor and generate some dummy data with it. There are also a lot of resources on AWS IoT with cool example projects I will check out.
Okay, yeah. So maybe you could put the link to this example projects in the Discord channel. And the other question I had is, so how, this more technical, how are IoT devices authorized to send data to IoT?
Yeah, the authorization is handled by the IoT policies I mentioned earlier in the general part about AWS IoT, and there you could specify topics where sensors are allowed to publish and also to subscribe, and which parts of the device shadow can be used and so on. This could all be done within IoT policies.
Okay, nice. Thank you. So there are a couple of more questions in the Discord. I think Nicolai will stay there for a bit and answers your questions there. Unfortunately, we don't have time for more live Q&A, and we are now having a short break, and then we will be back at 11:15 with the next talk. Yes, so
that's correct.
See you in a couple of minutes, and get yourself a beverage of your choice.
Okay, see you. Bye.
Bye-bye.
Thank you. So, welcome back, everyone. We hope you had a nice little break. I think this is working. There was a strange notification, but now looks all good. Sönke, can you confirm? Yes, all right.
Yes.
Good. Yeah, then welcome back, everyone. Just a quick note, if you want to check the agenda, so to say the schedule for today, you can go to the homepage of ServerlessDays Hamburg. There's also the link in the comments and see when exactly the breaks and the talks are. The next talk is going to be by Nick van Hoof. Nick van Hoof is a software consultant from Belgium who works in the field of cloud technology and AI as well. His talk is called Monitoring Serverless Applications. The monitoring monster becomes your friend. So this is all about how to monitor serverless applications, and because this is a special task because serverless is so distributed. Nick offers some solutions so there won't be a bad awakening to a monster lurking around. We're very happy to have Nick, and let me just pull up his talk. This will just be a second. There we go.
Hello, everybody. Welcome to Serverless Days Hamburg, and welcome to this session about monitoring and observability for serverless applications. I'm very excited to be here. I hope you are too. Let's talk about serverless monitoring and observability today. But before we're talking about that, let's talk about me. So who am I? I am Nick van Hoof. I am a cloud developer working at Cloudway, and I have been using cloud technology, serverless technology from AWS since 3.5 years in production now. And I am here to share some of my experiences with that. So let's go ahead and let's talk about serverless monitoring and observability. Now, what are we going to talk about today? Today, we will be talking about tackling the monitoring monster. And who is that monster? That is the guy that comes out when they call you at night, telling you that there's a problem, that you have to fix something in production very urgently. And you know that observability is a mess, that it's very hard to get insight in your production system, and it will become a very long night. So we want to avoid that, and we want to slay this guy. And this is exactly what we are going to look into today. So how are we going to do that? Let's talk about, is there a hidden danger for serverless architectures? I think there might be, and we'll get to that in a minute. From that, we'll go to the nature of serverless apps and the observability challenges that come with that. And then for those challenges, of course, challenges are there to be solved. So I will try to offer you some solutions for the challenges. Then there are also some third-party solutions, which we will go over very shortly. And then we will evaluate everything that we have learned so that we can slay the monitoring monster. Okay, so let's get into the application that I will use today to demo this all. This application contains some example code, and the code is available on my GitHub. The links are at the end of the presentation. And you can follow this link to go to the presentation, the application that we will use today to showcase everything. It's basically an application for people who are at a conference, and be that as it may, I guess you are one of those people today, and people learn something at a conference, so they can store what they have learned. They can create a new learning that will then be saved in the database. A Slack notification will be sent out containing that learning, and you can also retrieve all of the learnings via the API. So let's now go and look at the application. Voila, here it is, and we see that this guy, Nick, has already learned something. Do not forget observability for service applications. Well, okay, I will not. So let's create something new. Remember, Lambda Power Tools is a great tool. Voila. we will see that in a few minutes why. And then, yeah, this is the monitoring observability session. So the category is cloud, and we will submit that session. So it has now been stored in the database. It's been retrieved via the API, and we should also have received a Slack message. And indeed, we have. So that seems to be working fine, and that is the example application that we will use today. So going further from that, talking about serverless and the challenges that come with it, let's first talk about serverless and its nature. So serverless unleashes the power of the cloud. And I really think this is true because serverless provides you with all these off-the-shelf components that you can glue together with lambdas or just directly, allowing you to go very fast and have something working in a very brief period of time. Of course, do not get ahead of yourself, because when you can go that fast and have something running that quickly, people often forget that observability is still important. And that is why I'm here today, to tell you some of the war stories, some of the challenges I had to go through, finding that out myself, and telling you how I fixed those challenges. So, challenges, you say, well, those challenges come with the nature of serverless applications, and one in that nature of serverless applications is scalability. So before we had one guy working, one application doing his thing in one place, generating all of the logs and all of the metrics in one place. Now we have a lot of guys working concurrently, doing the work for us, generating metrics and logs together concurrently, coming from a lot of different places. Add to that serverless applications are by nature very distributed applications. Look at this architecture, just a small example. Often a production application will be even bigger. And you see directly that the application is highly distributed and a lot of things happen in a lot of places at the same time. So observability becomes a challenge because so many things are happening at so many places. But of course, we are here to deal with those challenges. We are not talking about problems anymore. In these times, we're talking only about challenges, and we offer solutions. So let's build a backpack of best practices and a toolbox of instruments that we can use to then slay that monitoring monster and to provide observability in our serverless architecture, our serverless systems. Well, let's get into the 6 challenges that I ran into myself, the things that I found out going through the trenches, and that you hopefully, if I tell them to you today, you won't run into anymore. So let's dig into them, and let's start with the first one. The first one is about finding the right logs and searching them easily. Well, imagine for a moment that the people, they call you at night or in the evening or even during the day, there is a problem. And the first thing we all do, right, it's, oh, let's check the logs. But we saw that so many logs are generated in a lot of different places and things are happening in a lot of different places at the same time. So how can we find the correct logs? We have this bunch of logs that we now have to search to pinpoint our problem or to find some information about our problem. Well, there is something that can help us with that, and that is structured logging. So structured logging to the rescue. And what is structured logging? Structured logging, well, let's first look at a normal log, which is just plain text. And you see, there's a timestamp and then a UUID and saying the message validated. Okay, let's just plain text string on one line. Well, let's now look at a structured log, and you immediately see, wow, yeah, this is indeed highly structured. It is a JSON format, and we recognize keys with a certain value. Well, we are not the only ones recognizing that. The computer is also recognizing that. So if you log in a structured format, then the computer will be able to pick up your logs and to read from them. So the logs, they actually become machine readable. And if they are machine readable, that means that we can now search the logs with certain tools. And those tools, and they can then search the logs which now also include a lot more information. Well, what information you say? For example, we can add some extra keys in the structured logs. Here, the AWS request ID or the function name. Making a small sidetrack here, the AWS request ID that is uniquely identifying an execution of a function on AWS. Well, we can also add even more information in there. For example, some functional information of where in the process we are, or we can add a log group or a trace ID in the logs. Well, now that we have these structured logs and we log in a JSON format, we need some tools to analyze these logs. And AWS is offering us such a tool that is CloudWatch Log Insights. So CloudWatch Log Insights enables you to explore, analyze, and visualize your logs instantly. Well, let's take a look at that. We see that this small mushroom has appeared here in the bottom, which means that there is a demo coming. So let's now look at CloudWatch Log Insights. I go into the CloudWatch console here, then I'm going to logs and to insights. I already stored a query before. So a basic example of log insights, we see that there's a query here. I'm going to run the query. The query gave me some results. So I was looking through all of my logs from the create new learning function. I was looking at where the cold start key is 1, so indicating that it's a cold start, and where the session is monitoring and observability, which is the session you are in right now. And indeed, it has found me some logs. You see that there were actually a lot more logs, but it only found those 4 because it was able to pick up those keys from the logs. You say keys, yes, indeed keys, fields that it picks up from the logs, and you can find all those keys right here. You can use them in your queries to build queries with. And you can also, I have here only used one log group to query, but you can add multiple log groups here so that you can correlate between multiple log groups. Now, if you like your query, you can save it here and then reuse it later, or you can add the result of your query to a dashboard. And then it will here arrive in the dashboard, something that we will come to later in this session. So far, log insights. Log insights, it's not the only option. You can also use Splunk or Elasticsearch to stream your logs to and then analyze your structured logs. Now, with that, we have solved our first challenge, and we add to our backpack of best practices, we add structured logging. And to our toolbox of instruments, we add CloudWatch Log Insights and Elasticsearch. Or Splunk, also something that we could add here. First challenge solved. Let's now go to the next one. Challenge number 2, which is linking a technical problem to a business impact and vice versa. Well, imagine that you are watching your application metrics and you see that something has gone wrong. You find an error log or you find an error metric. So technically you know that something's wrong. But which business process is impacted right now? You might not know which order is impacted, which container cannot leave the station right now. Yeah, that's something I would like to know because I would like to know the business impact of this problem. Might also be the other way around. Someone of the business approaches you and tells you something is wrong with this container. Here's the container ID. Well, if you never correlate your logs with your container, you won't be able to find the correct the place where the problem occurred. So we need to correlate that. And again, we go there to structured logging. Structured logging can again help us here because we can add a business key to the logs. For example, something that has a business meaning, in this case, the session. I want to find all the logs that have something to do with this session. Well, then I am adding the session key, monitoring and observability, and I can now query using CloudWatch Log Insights or using Splunk Elasticsearch to find everything, all logs related to this session. To do that, Well, yes, I have been talking a lot now about structured logging and how it can help you. But how would you actually set up structured logging? Well, of course, that is language dependent. So I've done it in Java, Python, and Node before. It was a little bit harder in Java than it was in Node and Python, but maybe that's on me. In Python, you have the library Lambda Power Tools, which will make things very easy for you, which I will showcase in a moment. You can find more information following this link. And you can also find more information about structured logging and the need for it in AWS Lambda in this article here by Teri, who was already speaking about this in the beginning of 2018 when we were still learning about Lambdas. He was already preaching about the best practices for structured logging. Well, let's now look at how to set up structured logging. Small demo here. So let's go to the code that is available for you on GitHub. So don't mind copying anything. So I already told you I'm using Lambda Power Tools, which is a Python library, and I'm just importing the logger. Now, using that logger will automatically cause the logs to be structured. So nice, we are already there. I already have structured logs. This will be a structured log. You saw or you noticed that I was talking about adding a business key to the logs. So let's look here where I do that. For example, here I say, well, I want to add to my structured logs. I want to append something to it. I want to append some functional information about my session. So I want to add a session key, and I want it to contain the value of the current session. So now this will be included in all of my logs. Very nice. We now have structured logging for our serverless application, and it didn't take that much effort because I used the Power Tools library. Back to the presentation. Challenge number 2 solved. Again, because we used the best practice of structured logging and because we used Lambda Power Tools to set up this structured logging in the code. Of course, in Node and Java or other runtimes, you won't have Lambda Power Tools, but you'll need, you can also configure structured logging, of course. And so we come to challenge number 3, which is locating the original source of the problem. Yeah, we already saw the landscape was highly distributed. Things are passed along through our landscape, and something might go wrong, but the problem might not be originating from where it went wrong. No, it might be in the data that originally came in via the API. And then when we tried to save it further in the flow, then we had a problem. So we now need to trace this request back to the landscape to find everything that was impacted and find maybe the order from which it originated. Now, this sounds like tracing, and yes, it is tracing. So we will have to trace our request to the landscape. And you can set this up yourself. So I have done this in the past. It took a lot of effort. I will tell you why. You see that we have to pass along this trace ID from Lambda to Lambda over AWS components. So we create a trace ID here, okay, and then I have to pass it as metadata or message attributes over SNS and SQS. Then here I have to trace over DynamoDB. DynamoDB doesn't even allow for metadata. So I have to add another DynamoDB just for my trace IDs or what. So it becomes quite complex. That's why I say use a third-party tool for that, or use an AWS service that supports this. If you want to do it yourself, you can add a trace ID to your logs and then use your logs to trace requests through your landscape. Tracing can also be used to identify performance bottlenecks. So find the places in your flow that are imperformant. Well, okay, we will see an example of that in just a minute. Tools to set up tracing, that is, AWS provides us with X-Ray. You can do your own tracing based on your logs, or you can use a third-party observability tool, which will do all of the work for you. So let's now take a look at the X-ray service that AWS provides for you to do tracing within serverless applications. And this is, when using X-ray, you will get a result like this. And what we see here is a request comes in via the API. Someone has learned something at a conference and wants to create a new learning. So we'll arrive in the Lambda function and it will store the learning in the database. Remember, now we will send out a Slack notification. So we would expect, or we would like to see here, that we now trigger the Lambda function. Unfortunately, X-ray doesn't support this yet. And so the DynamoDB will turn up as another client, a client of the Slack notification function, which is the flow that we see right here. Of course, X-ray is not only meant to do the tracing of the request to your landscape. It has another very interesting capability, which is getting insight in those performance bottlenecks. So that's what we see here. When someone is creating a learning, I want to know how much time does it actually take to execute my handler function. Well, so I'm going to trace my handler. That's what you're seeing right there. And I think it might be imperformant. It's probably the validation. Let me also trace the validation method. Well, I was wrong. You see, that's a very small block here, the validation. So it's not the validation that's taking a lot of time. It's actually the HTTP call to DynamoDB, which is taking up most of the time. Of course, here we see the timings are very small. It's actually quite performant. But this way, you are able to see which steps in your process takes the longest. Now, how did I do that? Again, this is a little bit runtime specific. Something that you have to always do is include the X-ray library and then wrap your SDK with X-ray. If you're now going to look into the code, you're going to see that I used, again, Lambda Power Tools for this. So this is a Python-specific example. And I set up a tracer, and I told the tracer to capture my Lambda handler, which is the handle method that we saw on the previous screen. And then I also told you that I wanted to know how performant is my validation. So I told the tracer to capture the method, is the learning valid? And that's why the data turned up here on the X-ray console. Nice. Now, I also told you that you can do this yourself via the logs. And if you do this via the logs, then again, you can build queries via login sites. You can save the results of those queries and add them to a dashboard. Now, we already saw the demo because I just showed you the code. So challenge number 3, correlation IDs and trace IDs. It's a best practice to add them or to have an external system that does this for you. Now, what can you use for that? Indeed, an external third-party tool or AWS service X-ray. With that, we come to the 4th challenge, which is a shorter one, but it's about money, so it's interesting. So it's about paying a lot of money for unworthy logs. And I have actually seen applications where more than half of the cost for the application was about paying for ingestion or storage of the logs. So if that is the case, then something is probably off. And why is that then? Because at first you're paying for the amount of data that is ingested into CloudWatch. So don't log too much. And then if you keep the data around for always, then you will also start getting increased storage cost for your logs. So please do some log management and configure a retention period for your logs so that after the time they are thrown out. And don't log excessively. Think about what you log. If you log excessively, you will have so many logs that you cannot look through them anymore. So it doesn't help you anyway. Best practice, a retention period, configure a retention period, and don't log excessively. And then challenge number 5. let's try to figure out what was the event that triggered our function. Well, using Lambda Power Tools or using just the code that you write yourself, you could log the event that is triggering your function. Again, there you are cluttering your logs. So I'm telling you to use a third-party tool if you want this, because those third-party tools, they will store this information for you. That by using Lambda Power Tools or using a third-party tool. And then we come to the last challenge, which is challenge number 6, which is again a big one. And this is about how can I know that something is about to go wrong? How can I be proactive instead of reactive? And what do I mean with that? Well, we have been there, we've all been there, or at least I've been there. You go to work and you know that you will be extinguishing fires all day, running from one fire in production to the other, which is quite exhausting and which is a never-ending story. So there you need to try and take the time to take a step back and know that, and be proactive to react before something is really going wrong. Now, how can we do that? Well, you have to configure the right metrics. And configuring the right metrics, what do I mean there? Well, the value of your application, it's only valuable when you actually produce some business value. So it makes sense that you would measure the performance of your application in business metrics. So we need a system to add business metrics to our application. We can also measure response times of the API. And then we can, of course, we have the technical metrics about function health. And then we can add all of those metrics. We can add that to a dashboard and then alert if something goes wrong, if the metrics are off, if any abnormalities appear. Well, let's see how we can do that. And this is something that came out last year. So it's not brand new, but it's quite new. It's the AWS embedded metrics format. It's quite a difficult term for something simple. Actually, it's just you log something. You log something with a certain structure, and AWS will recognize that structure, and they will know, okay, if something is logged in this structure, I have to create a metric from this. So they also have libraries for that in Python and in Node, which will then log something, and CloudWatch will detect it and create a metric for you. So this is the log that you will then see in CloudWatch, but it's actually picked up by CloudWatch, so you don't have to do anything with it yourself. CloudWatch will notice it. Well, let's look at it, how I did that. I set up, let's look in the code. So here, I added, once someone creates a metric, I just want to add a count of 1. Yeah? A learning was created successfully when someone creates a learning. So learning was created successfully, someone has learned something. Well, let's now go look in CloudWatch if it was able to pick up this custom metric from our logs and make it appear in CloudWatch metrics. So we're going to CloudWatch, we're looking at metrics, and we're already seeing here, and we have the learning created success metric. So yeah, it's average or sum. We want the sum over a period of 15 minutes. Okay, it's interesting. Maybe we want all of the successfully created learnings today or in the last 24 hours. Voila, here they are. And now we can add that to a dashboard. The button is here. Or we can create an alarm based on this metric. So let's create an alarm. I see I'm already running short on time. So you have the learning created success metric, which is a business metric. And say if this metric is lower than 100, then people are not learning anything. So I want to alert if this metric is lower than 100, then an alarm must go off. I can now set that alarm, or instead of configuring this threshold myself, I can tell CloudWatch, okay, look at all of my data from the past period of time and figure out yourself if anomalies are appearing or not. Well, so we can create an alarm on our custom metric, but we can also create a dashboard from it. And that is what I have done here. So this dashboard is actually grouping 3 things. First, we're seeing the business metrics that I added. So using the embedded metrics format, I created some business metrics and I added them to a dashboard. Now, then at the lower level, we see that I also added some of the technical function metrics that are provided out of the box by AWS. And then here at the bottom, this is the result of a CloudWatch login sites query. That result you can also add to a dashboard. So now you get this nice little overview of business metrics, technical metrics, and metrics that you extracted yourself from your logs. Now, I also told you about monitoring the APIs and the performance of your APIs. So let's quickly look into that. We have CloudWatch synthetics. It still has the new marker over here, so must be quite new. And yeah, you can create a new canary here, which basically, I want to monitor my API. API monitor. So which API do I want to monitor? Well, let's take the API that we have been working with all day. I think I can find it in here. Voilà, this one. I'm doing get request on which URL? Well, this one. And then I can configure a lot of stuff. I will not go into that right now. I can also set up an alarm. So if if I have low success percentage on this call, I want to trigger an alarm. You see, you can configure a lot of things here. And what will actually happen if I press create canary here, it will create a Lambda function, a function that will then every 5 minutes, because I configured it right here, every 5 minutes do the get request and see if it is still successful. Now, important notice right here, you are calling your actual APIs. So if you're doing this in production and you're doing a get request on endpoint, probably not going to cause some extraordinary load. But if you're doing a post here and you're sending some data, this is data that is getting into your actual system. So be aware of that. You are working with your real APIs here and you're inserting a real data. Now, back to the presentation. I see that, so this is the dashboard that we created, and these are some links to the embedded metrics formats and the CloudWatch synthetics that you can set up. And we just saw then that we have to monitor business value instead of technical problems, and that we can do this using the embedded metrics formats, CloudWatch alarms, and CloudWatch synthetics. So third-party tools that I've worked with, Lumigo and Tundra, they are both very active in the community. I think they're both sponsoring here too. I'm not here to do any sort of advertising for them, but I have worked with both of them successfully. There are other tools too, but I have not worked with them, so I cannot speak for them. Well, let's then unpack our backpack of best practices and our toolbox of instruments. So we saw that structured logging can help us out a lot. We saw that a log retention period will cause logs to be thrown out after a period of time, and we don't want to log things we don't need, so don't log excessively. Then we want to do tracing either by adding trace IDs or using a third-party tool. We want to keep track of the events that invoked our Lambda function, so that we can check if something went wrong. Hey, what was the event that triggered the function? And we want to monitor business flows, not only technical flows. So using business metrics to measure in your application. And as a toolbox to allow these best practices, we saw that we have CloudWatch login sites to query our logs. We can also stream our logs to Elasticsearch to query them. We have Lambda Power Tools to set up structured logging and tracing. We have X-Ray, which can do tracing for us. We can just use a third-party tool, which will be an all-include package. We have CloudWatch synthetics to monitor our APIs. We have CloudWatch alarms to notify us if something is going wrong or is about to go wrong. And we have the embedded metrics format to configure our own custom metrics using a certain structured format in our logs. And with that, folks, we have now the backpack of best practices, and we have all the necessary instruments and tools to tackle this monitoring monster and to be very well rested at night and sleep well. So with that, I have reached the end of my presentation. I want to thank you for your attention. If you want to know more, reach out to me on the Discord channel, reach out to me on Twitter. I'm part of the serverless community, and I'm here to further grow the community. So if you're interested in more serverless news, just connect with me on Twitter. Thank you, guys. See you next time. And here are the code repos that you can check out if you want to know more. Bye.
So, welcome, Nick.
Welcome.
Thanks a lot for your talk.
Hi.
How are you doing today?
I'm very well. Thank you. Thank you for having me at ServerlessDays Hamburg. And I just want to mention maybe, because the talk is called Tackling the Monitoring Monster, and it might sound negative about serverless. If you're looking at the serverless technology, I think the advantages greatly outweigh the small challenges that come with it. So that's something important that I also wanted to mention here.
Yeah, sure. And I think you noticed some good tools for actually tackling that monster and to let everyone rest well at night. So there have been some comments. I saw that you already answered some in the Discord channel, but still I wanted to use this opportunity to ask them to you in person. So the first one was by Lali, how to monitor cold starts.
That actually was a multi-part answer, and there are multiple options there. So I first mentioned you can use a third-party tool that will do all the work for you, or if you're using the Lambda Power Tools, you can just configure it with one annotation. If you want to see that, it's also in the example that I linked. The code there contains that annotation. Now, then I also mentioned the custom metrics format from AWS. So you could also start counting cold starts yourself. Now, bear with me. This is kind of a harder explanation. So the first time that your Lambda function is invoked, you execute the initialization code. In Java, that would be your fields, or in Node, that would be everything above your handler. So there you can set a variable, and you can set it to cold start is true. And that will then only be executed the first time that your function works. Then the function is warm. And the first time when the function works, you update that variable and you say, now the cold start is false. So then the next time that same container, that same instance of a function is called, cold start will be false. And then using the embedded metrics format, you can create a metric for that yourself. Now, if you get from my explanation, this is a more difficult implementation. Still, you can do it, and you can find it also in the repo that I linked. The example is in there. And then the last thing I mentioned was you can also use CloudWatch Log Insights to count the number of different log streams. And that number, that's actually the number of cold starts. So you can also use that number to count the cold starts and to counteract people who say that Lambda is always fighting these cold starts. And often it's not about that. If you look at companies where I've worked, only a few percentages of the Lambdas is invoked on cold start, and the rest is just a fast execution.
Yes, so there's also this joke, like if you have too many cold starts, then maybe you don't have traffic. So.
Right.
True. Maybe, Nick, you could later also send the links for your repos into the Discord channel directly, because it's always hard to copy from a screen. That would be very helpful, I think, because I like always the best to learn
Yes,
on,
sure. I was
like
proactive,
concrete examples.
but I will link them again in the end of the chat.
Great, thank you. And maybe we have time for just one short question. It's actually a yes or no question, but I think you will elaborate. Does using X-ray impact the performance noticeably?
From what I saw in Java, the cold start time was a little bigger. I guess that is because the package that you have to load into your function becomes a little bigger because with the extra dependencies. Then in Node and in Python, I admit that I haven't measured, but I haven't noticed it.
Maybe as a comment, I think there's in Lambda there's a background daemon running for X-ray, so at least you don't have like network latency, additional network latency for sending traces to X-ray. But there might be a little bit of overhead, like for the to analyze the code. Yes, but this should be very low.
Yep.
All right.
Pretty small.
All right. The time for the Q&A is unfortunately already up, but I can assure you that Nick will stay online and active on the Discord channel. Thanks again, Nick, and see you maybe next year. And now it's time for the next announcement.
Yes,
so I'm handing
thank
over
you,
to
Nick,
Zemke.
and bye-bye. See you in the chat. And yeah, we are going to hand over to Robert Hostlowsky, and he will talk about how to run a GraphQL Trello clone without any servers. So this looks like a lot of fun. And he also has a dedicated Discord channel. It's called Trello Clone. So feel free to ask questions there during the talk. And we will also have him live for Q&A after his talk. So I would say, let's go.
Hi, and welcome to my talk, Running a GraphQL Trello Clone Without Servers. For me, this talk is for knowledge sharing, all I learned in the last 2 years while running a demo application live. So the agenda of this talk will be, we will talk about why did I do this and how it all started, then how things evolved and what lessons I learned. Then afterwards, I will come to some recommendations and would like to tell you about my future plans of this project. So first of all, Trello is real great and I love it and love to work with it. But I thought, hey, there's something missing. And for instance, I tried to use it in my team together in a project where we wanted to have something like in Scrum where you have horizontal lanes. And I thought that is something that's missing. And then when I get the chance to create a video course, and at that time I was searching for a good example for an application we want to build in this course, I thought, hey, that would be nice. And it's not a stupid, simple to-do list or anything else, which was already well documented at the time. I wanted to build something which is bigger, which has more complexity, where it's also a server and a front-end part. And this is then the demo application. It's called Cool Board. You find the link on the bottom here where you can try it out. And when we come to the beginning of this project, you might quickly find out how Cool Board, the name was born, because there was a company called GraphQL, and they further then renamed to Prisma. But they provided this great, cool service or backend as a service. They provided a GraphQL backend, let's say. So at the beginning, we could write a GraphQL frontend, or let's say just a frontend, which communicates via GraphQL to a backend for storing any data. So that was the beginning, but quickly you have to implement, of course, authentication. And nobody wants to put all the data, the whole functionality, all this database directly into the cloud. So of course, we wanted then to have a customer-facing API, which is of course also smaller and doesn't provide all the information. You can set a password of somebody else. And of course, that was then the entire application we built at that time. That was in 2018, and things emerged. But let's have a look how this then looked like, or also we go one step further, because then 2019, I didn't need any microservice anymore, because I could use the Netlify functions for this to have this, let's call it API gateway, or backend for front end, or sometimes called. And as you can see here, I also used a different service. It's called Auth0, just to handling the OAuth authentication process and user management, of course. So at that time, 2019, this application was fully serverless. So, but at that time already, I had to learn a lot. Just to summarize the 5 things. First of all, of course, developing something and doing this all on a local machine always runs more or less smooth. But going into the cloud, of course, things run different. Thus suddenly, of course, I don't need to tell you, there are more latencies. The network is there, which you didn't really feel before. And also performance of I/O is slower, of course. More important for me was, when something is live and you want to change something, of course, then it's always very important to test very, very good and to have a stable deployment pipeline. And therefore, it was for me a must at the end to have smoke tests to finally give me a green or red light so that I can replace something or not. So smoke tests is a must. And of course, we will see this in a second. The pipeline, the deployment pipeline is really a backbone of the whole system. And then I also learned that also simple things break very easily. And I didn't notice it quickly enough. So we will come to that. And of course, there will be bottlenecks. Bottlenecks, as I mentioned before, you don't see, you don't feel on your local machine, and it's hard to get it when it's live, of course. And then a more crucial thing is when you deploy something on into the cloud and are using any service from somebody else, of course, they change their service sometimes. And so at the end, you have to rewrite some parts. So don't be too strong in this love relationship with your code. Be ready to throw something away and rewrite it. And then, even when the application is working and is out there and seems to be working, so you need monitoring, logging, and tracing, and get all out of it. So getting more into details now. So what is a good deployment pipeline? So pipeline must support you in having a new feature separated via Git and GitHub. It's easy to create some feature branch and then have the ability to preview it and test it. So that was really great for me all the time to use feature branches and pull requests so I can implement something separately. And also, as you can see here, at that time, of course, there were many updates, libraries were outdated or had vulnerabilities, and exchanging them is so much easier when you have something like a Renovate bot here, which does these updates and just shows you or just creates a pull request for you with the verification. I can get sure that it's still all running smoothly. Then what's also very important, of course, you can't have just unit tests and be fine with that. So it's nice to see that your code works, but at the end, also integration tests would not give you the real good feeling that at the end also that this works for a user. For me, it was also, of course, very important when using an external service from Auth0 that I can use a browser and verify that the authentication and login works, of course. So at the end, I was using Cypress since 2 years now, and it worked fine for me after some learning curve at the beginning. It's really a very impressive, cool tool to verify and also to implement, to write tests. As a pro tip, it makes totally sense to allow tests running in parallel so they don't even break each other when running in parallel. So therefore, it's absolute a must to write them so that they don't access the same data at the end. How did it look like? You see here with the nice Cypress dashboard. Every pull request here is tested, and yeah, you can see definitely there was something not working properly, but after changing anything, I could be sure that everything works. As it's the obvious, the small things break, and that was true. And the bad thing was it broke so easily that I didn't notice. And it was a small code change, which then leads to a problem that anybody who wanted to sign in already registered at Auth0, but the new user was not injected into my database. And so at the end, he was not able to, the user couldn't really access the application, even while he was already subscribed. And that was, of course, bad because I didn't notice it even fast enough. So then, as I said, there are bottlenecks, and I was not aware about 1 or 2 bottlenecks, which were there they maybe hidden in some looking good code parts. It was more like a facade, which didn't really show that they are doing some extra work behind. And so at the end, I had to really analyze to find the problem, and then quite easily after this analysis, I found a small piece where some extra requests were created which were not necessary. And then after fixing this, I also had measured or also found out how well it worked. And therefore, there are these 2 blog posts that summarize this. And of course, you can get the links later. And it was really cool for me also to find out that there are tools out there in the meantime, which even also support GraphQL out of the box. And then, of course, this environment is more complex because it's not only running stupid simple on your machine and do load tests and you're happy. But here I wanted to discover where the bottleneck is when it runs in the cloud. So I don't have control over all the systems. And typically, when running something locally, as I said, it completes completely different than in real life in the cloud, let's say. So there I wanted to check it out in the cloud environment. And of course, therefore, in this way, in this situation, Instana was for me the right tool. Then I said, be prepared to throw things away. And I had it more than often. And I was not always happy about that, but it was the right move, of course, because typically you can get something like these warnings or announcements. So that always leads to some extra work and changing code, even while this was announced a while ago and you have some time until you migrate. It often makes sense to migrate immediately, also to get the newest features out there. And so that was one of the learnings that I made or will make my application more easy to split and even not put everything together. So to make it more easy to pull things apart and rewrite only little things. And at the end, observability is no buzzword. It's obvious, but I have to make it clear again. This is so important, and only with good monitoring, where you can get the logging and health checks, you should also have something which gives you the ability to combine the page views, let's say, together with backend tracing. And please don't have different tools for that, but combine this data. And in this case, I can also recommend again Instana because it helped me a lot. It's instrumenting the backend services automatically. So for traces, you don't have to do anything. And yeah, it has GraphQL support built in, which is really great for on each trace you get, let's say, the GraphQL information, or it's get automatically collected. So you see which queries and operation names are used in this GraphQL operations and so on. And then I found also out that it has Lambda support, and I had the chance to get it running or working together with Netlify functions. So because Netlify function also run at the AWS Lambda environment. So I tried it out and was quite happy that it works, even while I don't have full access to Netlify's environment, of course. I can at least get a lot of information out and get information about the Lambda services. And for instance, if it's only just timings, but we will see that how it looks like now. First, I just wanted to show you that because I think it's quite great to have these tools and maybe you get interested. And as you can see here, of course, the typical dashboards where it presents you the typical top pages here, and it also collects JavaScript errors which occur in the browser, page views, etc. And when you want to get deeper, you analyze the page views or page loads, and here you see also the requests, which encapsulate, of course, also the GraphQL requests. And if you want to go deeper, you get the connection to the Lambda function here, for instance, and can even find out which of them were slow and faster. And that is really real cool integrated tool, and I liked it very much because you get so much out of it and not have to debug anything on a local machine, but get it directly out of the production environment. So, but enough about tools and more tools. No, I just want to recommend other tools which I would like to try out now, something which was not there 2 years ago. And I found this or didn't know that they exist. And this, for instance, already contains more important features like also the user authentication, authorization. It also all comes built in, and yeah, so you can easily create some new value. And that's the main idea of these services, that you don't have to think about backend services for persistence, for instance. So concentrate on the front end here and build on top of this existing services. So, but that's not the only player here. There's Hasura, and Hasura is, I think, coming from a different direction, or at least they can work with an existing database. So if you have a Postgres database and just want to bring this data out there via GraphQL, you have the chance to do that quite easily. And of course, I can mention difference. I would like to try out FaunaDB, for instance, which is a native GraphQL interface, and also Prisma 2, the next generation, and Slash, which is created by dgraph. And also I didn't come to this, but of course there would be AppSync out there if you are focused on AWS and already have your data there. So it won't be any problem to use AppSync. They have a complete tool set for different things and might also work quite well for you. But for me, the next thing will be FaunaDB. I like their approach and should be a cool thing. And besides this, of course, there are so many more things like I would like to migrate to TypeScript, which was not appropriate for my video course at that time. But now I think it's more modern, and you can get so much more out of it in combination with the types you get out of GraphQL, of course. So at that point, I say thanks for listening. You can, of course, find me later also in the Discord channel, and here, if you also want to connect me via mail, Twitter, or anything. So thanks very much for listening. I hope you enjoy it, and see you later in the Discord channel.
Yeah, thanks, Robert. We now have Robert here live, and he is still in his little tiny circle, which is very funny. And yes, so we don't have any questions from the
Don't hear anything yet. Sorry.
Yes. So let's wait for Robert. Okay, I'm not sure if it works currently. Hi. If you wait for the YouTube channel, it has a delay.
Okay. Mm-hmm.
Okay, I think his setup is a little bit too fancy. So I'm not sure, but we don't have any questions. So next up, so I'm now a little bit confused. So let's just
Can you hear me here?
Yes, we can hear you. Okay, I think we will just now. You can still ask questions via the
I'm sure you should be able to hear me? Is it true?
Yes.
Okay.
Okay.
Right.
Now you got it? Got it up and running? Okay, this was the last chance. No, so sorry for that. Then I would say let's have a look at our agenda. So the next one. So if you have still questions for Robert, then you can ask him in the Trello clone. Very hard word. Discord channel, and this is our agenda. So we'll now go out for a lunch break. So please get a hopefully healthy meal, and maybe have a short walk, and then we will be back in 1 hour with CI/CD in the serverless era with Efi. And yes, I would say enjoy your meal, and we will be back in 1 hour. Did I forget anything, Jonas?
I don't think so. Have a nice lunch break, everyone, and we'll be back soon. So, can you hear me?
Yes, hello.
All right. Welcome back, everyone. We hope you had a nice lunch break and are back now as fresh as always. We are happy to continue now. Our next speaker will be Efi Merdler-Kravitz. Efi is Director of Engineering at Lumigo, which is also one of our sponsors, and a monitoring and debugging platform for serverless. That's Lumigo. He is a long-standing warrior in the field of serverless methodology, and his talk is called CI/CD in the serverless era, and focuses on tech stack development process, stage release using a step function, and parallel testing. Efi is with us. He will have a short Q&A with us after his talk, so you can ask questions here on YouTube or on Discord. The Discord link is here down below us. And there is the general channel, and there will be there already is a dedicated channel for this talk of Efi. It's called CI/CD. So you can ask your questions there. Efi will be online there, but there will also be a Q&A where we will pick up your questions, or some of your questions, probably not all, from the channel. So without further ado, let me pull up Efi's talk and let's dive right into it.
My name is Efi, and in the next 25 minutes, I'll try to squeeze, and it's not going to be easy, Lumigo's experience with serverless CI/CD. Before we start, you're probably asking yourself, why should I waste 25 minutes of my time? Well, in Lumigo, we are 100% serverless in production, hundreds of millions of Lambda invocations per month, and of course, serverless is not only Lambdas. We are heavy users of DynamoDB, SQS, SNS, S3, EventBridge, Kinesis, and I'm sure I missed something. We are really the poster child of serverless in AWS. Not only that, we are also 100% of serverless CI/CD flow. Tens of deployments per day, and we don't have a single server that manages or drives the flow. Everything is outsourced, either to AWS or external SaaS providers. I always laugh and say that the only server we are running in our office is a disk on key computer that runs Zoom. By the way, as a side note, COVID-19 didn't affect our operations at all. Because everything is in the cloud and serverless, we had a very easy transition, no VPN whatsoever. In this session, you'll learn how we drive our CI/CD flow in Lumigo, how to make the entire flow robust enough. I'll share some tips and tricks on how we cut our CI/CD flow time by 2/3, and we'll talk about a unique flow for phase deployments we implemented internally. Across the session, you'll see many links to blog posts we wrote on the subject. A couple words about me. An AWS serverless hero from last January. I'm leading the development of Lumigo's R&D. I've been using serverless in the past 4 years, mostly with Python. I'm obsessed with serverless testing and serverless development flows. I wrote a couple of blogs and have a couple of sessions on the subject. 15 years in the industry, working mainly with backend and mobile applications, various verticals like healthcare, security, agriculture, and infrastructure. And on my spare time, I like to play card games, although most of the time I lose. A couple of words about Lumigo. It is a SaaS platform for AWS monitoring and observability, heavily focused on serverless workloads and components with smart out-of-the-box capabilities for serverless workloads. It uses data from your logs, metrics, and traces to create a coherent view of your application. Well, serverless is different, and it affects the way CI/CD is conducted. It's distributed with maybe hundreds of components. Therefore, the orchestration of building serverless environments from scratch each time is difficult. Many components usually means that frequent deployments are the norm. And for many of the components, you can't run them on a regular Linux machine. SQS, SNS, Kinesis are AWS services. We don't have their containers, so they have to run on a dedicated environment. So we're going to talk about the famous infinity loop, see how we here specifically in Omigo adapt it to serverless CI/CD, talk about our best practices, and in the end, we'll have some time for Q&A. The infinity loop starts with a plan, goes to code, then to a build process. By the way, in Omigo, we use Python, therefore the build process is skipped, but in other runtimes like Java or .NET, you actually have to create a running artifact. From there, we move to testing, both unit testing, integration, testing, and end-to-end testing. When everything passes, and I'll elaborate later what do I mean by everything, we are releasing artifacts, deploy them to production, and start monitoring them. Before starting with the flow, I want to go over a couple of guidelines we have internally in Omigo that affect our process. Each of our developers has an AWS environment on their name. We are using organization to manage it and consolidate the billing. For us, if the code is not tested on a real AWS environment, then it's not considered ready. Originally, we had a shared environment with different name prefix for each developer, but very quickly we started stepping on each other's toes and decided to separate environments. We do have a single environment for CI/CD driven integration tests. We're serverless first, which means we will always prefer to choose a serverless service instead of managing it by ourselves. And by serverless, I mean true serverless and not the managed ones. We don't want to handle sizing, operations, and pay for unused capacity. By serverless, also we mean across the technology stack. So things like CI/CD, code quality, and so on. I'm not talking about only on serverless in production. We don't want servers, period. We prefer to outsource everything that is not the core of our product. No dedicated QA and ops, which means everything is being done by the developers from start to finish. The infinity loop that you saw earlier, same developer takes the ticket across all states. Very pizza team oriented. No QA and no ops means we invest heavily in automation across the board. We talked about environments, and these are the environments we have in Omigo. Each developer has its own personal laptop and a personal AWS environment where they can try the code. We do have a couple of shared integration environments that are part of the automated CI/CD process. We have production environments, which are composed from an environment that our customers use, and a monitoring environment that runs our own product that monitors our production. We're eating our own dog food extensively, which helps us both to find potential issues ahead of time and to sharpen our product. In the end, we are a potential customer of our product and we have good feedback. So this is our technology stack. To drive the CI/CD, we are using Circle CI. We even wrote a joint blog post on how we use them. For our deployment, we use the serverless framework. Most of our code is written in Python, but we do have some services that are written in Node.js. So when Omigo started and we were small, we used Kanban to drive our workflow. We had a long list of tasks, prioritized. Each developer picked the top one. But as we grew, the upper management wanted more visibility. So we moved to a more traditional Scrum. Each of our sprints are week-long. We keep them short on purpose to create the feeling of things moving fast. These are the benefits of serverless in the end. But we don't wait for the end of the sprint to deliver. We are very CD-oriented. When a piece of code passes through all of our gates, it's being pushed to production. A lot of responsibility falls on the developer's shoulders. Originally, we used Trello as a ticket tracker, but as the team grew and the complexity of the task grew as well, we moved to Jira. I can't say that I'm satisfied with the move, but that's what we have and we live with it. We are using GitHub to store our code and using the GitHub flow in which you have only master and feature branches. Each merge from feature branch to master means deployment to production. Again, a lot of responsibility on the developer. At the beginning, we had a very heated discussion regarding mono versus multi-repo. We chose multi because it was more suited for services deployments. That is, each change in the repo means deployment. and it coerces the developer to think in a more service-oriented way. You don't read directly from a DynamoDB table that does not belong to your service, only because you can import the DAL or call functions directly. Instead, you use common practices to access remote resources, API gateways, lambdas, queues, and so on. We wrote a lengthy post on the never-ending battle between Mono and Repo. You can find it in our blogs. In one of the slides, I mentioned that each of our developers has their own AWS environment. Right now, we have around 16 services. We need to orchestrate the deployment of these services so our developers can update and install them into their environment. We've created an entire orchestration tool in Python, of course, which we call the Uber deploy. By the way, it's not related to Uber. That does the following: pulls the relevant code from Git, depending on the branch you choose, install relevant requirements for each service, and installs in parallel, and that's very important, the various services according to predefined order. The Uber deploy tool enables our developers to easily install these services in their environment, so no one needs to know the various dependencies. By the way, we use this tool only in the developers in integration environments. In the production, each service is being deployed on update. This is purely a development tool. We believe in automated testing without QA. It's mandatory. We can't skip it. We have 3 types of tests. Unit tests, which the developers runs locally. In the integration test, which the developer run on their AWS environment and are run as part of the CI in a dedicated environment. And end-to-end testing with Cypress, which again is being ran on the AWS environment. Because testing in the cloud is slower than testing locally, we prefer to detect as many issues as possible before pushing to remote. We use Git pre-commit hooks to automatically run tests and linting. For Python, we use pre-commit. That's the name of the tool. And for Node, we use ASCII. One of the hardest things is adding to the testing equation external services. People usually ask me, why are we running our integration test in the cloud? Use mocks. There are a lot of mocks that mimic the behavior of the various AWS services. Well, we've tried it and it didn't work well. Some services that we use don't have good mocks that don't really mimic the true behavior of the service and don't always include the latest APIs. Some mocks infrastructure, like local stack, are complicated. There are a lot of work surrounding them. I prefer to waste my time on real testing. Some of these mocks have bugs, and it happened to us more than once that things didn't work well. Later to find out that they work perfectly when running on an AWS environment. I prefer not to waste my time on debugging mocks. So as a rule of thumb, we don't use service mocks. We always run things on an AWS environment. So this is our testing stack. We use Black and Flag 8 for Python and Prettier and ESLint for Node. We use static analysis for Python, although I'll be honest, it helps us more with readability and less in actual catching type errors, although it sometimes does succeed. And for unit testing, we use PyTest, Mocha, and Jest. We have 2 types of integration tests. Very thorough API-based testing, in which our test is driven only by API. No UI interaction. We're using Node.js and Mocha to drive the flow. Very specific critical flows that are end-to-end, which include also the UI, flows like onboarding, logging, and so on. They're written in Cypress and Jest. We have 2 main problems while running our test. We have 16 services with around 150 lambdas, multiple DynamoDBs, tables, and kinesis, and also other services. Deployment takes time, quite a lot of time, around 30 minutes for the entire environment. The tests themselves are also slow. There are many asynchronous flow. The test originally took us around 1 hour to run. These numbers are not good, and they don't allow us to quickly deliver our features, and above all, to get quick feedback in case of failure. So First, we've tackled the second problem of running the test. We are using the power of parallelism. We've created a dedicated, duplicated AWS environment. Each time we deploy for testing, we actually deploy our code to 3 environments, and we're running each of our tests in a different environment. So the tests don't interfere with one another, and we can run them in parallel. The nice part here, because we are serverless, it does not cost us an extra money, except for Kinesis, which is a very painful point. Kinesis requires at least 1 shard to operate, so we do pay for it, a couple of hundreds of dollars per month, which, to be honest, is quite annoying. By using this parallel flow, we managed to reduce the integration test time from 1 hour to 20 minutes, 2/3. And the nice part about it, that it's fully scalable. More tests means adding more AWS environments. And again, you can read here a blog post that we wrote on the subject. Another change that we did just recently is the ability to reuse existing stacks. After deployment, we pin the latest hash of a repo as a tag in the CloudFormation stack. So when the Uber deploy runs, it checks whether the code changed, and in case it didn't, it skips the deployment of that specific service. It reduced the redeployment time from 20 minutes to 5 minutes. Right now, our biggest obstacle is the initial deployment that unfortunately still takes a lot of time. Another flow that we've developed internally is a staging step flow. One of our components is a SDK, which is embedded by our customers. The SDK is very delicate, and a bug there means the Lambda will crash. The customer's Lambda will crash. So we wanted first to deploy the SDK in addition to the regular testing in integration tests and the tests that it runs on our own system. As I mentioned, we are dog fooding our own platform. So we created a flow that at first step releases an alpha version to NPM. Alpha is not seen by our users. If it then deploys the alpha version to our environment and triggers a step function which automatically, in case no issues are found in the staging environment, releases the final version. At any moment, we are able to stop the step function, like a red button, in case we found an issue in the SDK. We're ready to release. We have a couple of release gates. Some are manual, but most are automatic. Code review is manual, but the rest of the steps are automated. When gates pass, the developer clicks on merge and the deploy begins. So here, for example, you can see the various gates. So a code review is required, and the various testing and linting and code reviews that are part of the entire flow. So monitoring is hard in serverless for a couple of reasons. Many microservices, you need to see the full story. The root cause might be somewhere down the stack in various services. No servers to SSH to. It's hard to collect the relevant details to better help you understand what's going on. And a lot of new technology. Suddenly, disk space in CPU does not play a role. A lot of new metrics and a new jargon to learn. So we use our own product in Lumigo to monitor and to do root cause analysis. For example, here you can see a real issue we had in production when one of our front-facing Lambdas failed because the Lambda it called crashed as well. When going deeper, we found out that the data returned from DynamoDB was invalid. The ability to collect the relevant data, like requests and their content, and putting everything in a unified view, in addition to the logs, helps us in debugging the issue. Another thing that we used a lot are alerting that are geared towards serverless. Because Lumigo is eating and breathing serverless, a lot of the original alerts we added came internally from our own need. And as you saw, we are 100% serverless, so we had a lot of issues that we needed to handle and to get alerts on. These alerts enables us to sleep quietly at night, knowing that if something bad happens, we know about it. So to summarize, use the power of serverless to power your testing with reduced costs. Prefer integration tests over mocks, and allow easy orchestration for your developers. Before finishing, I want to tell you about a nice open source tool developed by Lumigo. It's a Swiss knife for serverless. Many useful commands Many are not related to one another. For example, commands that enable you to switch between AWS accounts, ability to clear an account, that is to delete all the resources, which by the way is very hard to do in AWS, and even more exotic ones like tail event bridge or cold start analysis. Last time I checked, there were 24 commands, and you're more than welcome to try it and of course contribute to it. And you're more than welcome to try, so you can onboard our platform for free. And you can try our own playground and play with Lumigo with real data in case you're afraid to or don't have access to your IAM role. In addition, we provide a special 25% discount for the first year of using Lumigo for ComSum participants. And we love to share our knowledge. We've gathered a lot of experience in serverless related workloads. Talk with us. We would love to work together. Thank you very much. And I'm open for questions.
Yeah, thank you, Efi, sorry. And the man himself is online here right now with us. How are you doing today, Efi?
I'm fine, thank you very much.
Good, nice to hear that. There haven't been any questions on the channel yet, but we still have some questions for you. You mentioned you wrote a blog post about mono versus multi repos when it comes to serverless. So can you maybe elaborate a little bit on that? When I remember right, you choose in the end for a mono repo. Why is that?
Yeah, I think that the biggest problem in our case, I'm not talking about others, is that monorepo makes you lazy as a developer. Instead of using real service-oriented APIs, you're starting to use internal APIs in order to access various resources in your system. So the fact that you're using these internal APIs, you are starting to ruin and add a mess to your architecture. So we've noticed this at the first days of Lumigo, and we've decided to leave a monorepo and stay with a multi-repo. And in addition, it makes life a lot easier because each change in each repo means a complete deployment to production, and we don't need to do any kind of understanding. Okay, we've changed this specific file. It means that we need to take this on these specific functions and so on.
If the audio quality is lacking a bit, maybe stop your camera so we can hear you better. Although it would be nicer face to face, but I think it's better for the quality. There is a new question on the channel, and it says, "Did you have any problems with auto deploying to production?"
What do you mean by auto deploying?
I don't know actually. Now they changed the question. Did you have any problems with auto deploying straight to prod?
No. So it's a choice we made early on the days of Lumigo, putting as much responsibility as possible on the developers themselves. The purpose here is very simple. It's dangerous. I'm not going to lie. The point here is making sure that the developer itself understands that any change that he commits to master goes directly to production. So he needs to be very careful, making sure that he tests everything and not rely on other, I don't know, unknown resources or unknown people that will make sure that the code that he added to the repository will work. Everything is on him. So it's a very psychological effect. And of course, it's dangerous. And we made sure that when committing to master, we have a set of bullets the user has to pass, a set of gateways, make sure that everything works as expected. After deploying to master, he checks everything, make sure that the code that he deployed actually working on production, making sure there isn't errors. So we've made sure that the process is as smooth as possible. But again, the purpose is very simple, to make sure that developers are fully responsible to what they push.
Yeah, I think that makes sense. That also plays into this mono versus multi discussion, I think. Another question would be, can you tell us more about the Uber tool that you used? Is it open source?
Yeah, it's really a cool tool, and we've been thinking for a very long time on open sourcing it. And actually, we intend to do it. I don't have any date, but there's nothing secret inside the tool. The tool itself, again, because we are using a lot of services, and when a new developer arrives to the company, one of the things that we saw is his ability to build the environment from scratch. It's very difficult. Again, when you have 10, 20, 30, 50 services in your system with different dependencies, so you actually need to install some services first, and then the others, it becomes very complicated to tell the new developer how to install things. So this Uberscript makes everything very easy, very smooth. That's one thing. And another thing, because you have so many, we have so many lambdas, we have hundreds of lambdas in our system, the fact that someone made a change in a very specific lambda on 2 or 3 services, and his ability to deploy the entire environment again, making sure it takes all the relevant and new changes without redeploying everything from scratch, which, as I told you, can take a lot of time. It's also something that is very comfortable that the Uber tool brings to the table.
Yes, I see. There's another question from Discord. Adrian asks, how many applications do you have to manage? Where is the point where a company needs OPs just because team of developer cannot deploy in production for hundreds of applications? Develop them, then doing OPs, monitoring, troubleshooting, etc. So the main question is, how many applications do you have to manage?
Yeah, so we have one application. We have the main product that we are developing. So again, I'm sure that different companies with different amount of application, with different amount of developers that are working with different set of requirements, look at things differently. So for us, putting everything on the developer's shoulders, at least now at the beginning, while building our core, makes a lot of sense. Definitely, I'm not sure that's the right decision when we'll be 100 developers and when we're going to have multiple applications. So right now, for 20 developers and a single application, it makes a lot of sense.
Yes, thank you. I see that right now someone else is writing a question inside the CI/CD channel, so I'll wait for a second there.
So I would also have another question in the meantime.
Yeah, sure. Go ahead.
And you said that you debug Lumigo with Lumigo. So how do you debug if Lumigo is down?
Yeah, so we have another environment. Yeah, so that's a very good question, because in the beginning we actually used our production environment to monitor our own environment, created an infinite loop, and we understood very quickly that we need a separate environment. It's a monitoring environment. It's also part of the production, so it's a different AWS environment that runs our application. Again, the same application that runs on master, but in a different AWS environment, which points to the actual production that our customers use. And again, it's a question because we can't get monitoring environment. We're not creating another environment that monitors the monitoring environment. In these cases, so we are using also AWS, and we're using logs and all the traditional things to make sure that the monitoring environment keeps working and monitors the production as it should. And up until now, we're working 2 years and it works perfectly.
Okay, thanks. Yeah, so it's always good to have like this, like AWS native services as backup. Yes, thanks.
Yes.
Thanks. So it looks like there won't be any more questions. Or some people now are typing. So just on a short note, we just introduced a new channel to our Discord server. It's called Networking, and it's of course there to network, to get to know people, to offer jobs, or to maybe make some new business and company contacts. So for any of these discussions and questions, you can just go there. And will Nate wait for another second? Yes, there is another question for you, Efi.
Yes, I can see.
It says, Marx asks, do you use serverless artifacts like ones produced by AWS SAM package? If yes, what's your strategy to propagate them between the environments?
Yeah, it's a great question. No, we are not using artifacts. Again, we assume that, so for each, let's say that we have the two environments. We have the integration environment, we have the production, and we have the monitor environment. For each of these environments, we are using serverless. We are not using AWS SAM. And for each of these environments, we're running serverless deploy. Again, we are making sure that everything comes from the same, everything comes from master and from the same Git push. So everything is identical from code-wise. And for the external packages that we use, we are making sure that we are pinning them. So we're always taking the same version over and over again. So we're not moving artifacts. We are redeploying it again and again.
All right, thank you very much, Efi. I think that's it for the questions now, but Efi will be online and in the CI/CD channel as well, so you can ask more questions and have in-depth discussions there. Thank you again, Efi.
Definitely, I'll start in the channel, so if anyone else have more questions, I'll be more than happy to answer.
All right, thank you very much.
Thank you.
Thank you.
Bye,
Thank
Efi.
you. Thank you. Bye-bye. Bye-bye.
All right, and we are now 10 minutes from the next talk. Should we make another short break?
Yeah, maybe let's do a short break, and then we will be back at 1 minute before 2 p.m.
All right, I'm pulling up the logo slide.
Hello. So, welcome back to ServerlessDays Hamburg 2020. We're still live and we already have our next talk in the queue, and we are now going from CI/CD to production and what's going on there. So, and Gunnar Grosch will tell us, and he will tell us about a really important topic. It's chaos engineering. So how can you make sure that your stuff won't break in production, and you probably hopefully find it out before your users do. And so Gunnar is also as Efi AWS hero. So we are now getting in a row with AWS heroes, which is a funny like not planned not planned fact. And yeah, so he is really the expert when it comes to chaos engineering and serverless. So I would say let's welcome him on stage. And again, he will be there for live Q&A after the session. And there is there's also a chat on Discord. It's called Chaos Engineering. So ask your questions there, and we will queue them up for the live Q&A and then answer them live. Okay, let's go.
Hi everyone, I'm Gunnar Grosch and welcome to Performing Chaos in a Serverless World. This is the abstract of this talk. The principles of chaos engineering have been battle tested for years using traditional infrastructure and containerized microservices. But how do they work with serverless functions and managed services? And to answer that question, this is the agenda for this session. So we'll cover what chaos engineering is, and look at the motivations behind chaos engineering, how we perform chaos experiments, some of the challenges with serverless, and some of the common weaknesses are that we can test for in our applications. And of course, we'll finish it all off by doing some experiments. So just short about me. I have a background in development, been working in operations and in management within IT for about 20 years now. I'm deeply involved in both the AWS and the serverless communities by organizing user groups and conferences, and I have been honored with being named an AWS serverless hero for my work. And I have 3 kids at home who constantly keep me on my toes. So let's get to it. What is chaos engineering? Well, chaos engineering is not about breaking things. We often hear about breaking things on purpose in regards to chaos engineering, and that is great marketing lingo, which helps draw attention to the practice. But we have to agree upon that breaking things isn't the purpose. Sure, we do break things now and then, but the breaking part is not the purpose. Learning is the purpose with chaos engineering. Chaos engineering is not only for production. That's also a thing we often hear, that chaos engineering should be used in production. And hearing this can be an obstacle for anyone trying to introduce chaos engineering in their organization. We want to do it as close to production as possible. So you can do your experiments in dev, in test, in staging, playground environments, and so on. The more production-like, the better. So think about replaying traffic, using it with load testing, and so on, if you can't do it in production yet. And there are a bunch of big organizations doing chaos engineering successfully without doing it in production. So you can't really have a chaos engineering presentation without showing this. The Principles of Chaos.org is a website that was released alongside the first book on chaos engineering. So chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. And reading this shows that it's less about doing things that are chaotic and more about experimenting. So the chaos part of chaos engineering is more about what's inherent in the system. There is chaos in every system. So let's break that down a bit. Chaos engineering is about performing controlled experiments to inject failure. And talking about experiments makes it sound quite scientific. And to be honest, it is. We create a controlled experiment and we measure the result of the experiment. So some people like to compare it to a vaccine, in that we inject failure into a system to make it stronger in the end. And chaos engineering is about finding the weaknesses in a system and fixing those before they break. So no matter how much we focus on making our systems resilient to failure, there are always unknown factors that come into play. Be it traffic patterns, third-party dependencies, network issues, code deploys, configuration changes, and so on. So by doing our chaos experiments and measuring the results from those, we can draw out weak points in the system, and finding these and fixing them can help us avoid these big outages that we know never happens at the right time. Chaos engineering is about building confidence in your system and in your organization. By finding weaknesses and doing controlled experiments, we can build confidence in our system and how it works. But we also build confidence in our organization. The people are key when you want to build a resilient system. So by building confidence, we gain trust. Perform these experiments and you will learn new things about your application or system. So we've looked at what chaos engineering is and seen that it now sounds a lot more controlled than just breaking things in a chaotic way. So let's look at what the motivations behind doing chaos engineering are. So why should we invest time and effort in this? So everyone who builds or runs a system has customers, be it internal or external customers. So are your customers getting the experience they should, or are your users unhappy? And we often say that nothing is free on the internet. So no matter if we run an e-commerce site, an ad-driven blog site, or a SaaS solution, downtime or issues probably cost us money. So that can be in decreased sales or just by users leaving your platform. What happens when the incident is there? Are you confident that your monitoring and alerting will notice? Will the on-call get that page needed to start engaging with the incident? And you probably have your runbooks or playbooks describing how to act when you have incidents or outages when they occur. But is your organization actually ready to handle outages? You probably do fire drills, so everyone knows how to act in case of fire in your building. But are you doing fire drills for incidents? And every time there is an incident, we have a huge opportunity to learn about the conditions that exist for the incident to take place. But what about learning from controlled incidents? Well, that is something that chaos engineering lets us do. We can create controlled incidents and learn from those. And that brings us to the greatest motivation behind chaos engineering, for me at least. Don't ask what happens if a system fails. Ask what happens when it fails. We have to remember that a resilient system isn't one that does not fail, but one that maintains an acceptable level of service in the face of failure. So what happens when the system fails? Well, chaos engineering helps us reveal that. And this is actually a statement from the updated reliability pillar of the AWS well-architected framework. So if nothing else I've mentioned has motivated you so far, maybe this does. Chaos engineering should be done regularly. That's from the reliability pillar of the AWS well-architected framework. All right. So now we've set what chaos engineering is and why we want to do it. So let's look at how to run chaos experiments. And we'll do that by following some simple steps. So First off, we define what's called the steady state. So before we create our experiment, we need to define the steady state. And without knowing that, we can't really observe what happens when we're running the experiment. And the steady state is basically the normal behavior of a system over time. It's highs and lows, it's ups and downs. So we use system metrics to find this. System metrics might be CPU levels, number of instances, and so on. But even better is to use business metrics, like the number of purchases, the number of active users, and so on. And when we have the steady state, we form what's called an hypothesis. An hypothesis is a proposed explanation made based on limited evidence. So that's a starting point for further investigation. And to find and form this hypothesis, we usually use what-ifs. What if the primary database goes down? What if there is latency in the network? So asking these what-ifs, we're then able to form our hypothesis. Well, if the primary database goes down, we can switch to the fallback database. So that's really a scientific way of creating a hypothesis. The next step then is to plan and run our experiment. With the hypothesis formed, where we can plan the experiment and then decide upon how to run that experiment. And when we're planning it, we talk about containing the blast radius. We want to start with the smallest possible experiment. And that can be, for instance, with just a small percentage of users, a specific country, only one function, a certain number of instances, and so on. So we start small and we grow with confidence. We also need to make sure to have a stop button ready. So we don't want an experiment that grows or cascades. So having a way of stopping it is really important. Then when we run our experiment, it's now time to look at the results. And the first step I talked about was the steady state. Well, the metrics we used to define that, those are the ones we're going to use now to measure the result of our experiment and to actually prove or disprove the hypothesis that we created. So we have, in a controlled manner, injected failure of some sort. And the question is, was the system robust enough to, or perhaps adjustable enough to handle the failure that we injected? So we took down the primary database for 10% of users. Did they switch to the fallback database? So now we've done these steps and we've seen what happened with the blast radius that we set doing that experiment. And with the result that we found, we gain confidence. And with the confidence we've gained, we can adjust the scope, perhaps add additional users, additional countries, more instances, so on. And by creating a larger experiment, by increasing this scope, we probably will find new things to learn about the system. All right, so that was pretty easy how we run chaos experiments. It's pretty straightforward. So that finally brings us to the serverless part and some of the challenges around serverless. So this is the AWS definition of serverless. You've probably all seen this. Serverless allows you to build and run applications and services without thinking about servers. And it's not so much about the actual servers as it is about what running servers means. It's about letting someone else do the long time work that is involved with running servers. So we can focus on maximum business value. That's why we use serverless. But there are still servers in serverless. We've seen this and we've heard this, all of us, many times probably. There are servers, we just don't manage them. And that brings us to some of the challenges. So we don't have any servers to manage. And that also means that we have potential sources of failure that are unknown to us. We don't know about the unknown, about the potential sources of failure. I'm all for less infrastructure work. We just have to remember that every time someone sets up or configures infrastructure, they usually learn a lot about how it works. So they find sources of failure and are aware of those. So once again, things are unknown for us. And besides, in AWS world, at least, Lambda functions as the most common part of our architectures, there are a lot of services to choose from: DynamoDB, SNS, SQS, S3, and so on. And every one of these services has their own potential sources of failure and unknown failure modes. And for each function and each service we use in our applications, we have separate configuration and separate security policies. And this is all great for control, but it also gives us the opportunity to introduce failure, both in configuration and in deployment. And our serverless architectures are usually more granular in that they can contain lots of different functions, services, and interconnections. So all in all, with serverless, we have more of that inherent chaos that I talked about earlier. All right. So creating chaos experiments for traditional infrastructure can be fairly easy. We shut down instances, we destroy pods, we cripple network traffic, and so on. Because we have control of most of the underlying infrastructure, it's fairly simple. But designing chaos experiments for serverless, it is a different beast. So we have to be a bit creative, right? So let's look at some practical serverless chaos experiments we can do. So this is a simple architecture. It's a web service using API gateway, fronting one Lambda that retrieves or stores data in DynamoDB and one who retrieves or stores data in S3. Alongside this, we have an S3 bucket used directly by the client. So we can inject errors into our code or create exceptions in the code as well, to see how our application handles those. We can remove downstream services, in this case S3. We can alter the concurrency of functions to see what happens if we aren't able to have that concurrent concurrent functions as we perhaps count on in our application. And we can restrict the capacity of tables to simulate, for instance, issues with DynamoDB. We can introduce security policy errors. We can create coarse configuration errors. We can, of course, introduce different types of service configuration errors that might happen when either setting up services or at deployment time and so on. And if we're using the local disk space, the temp space in our Lambda functions, we can do different types of experiments around disk space failure as well. For instance, fill disk with files so we aren't able to store in the temp directory. And then we have perhaps the mother of all chaos experiments, adding latency to our functions. My fellow AWS serverless hero, Jan Kui, he wrote a great article on latency injection for serverless several years ago. So that perhaps was the starting point for a lot of the chaos engineering for serverless stuff that is around today. So we can add latency to functions to simulate, for instance, call starts, cloud provider issues, runtime or code issues, integration issues, and test our timeouts, as I mentioned earlier. So there aren't that many tools out there that we're able to use to do our chaos experiments for serverless. And so I've released a library that's called Failure Lambda for Node.js Lambdas. It's an NPM package that you can download and install. It's configured using parameter store. So you create a parameter and set the configuration there. It has several different failure modes that you can use. Latency, status code injection, exception creation, disk space failure, and deny list. You're able to block network connections. So you wrap your Lambda handler and do the configuration using a parameter. Fairly simple. And if you're using Azure or GCP, don't worry, there's a failure Azure functions and a failure cloud functions as well. So let's look at a chaos demo. This is a simple chaos demo site that I've created to help people get started doing chaos experiments for serverless. It's a basic site that loads images every 5 seconds. The architecture is similar to the one we just saw, basic web service, an API gateway, which invokes 3 different Lambda functions, who in turn fetches a URL from a DynamoDB table and returns that to the client. So the client is able to fetch a new image from the S3 bucket. So with that architecture, let's try to create a few experiments. So what if my function takes an extra 300 milliseconds for each invocation? What if my function returns an error code? What if I can't get data from DynamoDB? So those are the what ifs. So our hypothesis in this case is if we inject failure to functions, then my application will use graceful degradation. So this is the serverless chaos demo site. As we saw in the architecture diagram, it has 3 Lambda functions being invoked every 5 seconds, fetching a random URL from a DynamoDB table and loading an image from S3 object storage. Every invocation is 200 to 300 milliseconds. The 3 Lambda functions have the failure Lambda npm package installed, and their handlers are wrapped, and through that they get their configuration from a parameter each in Systems Manager parameter store. So let's look at the parameter for function 1. The configuration is done through JSON, and we can see that it is disabled right now. This Lambda function has its failure mode set to latency injection and with a rate of 1, meaning that failure will be injected on each invocation. It will inject a minimum of 100 milliseconds and a maximum of 400 milliseconds. So let's enable it and see what happens to function 1. Well, as we can see, the function is still working and new images are being fetched. But looking at the invocation time, we can see that it, as intended, takes somewhere between 100 and 400 milliseconds longer for each invocation. So by doing this, we're able to simulate different failures involving latency. So let's move on to function number 2. This is the configuration for function 2. It is disabled for now, and with the failure mode set to status code. With that, we're able to inject a specific status code, in this case 404 instead of the normal 200 you would get from a successful request. We can also see that the rate is set to 0.5, meaning that failure will be injected on roughly half of the invocations. So let's enable failure injection on function number 2. All right, now we can see that function 2 is returning status 404 and not loading new images on about every other invocation and 200 on the rest. So by injecting failure this way, we can verify that our application handles status and error codes in the way we intended. And now finally function number 3. it is disabled, and function 3 has its failure mode set to deny list. And in this case, we have deny listed calls to S3 and to DynamoDB. But it could, of course, be any service or any third party in use. So let's enable deny listing on function 3. And as we can now see on function 3, it has now gone from loading new images every 5 seconds to not loading images and instead giving an error by blocking connection to DynamoDB and simulating a service outage. So this was an example of how we can quite easily inject failure into the functions in our serverless applications by adding latency, manipulating status codes, and deny listing connections to downstream services. All right, so you remember this from before, from the reliability pillar of the AWS well-architected framework. Chaos engineering should be done regularly. Well, I actually cut it off. This is the full quote. Chaos engineering should be done regularly and be part of your CI/CD cycle. So let's look at that then. This is the serverless chaos demo Canary site. Sure, it's just one user on one page in reality, but it lets us imagine that we have 12 different users accessing a specific function in our application. In this case, the same image loader that we saw in the earlier demo. So we have this single function serving those 12 users. Now we want to do our chaos experiment with a small blast radius to only affect a small percentage. And the way we did it in the previous demo wouldn't really work. So that was more of an all or nothing approach. Using canary deployments is a proven method for rolling out features by traffic shifting from the original to the replacement over time. And this is something we can use for limiting the blast radius of our chaos experiment. What we can easily do is switch between parameters using canary deployment. So we have one parameter that is disabled for the users that shouldn't get failure injected on invocation. And we have one that is enabled for users that instead should get failure injected on invocation. So I'm deploying this using the serverless framework and using serverless plugin canary deployments. This in turn takes care of doing the deployment for us using AWS CodeDeploy. So everything here is done through code. And we have our two parameters, the disabled one and the enabled one. The failure mode is set to status code, and it will throw 502. The deployment setting is canary 10%, 5 minutes. So 10% will shift to the replacement, the one with the chaos experiment enabled, before all traffic shifts after 5 minutes. Now we just need to change which parameter to use. And then deploy. Here we go. Now that kicks off a canary deployment using AWS CodeDeploy. Okay, so it's in progress. It has done the pre-deployment validation and has now shifted 10% of the traffic from the original to the replacement. Looking at the site, we can see that it is starting to throw errors on a small number of invocations. But looking at it, we can also see how canary deployments actually work with Lambda functions. So even though we have a smaller blast radius in that we're injecting failure on about 10% of invocations, we don't have a smaller blast radius in regards to the number of users potentially being affected. So that's something to have in mind. But we have successfully done a chaos experiment by including it in our deployment pipeline through canary deployment. All right, so I want to jump back to this just as a reminder that chaos engineering should be done regularly from the reliability pillar of the AWS well-architected framework. So in summary then, serverless doesn't make your application resilient, even though the services in themselves are robust and reliable. How you build your application is how you make it resilient. Patterns, practices, and so on. Chaos engineering helps us find weaknesses and fixing those. Chaos engineering is about building confidence, both in your application and in your organization. And chaos engineering should be done regularly. And remember that chaos engineering isn't rocket science. Anyone can do it, so you can do it. All right. So if you want more, there's lots of links to the different libraries. Follow Serverless Chaos on Twitter. Try out the Serverless Chaos Lab. And I have some more videos and repos on my website. All right. And with that, I'm Gunnar Grosch. Thank you very much.
Awesome. Thanks. And here we have Gunnar live on stage. Hi, Gunnar.
Hey, how are you?
I'm very fine. I hope you are fine as well. So, hi to Sweden, I guess. Yes.
Yes.
That's
Sweden.
really
Sunny
cool.
Sweden right now.
Ah, nice. Okay. So, yes, thanks for this awesome talk, I guess. So we really now went from CI/CD to production, and then you enlightened us that we should do it in CI/CD as well. The chaos engineering, I also learned something new. And so we have one question from the audience. It's a little bit long. It's from Adrian. So how do we have to do our experiments? And so should we use a production environment? And this might be difficult. And the main problem he describes is how to copy the data, especially in AWS, from one account to another. So this is one question, and the other is like, why should we really do it in a production environment? So it's actually like two questions.
So let's break them apart then.
Yes.
The first part is, no, we don't have to do it in production. And I'd say that we shouldn't start by doing it in production. So even if we don't have the same perhaps data, the same traffic and so on to our staging or development and so on, we can still do these quite basic experiments and see, for instance, what happens if a service isn't responding the way it should and that we expect it to. Because those things happen. No matter if there is traffic or not, we should then know that we have a fallback in place, or we have some way a graceful degradation, or we're using patterns that makes our application work as close to what we intended to, even though there are issues with it. So we can start doing our experiments in other environments than production. And the other part then is also that if we don't dare to do our experiments in production, it usually tells us that we know that something might break if we do the experiment. So that actually tells us that there is something for us to fix before we do the experiment. Because if we believe that doing this experiment in production will affect the users, we shouldn't really do that experiment, because our applications should be reliable enough for us to do these experiments. we often use Netflix as the example for chaos engineering because they started it all. They invented what's called chaos engineering today. And they do their experiments completely in production. All of us Netflix users, we are constantly being experimented on, but they expect their application to actually withstand those experiments that they do. And that's where we want to get to, but it's a long way to get there, of course. So start in test, start in dev, and so on, to test these basic fallbacks, these smaller things that you expect your application to handle.
Yes, thanks. Yeah, so Netflix is usually like the end boss of chaos engineering, with like failing over entire regions. But yeah, we should start small. Do you have? There's another question. Okay, so I think so. Adrian has a follow-up question. I guess it's a little bit about like what happens if experiments, let me try to figure it out, like experiments if they modify data. So should like the question could be like, should we modify customer data or make experiments with this, or is this like out of scope for chaos engineering?
I think there are companies doing those types of experiments as well, depending on what industry you're in, what type of solution you've built. But it's always, of course, important then to have ways of stopping the experiments before it actually causes negative impact to customers, to users, and so on. And ways to roll back if you actually do changes that might affect the user.
Yes.
But what's quite common is to have different type of call them test users or experiment users that you perhaps use while doing the experiments. So that the data affected might be a cloned user or something like that. That's quite common.
Yeah, or you use the free users of your platform for experimenting more than the paid users.
I usually say that we should test on Norwegian users.
Yes, that's also a great possibility. And yes, I think so. I think what you showed in your demo is that you can always switch off the experiment. So if you see that something goes wrong, you can stop it immediately. So I guess this is really like this is always this discussion with deployment versus release, and we should really decouple deployments and releases. And we can also handle a chaos experiment as a release. We can turn it on and we can turn it off again via a feature flag.
Yes.
Okay. So yeah, I guess we are already up with our Q&A time. Let me look at the schedule. Yes. So you will be still around in the Discord channel, I guess. This is really cool, and yeah, thanks again for having you. This was really great talk, and I really enjoyed it. And yes, so thanks again, and then I would head over to Jonas again, and yeah, see you soon.
Yes, actually, next is a short break again. We are taking again off approximately 10 minutes until 2:50, when it's the time for Teri Radichel. So make a short break, and we'll see you in around 10 minutes. Welcome back, everyone. We're continuing the program. And the next talk will be by Teri Radichel. Some of you already know her, as she is also part of the big and worldwide serverless community, and has been since day one, actually. She is a founding member of the AWS meetup in Seattle and has worked as a researcher, a programmer, and a manager, mostly in the field of cybersecurity. No wonder her talk is also going to be about cybersecurity. It's called Defending Serverless from Cybersecurity Attacks. As always, there will be a dedicated Discord channel on this talk, and hopefully she'll be online there as well. We will collect some questions and then after the talk have a Q&A with Teri. The Discord link is down here, and there you'll also find the dedicated channel for Teri's talk.
Yeah, it's actually called Cybersecurity, so it's already there. You can ask questions there, and we will collect them.
Exactly. So let's get right into it.
Hi, thanks for joining me for Defending Serverless from Cybersecurity Attacks. I heard something interesting, and that is that a lot of developers are coming into the field and learning to program in serverless environments. And what that means is they don't have to deal with things like setting up servers and operating systems and also configuring containers, for example. It makes things much easier. I remember when I started learning Java and I spent so much time just setting up my development environment. It was very difficult. And now you can come in with some of these programming languages and just drop your code into a serverless container and you're good to go. And that's great. But we have to remember that even though it's really simple, we still need to think about security. And those are some of the things that I want to share with you today. All right, so a little bit about me. My name is Teri Radichel, and I run a company in Seattle called Second Sight Lab. We do two things. The first thing we do is help companies understand if their cloud environment is secure by performing pen tests or security assessments. And the second thing we do is some training. So we focus primarily on cloud security training. You can find me on Twitter. My handle is just my name. It's pretty easy. I am an IANS consultant, and what I do for IANS is phone consulting. So if you sign up with them, you can ask myself and a number of other security professionals questions. And I also write some things for them and working on some webinars. I wrote a book called Cybersecurity for Executives in the Age of Cloud. If you want to learn the fundamentals of cybersecurity, this book is hopefully easy enough for most people to read, and it focuses a little bit on how these security fundamentals apply in the cloud. I'm an AWS hero, so AWS nominates some people to be heroes, and we speak around the world. I also run a meetup in Seattle with my buddy Colby Allen, and we have about 3,000 members, and I write a lot of blog posts, so I think that may have contributed. And I have a bunch of certifications if you want to check it out. Some people think the GSE is one of the hardest to get in security, and I have that. Also have a Master of Software Engineering and a Master of Security Engineering, and I try to use those skills together to help people, especially in the cloud. So serverless is secure, right? We have nothing to worry about. It's just a function. I think you can tell by the picture on the slide that I'm kind of joking, maybe being a little sarcastic. This picture represents all the leaky S3 buckets we've seen in the past. It seems like the bucket leakages are going down, but we've had other types of problems in the cloud. I'm going to talk about some of those. Serverless involves a lot of different things. Serverless has evolved to include other things besides Lambda functions, or if you're in Google Cloud or Azure, they all have functions. A lot of the things I'm going to talk about today are there in all three clouds. So if I say Amazon, it's also there in Azure and Google. There are differences. I do a lot of deep dive research on the three cloud providers, which I present in my class. But for the things we're talking about today, they pretty much all have these capabilities. Of course, there are differences in the details and the implementation, but for the most part, you can leverage these things I'm going to talk about today across all three cloud providers. So what happened in serverless is when Lambda came out, this was where the word serverless came from. I was there at reInvent when they announced Lambda functions. I didn't quite understand it. Later, I went to a meetup at Amazon and I was like, oh, serverless, that's pretty cool. And immediately saw lots of applications for this sort of functionality, this event-driven function that you could use to write applications. But what happened is there are people who are newer to it and they think serverless is much more than that. So I was talking to a woman at an AWS influencer conference a while ago, and she said that no, everything that you don't have to configure for a server for is serverless. So a lot of people consider things like S3 buckets or Google storage buckets or Azure storage accounts also to be serverless, and queues and a lot of these other things where you don't have to configure a server. And so what happens is people are putting all these things together. Most of you probably know this here at a serverless conference, to connect all these dots and create these massive serverless architectures. And you have companies like iRobot, who is pretty much all serverless. I have a friend over there, and I think they're pretty much all serverless. Maybe there's a few things left, but really focus on creating their whole infrastructure in a serverless environment. And what that means is you have to look at security a little bit differently. So let's think about the first difference with serverless. You have the cloud platform itself, and you're running these functions on top of the cloud platform. I'm going to primarily talk about AWS, Azure, and GCP, but there are a lot of other cloud providers out there. I know this because I see them hitting my home networks, and I look them up, and I'm like, wow, there's a lot of different sort of virtualization solutions out there. One of the things you've got to think about when you're picking a cloud provider is, if they're sending a lot of bad traffic your way, those people are your neighbors. So you want to focus on cloud providers who aren't sending a lot of bad traffic, I would think. And I have not seen a lot of bad traffic from AWS, Azure, and Google. In fact, Azure just shut down a whole bunch of bad actors on their cloud environment. I know AWS has a policy to do the same. So these cloud providers are pretty secure. They know that their business depends on security. And if you think about the parts of the security that you have to manage versus the cloud provider, the underlying cloud provider security is going to get fixed very fast if there's a problem. So if you look at this picture that I have on this slide, there is a cloud, and the cloud represents the cloud platform. And then there are all these dots, and these dots represent customers. The cloud provider, if they have a vulnerability, they're going to fix it very fast. And all those dots are going to have the problem solved immediately. But if one of those red dots, one of those customers that has a vulnerability, fixes their problem, all those other red dots still exist. So what do we need to worry about in a serverless environment? Look at recent breaches. A lot of the things that are happening in recent breaches are things that can happen in a serverless environment, the same way they can happen in other environments. You can find a lot of information about breaches from different sources, such as the ones I have listed here. You can follow people on Twitter. I try to report about different breaches and talk about what caused them. You have things like the Verizon Data Breach Report, which provides statistics not only of breaches, but in different industries. A lot of these same attacks are going to apply in a serverless environment. And why are these breaches happening? This is something I look at a lot because I try to get to the underlying cause of the breaches to help people do things to prevent what is causing them. And one of the big ways that breaches happen are mistakes happen. If you look at a lot of the breaches, it's not some sort of massively complicated attack. There are very simple things causing some of these breaches. One of them being misconfigurations in the cloud. This is definitely something that can affect a serverless environment. If you look at this report from Accurus, the State of DevOps report from summer 2020, you can see that over the past few years, we've had over 200 breaches, which have exposed 30 billion records. So we have this scenario right now where the number of breaches reported is actually going down, according to some reports. This presumes that people are actually reporting all the breaches. There are a lot of regulations that are costing companies money now, and I sometimes wonder if this is affecting the number of breaches reported. But even though the number of breaches reported is going down, we have an increase in the number of records exposed. Now, if you look at why this is happening, you can say, well, someone made a mistake. But if you dig in a little bit deeper and you think about it, this is something I talk about in my book. The roles and responsibilities of people in the cloud are changing compared to what we had on premises. And we're lacking some of the governance that we used to have and some of the processes and controls that we used to have in the on-premises environment. So this is something to be aware of when you move to serverless. What else could go wrong? Well, serverless is still running software, and a lot of that software can be vulnerable in similar ways to the past. So I don't know how much you know about Equifax if you're from other countries, but when I went to Australia to teach a class, they told me they heard about Equifax when the breach occurred. So maybe you have heard of this. But basically, Equifax is one of 3 companies in the United States that houses data to tell organizations that want to give people loans, like car loans or auto loans, for example, do they have good credit? So this is, as you can imagine, very sensitive data. And one of these 3 organizations that houses this data was breached in such a way that almost every American's information was stolen. And how did it happen? It was a flaw in open source software, Apache struts. It was a serialization flaw. And this is a type of flaw that can exist also in serverless. So you have similar types of software running in a serverless environment that could also be vulnerable. I know this because I was testing out .NET in a Lambda function, and I noticed that when I entered a certain malform request, which is not intentional, even though I am a pen tester and I do that a lot, this was just me making a mistake. And I saw that serialization was used at some point in that .NET Lambda function. So I don't know if this is a function of, the way that .NET works, or if it's a specific implementation in AWS, but serialization is still there, and it has been the source of many flaws. After the Equifax breach, someone from Oracle came out and said, we're going to get rid of serialization because it causes way too many security problems and bugs. And I don't know if they actually did that or not, but if you also go read the OWASP guidance, I'm going to talk about OWASP in a minute, they say if you can get rid of serialization. So it's a source of a lot of security problems. It can run in your serverless environment just like it can run in other types of applications. I think that a lot of customers should focus on their own code instead of worrying quite as much about the cloud provider. You still want to keep them honest, but your code is still vulnerable to a lot of the same flaws that are causing breaches. And so you want to make sure that your code is well protected. So if you haven't heard of OWASP, it is the Open Web Application Security Project. You want to go take a look at that. They have a lot of resources for secure programming, which are very good. And one of those resources is the OWASP Top 10 Security Flaws in Web Applications. So they came out with the OWASP Top 10 for serverless, and I wondered if it was going to be different. But basically what they did was they interpreted the top 10 for serverless. And so you can go out there and look at that. They will provide implementation of all the different types of attacks, the top 10 attacks in a serverless environment. So they'll show you how it works. So these same type of flaws work in a serverless environment just as they did before. So let's take a look at injection. I like to say injection is the root of all evil in software programming. It is the way attackers will most often get in. They will find anywhere that they can insert something into your code, whether it's from a cookie or a URL or a header or a user interface. Anywhere they can insert data, they will try to insert malform data. And if you are not properly checking that data to make sure it's what you expect and what you want, it could cause a security problem. The classic example is SQL injection. And as I show here, someone is grabbing the parameter named ID to use in that query. Now there's a problem with this code. You never want to write code like this because I can insert something malicious into that ID parameter in the request, and that can result in SQL injection. So in this case, you have a URL that's passing in the ID, and I can intercept that request potentially and change that ID value to something malicious as shown here on the screen. And this particular value will cause the query on this picture to return all the accounts, when in fact, the code intended to only return my account. So if you have this sort of flaw in your website, this could be a bad day. Here's another example. This is actually an example from a penetration test, which is really interesting. I was asked to perform a pen test on APIs. And I don't necessarily recommend testing only your APIs. I think you will miss things that way, but that's what this test was, and it was very interesting. And so what I did was I wrote some functionality to write curl requests to call this particular API, and I injected bad values. I have tons of bad attack strings that I use when I'm pen testing. And this is just one of them. So I put this into the request, and you can see here I'm running curl, and the part that I have highlighted in yellow is my attack string where I'm trying to perform a cross-site scripting attack. This is the request, so it's sending this request over the server as I put, and then the response was an error, a 403 error. But the interesting thing here is that it returned the JWT token to me. So if it's my token, that's not a big deal. I got my own token bag, knocked myself out. I can hack myself. But if I could somehow get someone to click a link that somehow returns this to someone else that shouldn't get the token, that could be a problem. The other thing is this could be going into logs somewhere. So what if someone who controls those logs is able to get someone to click a link, have this spit out in the logs, and get someone's token and use it for an application? This could be a problem. So I thought about this for a minute, thought, well, maybe the token, it may or may not be a big deal. I probably don't want that there, but well, what if I put some code in there for a cross-site scripting attack? And the classic thing to try for cross-site scripting is a script alert one script. I mean, I have a lot more advanced ways of testing this now, but I put this attack string in place of the token when I submitted the request, and guess what happened? Yep, I saved it to a file, and sure enough, I have a cross-site scripting flaw. So this is a completely serverless environment. I'm testing APIs, and this is the result. You can have things like cross-site scripting. You can have a lot of the same attacks in a serverless environment that you have in a non-serverless environment. So if you think about a function, functions are APIs. And there are a lot of ways to attack APIs. And in fact, attackers are really going after your APIs right now. So you have to be really careful with your APIs. And don't assume that because you didn't tell anyone about the API that they don't know it's there. They will find it. So one of the ways that I attacked these APIs in this particular case was using a method called fuzzing. And there are some tools out there will help you with this, but I actually wrote my own because I wanted to have a little bit more control of the process. And this thing you see on the left-hand side here is a Swagger file, or otherwise known as the Open API specification now. And these are really cool. I helped a company move to the cloud, and one of my architects brought this up and wanted to use it. And I thought it was great because using a Swagger file, you can create a definition for your APIs. And we had different teams building different APIs, and the different teams now can see the definition of the APIs, how you're supposed to call them, what parameters you can pass to them. And the QA team can also test them more easily and write automation because they can read the Swagger file and do automated testing. Well, guess what? It's also great for attackers and pen testers like me. So I wrote some automation to basically attack every possible function, every possible way I could, because I could see the different values there. And I'm still revising this fuzzer, making it better and better, but it's pretty cool. I can get a lot of coverage. So some pen testers will come in and they'll try to be stealthy in your environment. And there's a good reason for that. You want to test to see if your team can figure out whether or not, if there's a security issue going on, you want to see if they can find it. So that's really important. But in my case, I go for coverage. So I want to take all these different APIs, all the different methods, and even the methods that aren't allowed, and I'm going to test them all and see if I can produce some sort of error. And that's the kind of thing you want to do in your service environment with your APIs. You want to make sure that you have protected every possible input and every possible parameter and every possible way those could be called to make sure there's no sort of problem in those API calls. So those are a couple examples. You can go over the whole OWASP top 10. And by the way, those are the top 10. I just gave a talk for AWS Women in Tech Day where I went over a lot of the things I find in penetration tests. And there are even more things that I couldn't talk about because there are so many. There are a lot of other different types of software attacks listed on OWASP. So go take a look at those and become familiar with them. And you can also take a look at the MITRE attack for cloud. And a lot of these things are applicable to serverless because you are going to have issues with your configurations in the cloud. So MITRE will help you with that. So another thing attackers try to do is maintain persistence. So they'll attack your environment and they'll try to maintain persistence in your cloud. and get a foothold so that they can continue to send commands and continue to control your environment. So you may have heard of breaches that have lasted months or even years before someone figured out that they were breached. A lot of times with ransomware, they'll be hanging around in your environment for a long time before they actually pull the trigger and ask for the ransom. So how would you get persistence in a serverless environment? And I've seen a lot of people, security researchers, talking about the fact that the temp directory is cached for a little while. To me, that's not super interesting. That's still a limited time frame that you could get an attack. You could do it, but I think there's much more powerful ways to get persistence in a serverless environment. And what you need to think about is how someone could get into your code and affect you that way. And this is one of the sources of the Magicart breaches, where attackers are able to steal credit cards. They are inserting code into content management systems, and they're also including third-party code in those systems to get sort of a persistence in those web pages where they can steal credit cards. Someone could do that in your serverless environment. They could attack your website the same way. They could also try to get into your GitHub account and get code into your GitHub account if it's not secure. They could try to get into your deployment process. So there's a lot of different ways that they could try to get into your code and maintain persistence. And I think that's one of the things you need to think about in a serverless environment. So besides the code, you have to worry about all those other components I showed you in the beginning and all the different infrastructure that you're using related to the serverless environment. So let's go through some of these. Of course, you have to worry about IAM, and a lot of people have already talked about this, but when you create a function, you need to make sure that it only has the permissions that it needs to do what it's supposed to do. For example, when you create a function on GCP, it has what are called editor rights by default. A lot of the defaults in Google seem to be very broad, so you want to be really careful if you're using Google Cloud and make sure your defaults are what you want. Or not use defaults, use very restrictive permissions. So what happens is if you have something that has a lot of permissions, it could be leveraged in an SSRF attack where an attacker uses that resource to get at something that they can't get at directly. Or they could try to pivot, which is a little bit harder to do in a serverless environment, but they could try to pivot to some other resource. The other thing they can do is try to escalate privileges. So let's say you give your Lambda function IAM permissions in AWS or some permission in any cloud that allows them to deploy new resources. What if they could deploy a new resource that has more permission than they have themselves? This is escalation. It's trying to get more permission than you should have. I find secrets in all the things when I'm doing pen testing. And we also just heard about an attack on Twitter where someone had put credentials in a Slack environment. Don't do that. You want to make sure your credentials are always stored in a secure key vault, and each of the 3 big cloud providers has this. Additionally, you can use something like HashiCorp Vault, which is an external tool. So you have all these different sources. I have found credentials in CloudFormation scripts. I've found credentials in Lambda environment variables, in Lambda code. Even as 2 years ago, I talked about at RSA, I did a presentation with Colby Allen on basically pivoting around and using credentials in an S3 bucket for a Lambda function. This came from an example on the Amazon website. So these examples are out there, and you need to make sure your developers know that those credentials should go into a vault. At the bottom here, this is interesting. There are shells. So for example, in Azure, you can just go up and click on the button at the top and hit the shell and start typing commands. What happens when you start typing credentials into that code? There's some sort of storage bucket behind this, backing it up. There are log files. Where are the credentials going when you type them into these shells? It's something you need to think about. Another thing is that you want to make sure you're using encryption, but encryption doesn't always save you. So in the case of Capital One, for example, the data was encrypted, but the problem was that the host that got compromised had permission to decrypt the data. So even though data is encrypted, if someone has permission to decrypt it, that doesn't help you. When you create encryption keys, the cool thing in the cloud providers now is that you can give specific permission to specific people to decrypt things with various keys. So, you can change that default policy, and you can make it such that only certain people can decrypt the data with that key. So you also want to think about your network. when you set something up on any cloud environment or even your home network, immediately it will be attacked or at least scanned by so many things looking for flaws in your environment. Don't give the attackers the chance to even do that. If you have something that doesn't need to be on the internet, make sure it's not there. And there are mechanisms now in all three cloud providers to create network controls related to your serverless functions, so you don't need to expose them to the internet. You want to be really careful with third-party code. I wrote a blog post about this if you want to go check it out. Third-party code can be used for injecting data. I already mentioned the Magic Card or the credit card code being injected via some third-party library. And there are other types of flaws that can happen with third-party code, such as, you reach out to get that Google font and then there's some sensitive data that's passed along in the referrer. So you want to be really careful using that third-party code. Make sure you know where it is. You probably want to pull it into your own repository, scan it, validate that it hasn't changed between the time you had it in development and test and the time you put it in production. A lot of people are using serverless frameworks to help them deploy their serverless environment. Just understand what your framework is doing. So I just quickly did a search around and I found this serverless framework. I haven't used it and I don't know exactly what this particular functionality does, but I just saw that, oh, this serverless framework can create a role and attach a role to a policy. What can it do? Can it create an admin role? I don't know. You want to make sure you know what these serverless frameworks are doing and if they're secure and what sort of permission are you actually giving them. You want to make sure your API gateways are set up securely. So you could have a poor architecture and misconfigurations in your API gateway. For example, an API gateway could be configured with a key that is used to access the APIs. And if you give the same key to all your customers, that's a really poor design. There was a security product that actually had this sort of configuration problem where all customers used, I guess they used some software to access the security product in the cloud, and they all use the same key. So a security researcher found that he could use the same key and pull out all sorts of other data from other people, other customers of the security vendor. So you want to make sure you're using good architectural models, and definitely do use an API gateway. It will help you. You want to centralize your authentication and authorization if possible. You want to think about monitoring. Maybe you're going to put a WAF in front of that. Who knows? But you want to make sure you're using those API gateways and setting them up correctly. So a lot of people are using CDNs, and there are CDN services on each of the cloud providers. And what these do is they'll push the content out closer to your users, so they will have a better experience. And the problem is that these CDNs also have things that can be misconfigured. For example, they have CORS configurations usually. I like to say CORS misconfigured is like someone comes up to you and says, give me all your cookies. And you say, okay. I wrote a blog post about this if you want to go read it. You also have to think about the caches. Could someone trick these CDNs into caching evil code? This has happened. You can turn off that cache in these CDN providers if you don't need it. Also, think about how you configure your CDNs so they can't be bypassed. So the attacker just can't go around them. If you're using them, for example, with a WAF, which you can do on AWS, you can configure that to work with your CDN. Well, if someone can just go around that CDN and get straight to the resource behind it, then your WAF is not really helping you. Some cloud providers let you move functions out to the edge. I was actually testing one of these and started thinking, wow, could the credentials be cached in my CDN out there in the edge? And sure enough, I contacted support and talked to them about it, and yes, they can. So you want to understand when you're pushing these out to the edge, what is the implication of that? The other thing is sometimes the logs are different. For example, in AWS, when you use Lambda at edge, the logs for your functions at the edge will appear in the region where the function was called. And this can get really tricky to keep track of your logs. You want to be aware of that. I see a lot of authentication problems on penetration tests, and this is definitely a problem that can happen in serverless environments. So one of the big ones is just, forgetting to put authentication or authorization in front of a particular resource could be accessed without those things. And the other thing is I see problems such as a JWT token that someone checks for the existence of, but does not check the actual permissions in the token. So what can happen? I can access someone else's resources. I can swap out a request that they were making with my token and it will still work. So when you're using JWT tokens, you have to verify the signature, you have to verify the permissions within the token and that the token exists, not just that the token exists. So we still have databases in serverless and all these things apply. We used to have DBAs, database administrators, and in some cases companies still do, but in some cases this is being handed off to developers. And there are a lot of issues with database security that need to be considered. You need database integrity, you need to have reconciliation in the case of something like a financial account. You need disaster recovery. You want to be able to recover from ransomware very quickly. And that's a pretty complex topic. Attackers are still getting to backup, so you have to really have an air gap backup. Do you have people who are trained to handle these complex database issues? DNS is another one you have to worry about in serverless. For example, I had someone tell me the story where they set up something at Zendesk, and I'm going to use my website as an example. Let's say I wanted my customers to go to Zendesk at secondsitelab.com. I would set up what's called a CNAME in my DNS, and I would point over to Zendesk. And what happened is this company did this, and in this case, an attacker, or actually it was what I call a security researcher, but I use that term loosely, came along and said, hey, I'm going to register that domain name over at Zendesk because the company had terminated their Zendesk account. So it was free over there. So the security researcher came along, grabbed that Zendesk account and set it up. And then they started getting requests for support because the company may have had links on their site that they forgot to remove, or someone had bookmarked the support link. And so they were still going over there and submitting things to that old Zendesk account. So this security researcher came back and said, hey, will you pay me because I found this problem? And so the company did, and found out that the researcher was actually seeing sensitive data. So the moral of the story is, when you have these third-party services that you're using and you point a CNAME to it and you decide to cancel the third-party service, you want to make sure you cancel the CNAME when you're done with that service. And the other thing you have to worry about with DNS is you have packets going back and forth with DNS, and DNS packets are very sort of complicated in the way they're set up, and there's a lot of places where attackers can insert data or exfiltrate data in DNS, and they have done this. So they could create a tunnel potentially through DNS. So depending on how you're using your DNS, you have records going back and forth that data could be escaping you don't know about. You want to be absolutely looking at that packet layer and using DNS protection to make sure that's not happening. And you could also have log issues. So you want to make sure your cloud provider is logging all the things that you need to see in your DNS records. So another thing you have to worry about in serverless environments are deployment systems. Who can deploy the code and how? Because if someone can get access to your deployment system, they can deploy anything they want in your cloud environment. This is a problem. So you want to make sure you really have locked down that deployment environment, and that only the correct people can get in there and get at your systems and your data and deploy things. This is something I think sometimes gets overlooked, and there have been a lot of cases where Jenkins servers have not had their patches up to date and have been taken over, and there are other types of attacks as well that can get access to Jenkins server. And if people have a lot of permissions who are using Jenkins to do a lot of things, if they can get into that person's account, they can do a lot of damage in your cloud. Another complex thing with serverless is monitoring. Sometimes you have all these different components of different functions that are calling each other, and then you have an error, and maybe it was produced by a security incident or a security problem, and you have to find what caused that error. So first of all, the Lambda functions are all gone. So security people sometimes like to look at memory in a serverless environment, and that's not going to be there. I mean, I talked to someone about the interesting capability potentially of grabbing memory from a function, but it's not very realistic for many reasons. So you're going to have to figure out, if you have the monitoring in place, there are tracing services from all the 3 cloud providers that will help you trace transactions through your serverless environment. You want to make sure your developers are logging things that are helpful for any sort of security incident in the cloud. And you just want to look at all the different options you have there for logging and make sure you have what you need before the security event occurs. There are also logs for all these different services in the cloud. So you have DNS and you have security services, network logs, CDN logs, all these different kinds of logs, not just your function logs. And you want to make sure you turn them on, monitor them. Maybe you pull them down into a SIM if you have one, and make sure you can respond to these events effectively. A lot of the problems in cloud environments are that security teams don't have the visibility because these logs are not turned on, they're not consolidated, and maybe the security team doesn't even know they're there. So you have to, if you're a developer, work with your security team and make sure they have the logs to deal with a security incident. The other thing we want to think about is threat modeling. So threat modeling means we're going to look at our architecture and look at our application and think about what could go wrong. We're going to think about how an attacker might bypass our controls. So I'm going to tell you a story to help you out with this. I had a pen test where a company had a financial website where they had customers upload files to create an account. And I find a lot of problems with file upload forms. So this company had taken some measures to prevent bad things from going into their system. And that was great. But what happened is, as I was looking at the requests going back and forth while I was testing out the system, I noticed that the company was sending data to S3 via a time-limited URL. So 2 years ago at RSA, I told you I did a talk. And one of the things I talked about were these time-limited URLs and some of the problems with them. Once I saw the company was using a time-limited URL, I could take that URL as a person logging into that website and reuse it because there was no sort of nonce, there's no sort of CSRF token. I could just replay the request again and again. And by this point, I don't have to go through the website anymore. I can just go directly to S3. So guess what? I can put malware in that bucket. I can put scripts in that bucket. And it depends how that file is leveraged on the other side to determine whether or not that's a problem. So for example, maybe the company had some sort of virus checker or something that would stop my attack. But if the company would just take that file and pull it up in some sort of admin site and I can put a script in there, then later on that script could run and send me data from an administrator, such as their cookies or their tokens. And then I could log in as an administrator, or I can put malware in that bucket. If I can put malware in the bucket, maybe an administrator opens it and maybe it has fileless malware, so you don't even know it's running in your system, and it connects back to my command and control servers that allow me to send more commands to that administrator's machine. So these are the type of things you need to think about in a cloud environment. You may have some sort of control or protection, but your architecture is such that an attacker can completely bypass those protections. And that's what we do in threat modeling. You think holistically about architecture, not just about a single security controller component. And you need to think about this in the serverless environment, just like anywhere else. So thank you. That's my talk. And again, my name is Teri Radichel. I hope you will follow me on Twitter. I love to share information. If you're interested in anything I'm doing, you can reach out to me on LinkedIn. And my company is Second Sight Lab. I have a blog out there as well. And this is my book if you want to go check it out. Cybersecurity for Executives in the Age of Cloud. Thank you very much.
Well, thank you, Teri. And she's actually here with us. Hi, Teri.
Hello.
Hi.
Hi to Seattle, I guess. How is it over there?
It's a little smoky. We got some wildfire smoke rolling in, but still okay. Dark now, can't see it.
All right. Thanks a lot for your talk. There have been some questions or more or less comments in the Discord channel, which I'm going to read to you in a second. Unfortunately, we have just a few minutes for your Q&A, but still, I wanted to get these comments through. So Adrian 145 says, complexity makes it easier for an attacker to succeed. AWS has a lot of responsibility and should make a lot to make the developers an easy task. Some layers of security, alarms, checks, automated pen tests, etc. The security become a party's responsibility. AWS, managed services, and developers, customers. So I think that's mainly about like the complexity of these services and how security aspects increase with
yeah,
complexity.
so there are definitely shared responsibilities there. So there is a layer of trust with the cloud provider. In terms of the developers' responsibility, yeah, there's some complexity in the architecture, like I mentioned, where you have all these different components. You have to make sure every single one of those different components you're using are configured correctly. So it is a big job, and people need to take the time to really look at the security controls for each of those components and make sure that you've got them set according to best practices.
Yeah, right. Sebastian Hesse writes, the CNAME issue can also happen if you have developer account with a separate URL like employee.dev.company.com, etc. for testing purposes, and the employee leaves and you don't probably clean up their resources. Have you seen
Not
something
specifically
like
with
this,
employees,
Teri?
but yes, any CNAME you create that points to some sort of external service that someone else can go log in and create and control, you will be in trouble. So any sort of service where you take a domain name on your DNS and point it somewhere else, someone could take that over and do something with it, and it would look like it was coming from your company. So yes, you do have to be really careful with that.
Yeah, right. And then one more question, maybe. You mentioned changing roles when going to public cloud and serverless. Can you tell us more about what roles are changing?
Definitely. So I have a background of security and software. So I was primarily a software developer for many years, but I have my own company and I had Breach, and it's on my blog. I posted some links there for you. You can follow that and find them, the stories there. But basically, when I was a developer, I was working in a large financial organization with billions of dollars of assets under management. I had no way to put a database on the internet. It was not possible for me to expose data. There were network segregation layers. There were deployment processes that went through multiple layers and channels to get those things to the internet. So it was not possible for me as a developer. It would be really hard for me to expose data. And now the problem is that the developers are, it's not that they're given the responsibility, it's that they're given the responsibility without the training, and there's no sort of guardrails and checks and balances. And mistakes, just like I put in the slide deck, the funny picture, mistakes happen. I've done it, everyone's done it. So you want those sort of checks and balances to help make sure you don't make those mistakes. And that's some of the things I wrote about in my book that are kind of lacking as we move to cloud.
All right. Thank you very much for being with us. We're moving to the next talk, but I guess you will stay online in the Discord channel. So you people can keep asking Teri. Thanks again for being with us.
Yeah, thanks.
And
bye.
Bye-bye.
Bye-bye.
So, and up next with us is Jeremy Daly, and you probably already know him if you're familiar a little bit with the serverless community. So he has a podcast. He has a newsletter, Off by None, which is like a weekly newsletter, which is really cool. And he is actually also the founder or co-organizer of ServerlessDays Boston. So yeah, so it's really deeply rooted in the community. And today he would talk about a really important topic. It's so the problem is so once you go serverless and everything scales automatically, but what to do with components that don't scale that great and how to fix this. So it's a really important topic, and it's coming really from production issues, or when like serverless hits the reality with legacy systems. And so, yeah, I would say, let's go. He has a Discord channel as well. I always forget to mention the Discord channel. It's Resilient Serverless on Discord. So feel free to ask the questions there. And now we are good to go, I would say.
Hi, everyone. I'm Jeremy Daly. Thank you so much for having me here at ServerlessDays Hamburg. I really wish that we were in person. I'm sure we all wish that we were in person so that we could share this together, but we are going to press on and we're going to learn about serverless anyways. So today we are going to be talking about building resilient serverless systems with non-serverless components. So let's jump right in. So again, my name is Jeremy Daly. I am an independent consultant working with companies building in the cloud. I've been doing this for a very, very long time. I started working with Lambda right after it came out, and have been working with AWS since 2009. I blog, I do some open source work, I do some speaking. I also publish a newsletter every week called Off by None. You can sign up for that. I host the Serverless Chats podcast, and I also have a new series called the Serverless Spotlight that should be launching very soon. So hopefully you will check that out as well. And I am also a serverless hero with AWS. So this is a great program that allows me to get sort of, give early feedback on products and to help sort of shape the future of serverless. So it's a great program that I'm really happy to be a part of. And there's a lot of great people in that program. Okay, we have a very packed agenda today, so we're going to try to get through this quickly. We're going to talk about what is resiliency and what is serverless. We're going to talk about working with less than scalable relational database management systems, because you are going to run into those. We're going to talk about using unreliable APIs. We're going to talk about managing API quotas. We're going to talk about decoupling our services. And finally, we are going to talk about some other non-serverless components. So if we think about resiliency is the ability for parts of our system to fail, but for us to be able to provide an acceptable level of service. So this is not about preventing failure. It's not about it's not about uptime. It is basically the ability for us to understand how to gracefully deal with failure when we get failure. So we're at a serverless conference. Serverless has been around for a very long time, so I'm sure we all know what it means to be serverless. We typically hear things like no server management, flexible scaling, pay for value, and automated high availability. Those are all great, but one thing that people don't always think about when it comes to serverless is that it requires lots of configuration and a deep knowledge of many of these cloud services. And also it's highly event driven. So this is something that we really need to think about when we're designing and building our applications and how we build in that resiliency. Today, we're going to be talking mostly about the flexible scaling aspect of it and how that is going to affect other services that are not so scalable. So let's jump into that a little bit more. So if you think about the AWS ecosystem, and I'm going to be talking about the AWS ecosystem mostly because it is sort of the furthest along, but a lot of these techniques would apply to other services as well, including Azure or Alibaba or some of the other ones that are building out serverless applications or serverless components as well. So if we think about how AWS sort of classifies services, some of them they sort of consider serverless. These would be things like Lambda and DynamoDB, API Gateway. These are things we don't have to worry about provisioning capacity for, or we don't have to worry about sort of capacity planning. These just sort of, you can throw work at them and they will continue to scale no matter what you want to do. Then there's a series of services that are considered managed services. So these would be services like Elasticsearch and Elasticache and Redshift, where you do have to do some capacity planning, but you don't have to manage the underlying infrastructure. You don't have to worry about patching and all that kind of stuff. And then finally, there are things that are not serverless, right? So this is basically anything that's going to run on EC2 and anything such as Kubernetes or Docker or Cassandra, anything you have to install yourself. These are things that are definitely not serverless. All right, so something important to remember when we're building serverless applications, because there is sort of this hype of it scales infinitely. Everything does have its limits, all right? So if you think about reserved concurrency, there's only so many concurrent executions you can run at once. We have function timeouts, which limits how long a function can run for. We have memory limits that are in place. There's network throughput. We can only transfer data so quickly between Lambda functions in a database, for example, or between S3. That's pretty fast, but there are still some limitations. And some of these components are better than others when it comes to scaling. Like even with DynamoDB, you have to think about the scaling of that if you are going to set some limits yourself, which we might want to do. The key point here is just to know your limits, right? And AWS is very, very good at publishing these limits, and so are the other cloud providers. We can go in and you can look and see what those limits of the individual services are. Okay, so let's look at a simple serverless web service if we're thinking about building purely serverless. So we would have our API gateway, maybe call a Lambda function, which then routes that request to DynamoDB. DynamoDB responds, sends that data back to the API gateway, and eventually back to the client. So the great thing about this architecture is that API gateway is ridiculously scalable. Lambda is ridiculously scalable, and DynamoDB is just a power workhorse. So in this situation, it's great because we don't have to worry about there being a component that doesn't necessarily scale well under high load. All right, but if you remember the song by Dire Straits from, I think it was the early 80s, they say, I want my SQL. And that is something to think about when you are building applications, is that developers still want to be able to use relational databases, and relational databases aren't very scalable. So if we take our simple serverless web service and we replace DynamoDB with RDS, which is the relational database service that AWS provides, the problem is that this is not that scalable. So unfortunately, we now get the simple, not so serverless web service, and this has some dramatic impacts on the performance of our application. And that's because relational databases and functions as service don't really play nicely together. The concurrency model doesn't allow for connection pooling, and we'll talk about RDS proxy in a minute if you're thinking ahead. And then you have to think about a limited number of database connections that are available. So if we can't do pooling, then we have to have a new connection for every single Lambda invocation. And the problem with that too is that because Lambdas freeze and they recycle themselves, we often end up with a zombie connection to that RDS cluster, which makes it really hard to then recover those without using something in order to recover those. All right, so let's talk about some ways that we can manage these database connections. So first, we could do something like increase the max connection settings. And this is one of those things where we need to be really careful of, because again, we can spike our CPU. We could limit the concurrent executions, but this is likely going to make some angry customers because they can't access their data. We could lower connection timeouts, but this is sort of a, let's hope that those zombie connections go away sort of strategy, kind of a, cross your fingers. We could limit connections per username. So this is sort of a game that you could play, but again, it's very much so rolling the dice because you never know what's going to happen. And we could then close connections before the function ends, which is an absolutely terrible way to manage your connections because it can take 100 to 200 milliseconds to make that initial connection. And that means that not only on cold starts, but on every single invocation, you're going to have that extra latency, and we definitely don't want that. So these really are not good ways to do that. So if you're thinking about doing some of these things, let's rethink our strategy and talk about some other ways and some better ways that we can actually manage these database connections. So first thing we can do is implement a good caching strategy. We're going to go through each one of these individually. We can buffer events for throttling and to add durability. We can utilize a proxy service. And we could manage connections ourselves, right? And we'll talk about these, but these are all better ways that we can manage those connections to a relational database. So let's talk about a caching strategy. So assuming we have our same sort of simple serverless web service here, we want to get data from an RDS database. So this would be something that's a high read application, okay, where your workload is accessing lots of reads, right? We're not talking about writes here. Rather than accessing the RDS cluster directly, we would put Elasticache in front. We would query Elasticache, see if Elasticache had the data that we looked for. If it did, we just reply back to the customer. If it doesn't have the data that we're looking for and we get a miss, then what we want to do is query the RDS database, whatever that is, MySQL, Postgres, Maria, and then return that data to the Lambda function, which we would then write into the Elasticache. Elasticache isn't a write-through cache, so we do have to manage that caching ourselves. But then we get the data back, and then we write that back to the client as well, and obviously cache it, as that's happening there. So a couple key points here is that we only want to create these connections to RDS on misses. So if Elasticache has our data, there's no reason for us even to waste a connection to RDS. Now, again, once the cache gets nice and hot, chances are you'll be really minimizing the number of connections to RDS. The other thing you want to do is make sure that, again, TTLs are set appropriately. We don't want data to get too stale. And you have to think about a way to invalidate that cache as well. So again, it's not a write-through cache. So we have to make sure that if we update the cache or update the database somewhere else, we also either nuke the data in the Elasticache, or we somehow update that cached record. Now, if you're thinking, wait a minute, you're not supposed to put a cache in front of a database because, the database should be able to handle the connections. That is still the case here, right? So you still need to size that database cluster appropriately. We're just putting Elasticache in there to kind of help with that sort of broken connection model, that FaaS has with RDS. All right, so now the question that comes up quite a bit is, especially when we're doing things that are heavy write applications. So we're writing a lot of data. So maybe a webhook or maybe click tracking or something like that. The question is, do we actually need immediate feedback? And so we have two types of communication that we sort of work with when we are dealing with calling any sort of distributed system. So the first is going to be synchronous communication. We're all very familiar with this. This is simply I make a request, the system does something and returns back to me all in that single request while that is happening there. Now, that's fine in most cases, but unfortunately, it's a blocking request, which means if that downstream system has to do a bunch of work or goes offline, then you immediately would lose, or you wouldn't get any benefit from that. It would be detrimental to your application. It would slow down everything, and it would not be a good way to necessarily approach it. The other option is to do what's called an asynchronous request or asynchronous communication. And these are non-blocking requests. This is when we can hand off that request to some intermediary service that can eventually then process it for us. And this is really great in case something goes down or that we get overwhelmed, and we can buffer those events. And we're going to talk about these in detail next. All right, so buffering events for throttling and durability. If we think about our simple web service again, and we've got our API gateway and our Lambda function, now we want to write data into RDS. Now, again, writes into a database are much more expensive than reading from a database. So unfortunately, we can't just always assume that we can just, of course, you can't cache these. So what we want to do is we want to buffer them. So rather than writing it directly to RDS, we're going to actually put what's called an SQS queue, a simple queue service. We're going to put one of these queues in front of it, and we're going to write all of our data into the SQS queue. So again, these are just going to be events, right? Whatever our payload is that's going into the database, we just write it as a record into, or a message into the SQS queue. Now, once this is handed off, this is sort of an asynchronous request. And then this will act back and say to the Lambda function, hey, I got your data. And then we can immediately respond back to the client and say, okay, we got it. So think about times when you have, a webhook, a big email goes out and you've got all of these open requests or all these open events and all of these click events and things like that. All of a sudden, that's going to overwhelm that database. So instead, we're just going to write those all to SQS and tell the service, hey, we got your data. Then what we do is put another Lambda function, and this Lambda function we're going to throttle, and we're going to limit the concurrency of this so that it sort of matches that RDS throughput. So if our RDS cluster maybe has 1,000 possible connections, then maybe we want to limit this Lambda so that it can only have 700 or something like that. Or maybe we want to drop it down even lower. And then what happens is our Lambda function will actually pull the SQS queue. It'll match that throughput based on the concurrency. This is synchronous, so this will stay open while it makes this request to RDS. If everything succeeds, the Lambda function will tell the SQS queue to remove that particular record. But if something fails, then we can actually write that data into a second SQS, which would be our DL queue or our dead letter queue. And this allows us to not lose events. So if that RDS cluster goes down, if it's running really slow and we're getting a lot of errors, then we're just going to go ahead and save those events and we can look at them later. So some key points here is that SQS adds a ton of durability. So we're not going to lose messages if our RDS cluster is down, and the chances of SQS going down are very, very low. It's completely distributed. It runs multi-AZ. We should not have to worry about that. Throttled Lambdas reduce that downstream pressure. So again, RDS clusters, MySQL databases, Postgres, whatever it is, those can get overwhelmed very, very quickly and very easily. So by having this ability to throttle that, we can make sure that we don't exceed the number of connections, and also that we just don't try to write way too many records into it at once and then kill the whole system. And then finally, like I said, those DLQs are great, or the DLQ is great because we can store those failed events. And not only can we go back and look at them and see why they failed, but we can actually just run another function off of that SQS. If for some reason the data was down and everything ends up in that, or the RDS cluster was down, everything ends up in the DLQ, we can just connect that DLQ to process those records again and just replay them. Now, you don't actually need this Lambda function here. If you wanted to, you can utilize what are called service integrations, and you could just write API gateway directly to SQS, and you can write them directly into DynamoDB and a bunch of other services. But this is just another architectural pattern that'll cut down on a little bit of latency. And again, you're going to use that that Lambda that's throttled anyways, so you can use that to inspect the records and make sure that everything's in the right format. So even if you got some junk in that SQS queue. Okay, so the other thing you could do is utilize a proxy service. So there are a bunch of them out there. There's PG Bouncer. If you're using Postgres, there's another one called SQL Relay. And all of these, unfortunately, though, have to run on an EC2 instance or some sort of virtual machine. And so if you put this in the context of a serverless application where you go from API gateway to Lambda to EC2 to RDS, now you are looking at a pretty ugly serverless application here. So you've gotten away from serverless. You're losing some of the benefits. But if you needed to go down this route, you could definitely do this. And of course, this would apply to other clouds as well. it would be great to get rid of this and use something like Fargate, that could handle these, could handle this a little bit more serverlessly. But again, it's up to you. And then finally, we have this new thing called Amazon RDS Proxy that I want to talk about. Now, again, this is not a silver bullet. All right. It is a very, very cool service. I would recommend, if you could use it, you should definitely use it. But just some of the basics of it, I guess, is that it does pool and share database connections. It will reroute the requests really, really fast when there's a failover. So you don't have to worry about your Lambda functions trying to point to a different database or waiting for DNS to change. It does use IAM credentials, which is very cool in order to control access. You don't have to put your credentials into your Lambda function. Instead, that will be handled at a higher level. And it does have this thing called connection pool maximum connection. So you can actually set how many total connections will end up in a connection pool, which is very cool, because if you have multiple services that are connecting to the same database, then you can use different connection pools to manage that. The problem here is that it only works with Amazon RDS. You still need to do some capacity planning, although, again, it is much easier to do that. And there is an added cost. So you do pay based on the size of your cluster that you are using. But again, if it's possible for you to use, if you're on Amazon and you're using RDS and this makes sense for you, I would definitely suggest taking a look at it, because it does help out. It does help out quite a bit. It doesn't always solve all your problems, but at least will help with that exhausted memory or exhausted database connection issue. All right, so what about managing connections ourselves? So if we were going to do this, we would have to count open connections, would have to close connections if connection ratio threshold was exceeded. We'd have to close any sleeping connections that were zombie connections. We'd have to retry connections with an exponential backoff. So this seems like a lot of work to put into every time we're trying to connect to a MySQL database or something like that. And you'd have to be crazy to sort of build this yourself. The good news is I actually am a little bit crazy, and I did build this myself. Now I'm showing this to you not because I expect you to use it. This is only for Node. This only works with MySQL, right? It doesn't work with Postgres. And the nice thing about this, though, is that this is a way in which you can do some connection management without using RDS proxy. And if you are, again, using data in a couple different ways, maybe you have some spikes or things like that, or you're not on AWS, this package would still work for you. I'm more interested in just showing you how it works, and again, not really telling you to use it. So the first thing would be counting open connections. So if we are using MySQL, pretty easy to do. We can just use the process list to count the active connections. If we exceed some ratio based on the maximum connections based off of what we are currently using and the total connections, then we can go ahead and we can calculate things like what our timeout's going to be. We can try to kill zombies if those connections are old enough. If there are no zombies, then we can just quit and free up that connection. So we can terminate our own connection if we need to. And then if we can't free up our own connection, or if we don't exceed that ratio threshold, we're still going to try to kill zombies anyways. And then we want to close sleeping connections with high timeout values. So again, use that process list, look for those high values, and then kill those connections just using a kill command. And then when we're trying to connect, we want to actually try to reconnect, right? If we try to reconnect and all of those connections are exhausted, the system should work in a way that it will eventually free up its own connections. And so we want to make sure that if we're trying to reconnect, we can look at all these different errors that might exist, try to reconnect with something like jitter, which is sort of it's exponential, but it's also random. So this is something that AWS, I think, came up with that allows you to sort of randomize those reconnects. So if you're just backing off 1 second, 2 seconds, 4 seconds, 8 seconds, or milliseconds, or whatever that connection is, that could be overwhelming to try to all connect at the same time. So the question is does this technique really work? And yes, it does. I used an Aurora serverless cluster with 2 ACUs, simulated, or with 90 connections available, gig of RAM on the Lambda function, simulated 500 users per second for 1 minute. Average response time was 41 milliseconds, which wasn't too bad. And we had 0 errors. So if you think about it, though, this is something we really shouldn't have to do when managing relational databases. Okay, so we do have Amazon Aurora serverless. I really like this, but it doesn't solve that max connections issue. And unfortunately, RDS proxy does not work with Amazon Aurora serverless. So you still have to deal with those connections if you're using that. There's also the data API, which I absolutely love this product. Very, very cool HTTP API in order to connect into SQL databases. It has somewhat of a slower throughput for some things. So I say it's not quite ready for synchronous workloads. It depends on what your SLA is and what you're hoping to achieve. I do use it for some synchronous workloads because it's just easier not having to be in a VPC, which you do not need to be when you use the data API, which is amazing because again, you get other things that you can do, like being able to get free connections to the internet without having to set up a NAT gateway. So that's a very helpful tool to use for that. And then we talked about this, the Amazon RDS proxy. Again, added cost, doesn't necessarily address things like auto scaling, so it's not super serverless in the way that works, but it is still a very good product that that's coming on. So we're not quite there yet, but we are certainly getting there, and they are coming out with better products to really address these workloads that require access to relational databases. Okay, so let's move on to third-party APIs. And basically, in order to manage calls with third-party APIs, we can do a lot of stuff very similar to what we would do to a database. So we can implement a good caching strategy. We can buffer events for throttling and durability. Same thing we did before. If we need to write a lot of data into Salesforce, but we don't want to overwhelm the API, we can buffer all those in SQS, use a throttled Lambda function, and then write to it when we get to them. And then finally, we can implement something called circuit breakers. So circuit breakers are very, very cool. These are used all throughout distributed systems. And it's something that you should get very familiar with because they can be very, very helpful. So essentially what we want to do is, same idea. Let's say we have an API gateway calls a Lambda function and we want to call the Stripe API. Now, again, this doesn't necessarily have to come from a client API gateway relationship. This could be pulling from an SQS queue. This could come from Kinesis. This could come from EventBridge or whatever we want. But the idea here is that we want to be able to somehow control that access to that Stripe API or that third-party API without overwhelming it. And if something happens, we want to be able to back off. So what we would do here is if we normally just called Stripe API directly and got a response back, this is a nice little happy path. But unfortunately, as Werner Vogel says, everything fails all the time. So essentially, we have to think about what's going to happen if that Stripe API call fails, and not necessarily just the request to it itself, maybe not the processing of it, maybe just the response back doesn't get to us. So what we would do is we'd put some sort of status check in here, and we're going to want to coordinate this across multiple Lambda functions. So we would need to use like DynamoDB or maybe ElastiCache if you're in a VPC as a cache for us so that we can save periodically back to these things so that we know. And what we would do is we would check that DynamoDB and say, is our connection closed? If our connection is closed, great. Then we make the call to the Stripe API, and the Stripe API can respond back to our Lambda function, and we can reply back to our client. But if that Stripe API is to fail, now our Lambda function has to think, okay, what am I going to do? So what we want to do is increment the failure count in our Lambdas as well as in our database or in our ElastiCache cache so that we know that we're starting to see more failures. And once we reach a certain point, then what we want to do is actually make it so that we open the circuit. And when a circuit's open, electricity can't flow through. When a circuit's closed, electricity can. And so now we are going to stop sending requests to the Stripe API and instead just reply back directly to our client and say, I'm sorry, we can't connect right now. Now, again, if this was in SQS, then we might be able to send those back to a DLQ or retry them or whatever. So we can't just sit back and wait and hope that someday that the Stripe API will be back up and running. We have to be aggressive and make sure that we check on it. So every once in a while, we would send what's called a half open request. If the Stripe API fails, at that point, we just say, okay, great, it failed. We can stay in the open position. But if it succeeds, then what we want to do is update DynamoDB or ElastiCache, let it know that the circuit is now closed, and we can continue to send data through that way. So a couple key points here is that, again, we don't always want to be calling DynamoDB or ElastiCache to check the status. We can actually keep a count in our Lambda functions, in our warm Lambda functions that kind of know how many failures have happened. And the reason this is fine is because you're going to use some sort of reasonable failure count anyways. So you're not going to fail after one. It doesn't have to be highly coordinated. It just needs to be loosely coordinated. And then that way, but you do want something reasonable. So if you have a high velocity thing where you have 1,000 calls per second, then maybe you want to fail after 5,000 calls. If you have something really low velocity, like 10 calls per minute, then maybe you want to wait, 10 minutes before you stop sending things. The idea here is just to make sure that you're not overwhelming that API, because the worst thing you can do is for an API that's running slow is send more requests to it. All right, and then understanding idempotency. We haven't talked about this, but basically understanding that when you send a request to an API, you want to make sure that if that's going to have some sort of mutation, you don't want that to have a ripple effect. You want to make sure that every time you send a request, that it's going to have the same effect. And it's not going to increment counts or something like that. Stripe API has a very good service for doing this. They have what's called an idempotent ID that you can send in some verifiable hash of the event or something like that, where then you can make sure that it doesn't process the same event twice. All right, what about quotas? All right, if we were to build something to deal with quotas, we have to think about this. Concurrency has no effect on frequency, and that means essentially that we cannot. Even if we set our concurrency to 50, it could take half a second to run that, and we could run hundreds and hundreds of invocations in a minute if which wouldn't matter to our actual quota. All right, stateless functions are not coordinated. Step functions would be expensive. If we added state, that would cause needless invocations. If we had to run the function to check to see if we're over quota, then we'd be basically running an invocation every single time. So could we build a better system? Yes, we absolutely could. It would have to be serverless, cost-effective, scalable, resilient, efficient, and it would need to be coordinated. So I have this thing called the Lambda Orchestrator. There is the QR code. But essentially, I'm going to go through this very quickly because we are running out of time. But what this service would do is this would allow you to implement things like the strategy we use for caching, the strategy we use for buffering and throttling, the circuit breaker strategy, and some of these other things that would allow us to sort of coordinate all these things using a single Lambda function, and would allow us to manage that quota so that we weren't exceeding that quota with all kinds of protections in here, and we're not losing any data. We're using a fan out pattern. So again, there's an entire blog post on this that you can check out. And hopefully this will give you information that you need. All right, so moving on to decoupling our services. If we think of something like EventBridge is a very cool service where what we can do is we can send one request to it, one event, and then that's an asynchronous event, so we can just connect immediately from that service. And then we can send the results of that event or send that event to multiple services. We can multicast it. So send it to SQS, send it to Lambda, send it to step functions, send it to our another event bus in another account, and plus 16 other services. And so you can also set all these really cool rules that allow you to filter with patterns and all kinds of stuff like that. It's a little bit more advanced than using SNS, for example, because you can actually filter on the data as opposed to needing to look at metadata. You can forward to other accounts, like I said, and it's pretty resilient. You're going to get 24 hours of automated retries. Most of the time, you're sending things to another service in AWS, which means the likelihood of you losing those is very minimal. Now, the reason why this is important is because we can take those strategies that we just talked about, and we can use those to actually separate each component of our application so that we can implement the right strategy for the right piece of it. So let's say that we send something to EventBridge. This is a order, like an order process or an order submitted request. So we can immediately respond back to the customer and say, hey, we got your order. I mean, think about Amazon, think about any place where you put an order and they're not processing your order immediately, they're distributing that to other systems. So then we maybe have an order service, and we put a rule in here where we say only send us, order completes or whatever that is. And then we can buffer that in SQS. We can use a Lambda with a concurrency to write that eventually to an RDS cluster. And again, if that RDS goes down, we don't have to worry about it. It's buffered in that SQS, and we can retry it and use all those different patterns. But the great thing is now we can create other services. So let's say we want an alerting service, and every time an order is placed and we receive your order, we're going to go ahead and send you an alert that says we got your order. So let's say we have a billing service, all right, and we have an event that sends into the billing service that charges your Stripe API. And again, if Stripe's down, but RDS is working and Twilio is working, we still want those other pieces to happen. So you can use these rules to set things like this detailed type order complete, or when the total is a numeric value greater than 0, because maybe we have like something free that we don't always bill people for. And what's great about this is that you just have the ability to filter all these events and selectively trigger those services. And then that allows you to manage the throttling and the quotas and all of that other resilient things we talked about per individual service. And of course, you can use Lambda destinations with asynchronous events, which we didn't talk about, but a very, very cool service that can allow you to sort of process events on the back end without having to write a bunch of extra code. All right, so we're almost done. So other non-serverless components, you have managed services, you have other cloud services like Elasticache, or Elasticsearch, or MongoDB. You have to think about. You have to think about other legacy systems. We have to think about our own serverless APIs. We may be restricting how many people can access our own APIs. If that's the case, then we have to be very careful about that. So finally, non-serverless components are inevitable. Know the limits of your components. Use good caching strategies. Embrace asynchronous processes. Buffer and throttle events to distributed systems, and utilize eventual consistency. We didn't really talk about this, but the idea is that it's okay for things to take a few seconds to update and distribute to other events. That happens all the time. So that's it. Check out my blog, my podcast, newsletter, a couple open source projects, and follow me on Twitter. Thank you so much for having me.
Yeah, thanks. And we have Jeremy with us. Hi, Jeremy.
How you doing?
How are you? So, good morning.
Good morning.
Good morning. So, yes. So I now have an earworm from the "I Want My SQL" song. Thanks for that. So we have time for a couple of questions. There's a discussion ongoing about how serverless Aurora could solve the, for example, the scalability availability issue. Maybe you can say some words about that.
Yeah, sure. So, Aurora Serverless is great because what it does is it allows that cluster or the instance that it uses in order to serve up your whether it's MySQL or Postgres now, it can automatically scale that up as the demand increases. And the way that it does that is essentially what it does is it creates it uses a warm pool of containers, and it will size up that database for you. And then your data, because it's replicated across all these different availability zones, it can just switch your data, and typically you don't have any downtime as it does that scaling event, right? You can't scale up when you're running long-running queries or something like that. So that works really, really well, and you basically have no downtime as your database scales up. The problem with Aurora Serverless is that the way that it scales up is based off of the number of connections and the CPU utilization. I think it's 70% or 75% or something, or 90% of the connections and 75% of the CPU. So the problem that you have from FaaS and working from Lambda is that you have to create a separate connection for every concurrent invocation. And so because you're going to do that, even if you've got high traffic, if you've created 1,000 connections to your database because you've got 1,000 instances of Lambda running or 1,000 concurrent invocations, then your database might try to scale itself up. But in actuality, it's just because you have so many connections that it has to scale up. It's not that you have that many connections because you have that much load. And so that's where RDS proxy comes in, which basically says we will take the connections from your Lambda function and we'll take those thousands of connections and we'll reduce those down into just a few connection pools that will then connect to your database. But the two can't work together. So you can't use RDS proxy with Aurora Serverless, because essentially what RDS proxy would do would be solve the problem that causes Aurora Serverless to scale in the first place. So if you want to use an HTTP type connection into Aurora Serverless, you can use the data API. But otherwise, if you're just connecting straight to Aurora Serverless using a MySQL protocol or Postgres protocol, the problem there is that you are likely going to get these scaling events if you're under high load, and really not because you need to, but only because you're just using so many connections because of what I like to call the broken connection model.
Okay, yes, thanks. So I think we have time for another question. So Adrian asked, do you have experience with very large databases, partitioning, clustering, failover backups?
Yeah, so I had a startup several years ago where we had an entire MySQL cluster that was sharded. We had sort of a lookup cluster, and then we had all of these separate sharded components that had their own replication models in each one of them, and you had to sort of do this lookup and assemble the data. So I've had the pain of dealing with very, very large MySQL database installations and the problems that come with that. And you could still do something like that now. I mean, you're still going to run into the limitations of relational databases, right? So relational databases only scale so much. And if you get to a point where you're talking about millions and millions of rows and you have to sort of aggregate that and have all the failover in place and be able to pull those together, then you have to start looking at something like a sharding strategy. And so you're only going to get so much performance out of something like Aurora Serverless because it can only scale up to 256, what they call ACUs. And that's great. Like you could handle a lot of traffic and things like that, but also, again, you're going to eventually run into problems with things like joins or whatever, and you're probably going to end up having multiple Aurora Serverless clusters in order to do your own sharding and things like that. So in the world we live in now, I typically recommend people not use RDS to do web scale type applications, but instead look at something like DynamoDB, and really have those access patterns planned out, because those can scale pretty much infinitely, and you don't have to worry about it. But yeah, I mean, I have not built a large MySQL cluster out in a very, very long time because I've relied on sort of much more resilient type technology like NoSQL databases.
Yeah, thanks. So serverless can't fix relational databases entirely,
right,
or Lambda.
Right.
So we were still so problems with relational databases are still the same, even in the serverless area. So I think we are now unfortunately already up with our time for Q&A. So thanks again, Jeremy. So you also have this serverless patterns website, which I find really cool. So what's the URL? Can you put it in the chat, please? Because I think this is really awesome. Because
I'll be adding some more. Yeah.
Great. So because Jeremy's really like Mr. Serverless patterns, and so you don't have to learn all the stuff by yourself. Just look at his content. Yeah, thanks again. Have a great day.
Thank
I
you.
guess you will still around a little bit for questions.
Yes,
for more
definitely.
questions. Cool. So if you have more questions, go to the Resilient Serverless channel, ask Jeremy questions there. And now I am going to hand over to Jonas again. So bye-bye, Jeremy, and
thank you.
See you soon.
Bye. Thank you, Jeremy. We are heading towards the last talk of ServerlessDays Hamburg 2020. This was a very special version this year, and we're welcoming another AWS hero to the stage. It is Erica. I will get her into the digital studio now. We should now see her, and there she is. Hi, Erica. How are you doing?
Good.
Nice to see you. Erica is a principal engineer at New Relic, and as I mentioned before, another AWS hero. And she is very passionate about systems architecture, security, and machine automated low-code development. And as I said before, this is going to be the last talk of the Serverless Days. And funny enough, her talk is also called My Last Serverless Talk. So without any further ado, the stage is yours, Erica. Thanks for being here, and let's go.
All right, thank you for having me. So as you said, the talk is titled My Last Serverless Talk. But I also wanted to talk to you about, and let me make sure I can switch my slides. Right, about my last or previous talk, which was Gmail was cheaper and actually worked, or how I failed to save $5 a month building email from scratch. So when I needed an email service, I said, well, I don't want to spend money with Gmail again for, especially if I wanted to do, it's like a vanity domain, and I wanted to give, users to my friends, and Gmail is $5 a month per user. And I said, well, I've run email servers before. This is something I am familiar with doing, but can I do it serverlessly? Because I like to approach problems serverless first. And I thought it would be a really interesting exercise to try and build out an email service based completely around, well, as much serverless as possible, because I recognize that I would not be able to make this 100% serverless. But it was also something I was really deeply familiar with. I've built email services before, so I felt like this was a really good domain for me personally to take a problem that was hard to do serverlessly and then do it because I have that experience, right? So for those that don't have that experience and aren't as familiar with how email services work, on the left-hand side, we have an email, a system, like a laptop, sending email via SMTP to its own local SMTP server. That server also sends via SMTP to, this would be our destination server. This is where we are receiving our email, and this is where systems pull from those emails via POP3 or IMAP. This machine here would be running an MTA like Postfix, Dovecot, and XM, SendMail, etc. And then also in the POP3 or IMAP service, which again could be Cyrus, Dovecot, etc. So that would be our traditional model. So again, I was like, architecting serverless first is a good idea, except one of the problems that we have here, if I actually go back to the previous slide, is that neither SMTP nor POP3 or IMAP are protocols that we can actually do serverlessly. These are protocols that are, they're not binary protocols, but they are not HTTP based. And all of the serverless services that are provided, like API Gateway, for instance, are HTTP based. So we will not be able to natively use these protocols serverlessly. So it becomes a question of what can we do serverlessly, or at least some SMTP we can do serverlessly. We'll get into that in a moment. So the basic structure for receiving those emails would be to use Amazon SES, which provides email forwarding into S3. S3 provides object storage. And then we store those files in S3 in a standardized MailDir format. And using MailDir is nice because S3 creates those files very readily, and it's a well-supported format in most services like Postfix, Dovecot, etc. They all support MailDir. So what I'm going to do here is actually switch. Wait, this one. Okay, so this is the Amazon SES console. And what I've done here is I've created a domain, and I set up the verification and the DKIM status. And this means that I set up all the DNS. The DNS is pointing here, and it exists in SES. So what I can do here is set up my SMTP credentials, which are provided here. This is how I can send email out from here. So I'm not going to click this because I don't want to share my credentials to everybody on the stream. But this will be based off of AIM credentials. So using, that means that it does not necessarily work with single sign-on because it needs to use your access keys and so forth. It's interesting because it says they are different than your AWS access keys, but they are actually based on AWS access keys that have kind of been serialized for SMTP credentials. This is probably not the best way if you're going to support a whole bunch of users. You might want to create a proxy in front of this, running a traditional service like XM or SendMail. But the nice thing is that if you are in a rush or you're just doing this for yourself, you can absolutely run your Outlook or another SMTP client directly off of the credentials that you generate here. So let me go back and see what I'm missing. Okay, so we want actually email addresses. SMTP settings, sending statistics, rule sets. So I guess I disabled my rule sets. All right, I'm going to go back to, this is why I took screenshots. So you can create a rule set. My default rule set was to create the files in S3. I guess I had accidentally deleted these at some point. But what this would do is take emails for Erica and put them into the S3 bucket in the maildir format. And then on S3, I could go in and I could create rules to put those files elsewhere if I want to. So for my email client at this stage, right, I'm receiving emails in maildir format. How do I read them? I don't have SMTP. I don't have a POP3 service or an IMAP service, but I can verify that the emails are being received by simply loading up the S3 console. This is the most fundamental email client, I suppose, that you could create at this stage. It's just a good way of verifying that those emails are, in fact, coming in. And we went over this. So, but what you can see is that I did test this, and once using those SMTP credentials, I am able to actually send email through SES to myself, right? So that was kind of easy. That's thankfully the easy part. But email fetching is harder, right? We shouldn't expect that users are going to use S3 console in order to fetch their emails. It's not scalable. It's not convenient. And if we were to go back to those screenshots, you would see that there are just all, we don't get subject lines for those files. We just get like a SHA-256 or something for its file name. It's not particularly a very user-friendly way of reading your emails, right? You want to be able to use your email client. You want to be able to access your emails on your phone. And for that, we need a POP3 or IMAP service. Personally, I'm a big fan of IMAP. IMAP works a lot better with things like mobile devices these days than POP3, which would synchronize usually one computer to download those emails. POP3 could be a really great way of downloading, if we could provide such a service, to download files off of S3 into something else, potentially, where we would run IMAP. But ultimately, we want everything in IMAP. So unfortunately, there is no IMAP service, right? And there's also no raw socket listeners for Lambda. There's no way that serverlessly we can listen for IMAP because it is it's a straightforward TCP IP connection that it makes with I don't want to say it's ASCII, but it's you can certainly work with it within the ASCII code sets. It's not like it's a binary protocol. So looking at how do we solve this problem, like, okay, we can't process these serverlessly, so what can we use? And this is a mapping that I created of all of the protocols on the left-hand side, TCP, UDP, WebSockets, and HTTPS, and how can you get those into services like, for instance, Lambda. So, with Lambda, you can map this, ALBs and API gateways can talk to Lambda, and you can use WebSockets and HTTPS to talk to ALBs and API gateway. You cannot do raw TCP or UDP to either ALBs or API gateways. The only service that you could use here for raw TCP or UDP would be a network load balancer. But if you were to use a network load balancer, you would have to talk to EC2 or to containers. So if we want to run IMAP, we need to set up a network load balancer and then a fleet of machines running the IMAP service on either EC2 or containers, or both, right? If you're using Fargate, you can run natively just on containers. If you're using EC2, you could put containers inside of EC2, or you could just straightforward, of course, run those services inside of a VM. So in my case, I selected a network load balancer. So the client talks IMAP to the network load balancer. The network load balancer talks to IMAP, which is running on Fargate instances. And then somehow we need to access the files that are running on S3. Hi, I'm in a phone call, so I'm going to need you to wait, okay? You can take your iPad. Hi, I love you. See you soon. Okay. So where were we? So somehow we need to be able to get those files off of S3 and be able to read them from our Fargate instance. So when I first started looking at this, I first started building this out back in, I think, 2018. We did not have EFS. There was Fuse S3. I really did not want to use that. EFS was an option from Fargate, but it was not an option from Lambda. So getting the files from Lambda to EFS was a bit of a mess. Not impossible, but certainly not convenient. And if I... Right. So actually, just to go back really quick, one of the other things I could have done here is I could have had the Lambdas reading off the S3 bucket and then sending SMTP into the Fargate instance and running an SMTP service on Fargate also. One of the solutions that came to my attention is that somebody actually has done this besides myself. And they built a project called SES IMAP, and it is a Lambda-based service. It's small, it's relatively simple, it's open source. And what it does is it allows you to run an IMAP service, off of, I believe, Fargate, and it uses S3 as a storage backend natively. So this is an IMAP service that was custom developed that authenticates using credentials stored in S3, although that could be changed. And it allows you to use S3 directly for the storage backend for the IMAP service. It's a really neat project, but it has been 4 years since the latest commit, probably closer to 5 years now since I put the slide up the first time. It's not completely serverless. It does run on Fargate, and it lacks some polish. I tried to deploy it, and I ran into some trouble. So certainly something you could use here. I decided to go a different way. And the main reason I decided to go a different way is because Amazon released EFS for Lambda. So with EFS for Lambda, I could run a traditional IMAP service using EFS as a backend. Just looking at our storage mappings, SES can talk to S3. Containers can talk to EFS, but containers cannot natively mount S3 as a file system. Of course, they can access S3 via an API, but other than using Fuse, you're really not wanting to use S3 as a file system, right? Lambda, however, Lambda doesn't use S3 as a file system exactly, but S3 as a file system can use Lambda. It has, the S3 triggers. So in our particular use case, when S3 publishes when SES publishes to S3, S3 can trigger Lambda, and Lambda is able to talk to EFS. So here's our prototype. We have a client that talks to IMAP, to NLB, talking to Fargate, running dovecot IMAP, right? That's unchanged. This is this top line here should be familiar from a few slides ago. That part has not changed. But then we also have SES to the mail dir to EFS, right? And now this part is new, right? So now we're going to use EFS as our storage mediator. This is where your mail will actually sit. And what happens is that the S3 mail dir bucket ends up being a place where you could either choose to just have a one-day retention and delete those, and it just becomes, basically an inbox queue. And that can also be a really great place to implement spam filtering and other things before you write it into EFS. Let's see. Yeah, so we would write those to EFS from the mail there, right? But the question is that serverless, right? The SES part is certainly pretty serverless. The Fargate side maybe isn't so much. One of the great things that I consider in terms of whether or not something is serverless or how serverless something is what you're paying for it. And we can see here that a network load balancer is pretty expensive. It is a provisioned resource. However, it is scalable in a pretty serverless fashion. You don't need to really manage it. It's just once you set it up, you are paying about $16 a month plus your elastic IP, which is $1, and data traffic. Altogether, I would estimate probably for even a small service spending close to $20 for the network load balancer per month. If you have 2 instances on Fargate, I would just estimate that's about $40 a month. Maybe a little less, maybe a little more, depending on the size of the instances that you choose. But I mean, at this point, we're already close to $60 for the non-serverless components. Certainly not $5 a month. Now, the great thing is this will scale. So you could support probably 100 users, 200 users, 500 users, or more running off of this infrastructure that you're paying $60 a month for, which is not bad compared to Gmail. But if you're using this for one user, which would be myself for my own personal use, it's certainly a more expensive option than paying for G Suite. But the serverless component here, which is on the bottom, is 10 cents per 1,000 messages and 12 cents per gigabyte for attachments received. Which also brings me to another really strange property of this whole setup, which I didn't mention earlier, is that Lambda, SES, and S3 are not aligned in the sizes of the objects that can be passed through them. So SES can pass through email attachments that are larger than Lambda can process through the S3 trigger, which is a interesting and unfortunate property, because what happens is there's no way to reject those attachments for being too large in SES, because SES is just like, yeah, we can store these attachments. But the problem is that we can't get those attachments from S3 into EFS. So one of the solutions here is to basically trigger on those messages and then pull them through the S3 API to put them in the EFS. Or what you could do is make the file public and have like a link into it. Or at that point, have the Lambda trigger send an email out to the user who sent the message saying that their attachment was received but was too big and is being discarded. So what I suggest is that if you want to do these, really, if you're building serverless, right, experiment in learning services, learn best practices, right? And I don't care what it's called. I don't care that this was not a completely serverless system. I think that building something like this for your own personal exploration would be really useful for you to learn how these services work and also how you're built. This service ended up costing me a little bit more money than I wanted to spend. I ended up spending probably actually more, because I think I just estimated this is about $60 a month plus the cost of the emails that are being received and the storage. However, I was probably paying closer to $100 or even $200 a month, because setting this up, I ended up setting up a staging environment. I ended up allocating too many resources in one place or another, let some things run for too long, etc. So it's definitely a really great way to build services like this in order to learn what their impacts are, both financially as well as how to put these pieces together. And if you're an engineering manager, I would really suggest maybe putting it getting like $2,000 per engineer just for playing around with AWS and learning it, because you don't want people learning necessarily all the time with your production infrastructure. I think that giving people time to hack and learn is really useful. So just talking a little bit more about the billing and so forth. Morningstar is a customer that I've worked with, and they were surprised how easy and affordable it was to move to Lambda, and that, for them coming from a huge deployable enterprise application, it was a thrill to get something that provided such fast deployment times. They had a geological stack of languages and applications you have to keep alive, and Lambda became the glue that pulls all this stuff together. They reduced their outages, and they were able to comfortably deploy at 5. And the reason that I'm bringing this case study up is because, I'm talking about a hybrid infrastructure here, right? These are IMAP services, Dovecot, SendMail. These are very much legacy applications. And I think it's a really great example of how things don't have to necessarily be greenfield or serverless, designed for serverless, or coming from modern infrastructure, or being RESTful applications or GraphQL applications. They can be, these legacy applications that have been adapted and migrated and developed serverlessly, and you still get these advantages of serverless, even though we're using Fargate and even though we are not completely serverless, right? And just some final notes I want to leave you with. There's no point in serverless if you have budget constraints. This is, what I'm doing here is, $60 a month for handling hundreds or thousands of users on email is significantly cheaper than, if anybody has ever run an Outlook server or an Exchange server, they would know it can be very expensive to run enterprise email. You could run enterprise emails with something like this for significantly cheaper. Maybe not for $60 a month. You probably want some additional services here. And unfortunately, there's a lot of DIY. So you would have to solve some spam fighting tactics and other things that are going to cost you engineering time. But in terms of CapEx and so forth, this is significantly cheaper. But if you can afford to just run G Suite or whatever, why not just do that, right? And finally, it's all about the billing. Just repeating, allocate some money to your engineers, right? Constraints are good. Making it hard for your developers to build things a certain way actually can be a good thing. Saying that you should try and build serverless first, or see where you can use Lambda, where you can use Fargate. I think those are good as long as, again, you have budget constraints. And I think that constraints in general are a good thing for you to have. Just going back to my days with Docker, I felt that the biggest advantage of Docker was that it was constrained. You could build containers previously, but containers were undefined. There were no constraints. There were no boundaries. There was no definition to what a container was. And Docker came around and it set up constraints. It set up standardization. And that is what made Docker so successful. And I think that for serverless to be successful in your organization, you need to do the same thing. You need to apply constraints, because if you just say that you can do business as usual and not use serverless and just use EC2 all the time, then you're never going to go serverless because you're not applying a constraint. And again, you're acting as if you have an unlimited budget, right? So that's it. I thank you very much. I will stick around for questions.
Well, thank you very much for your talk, Erica. Indeed, there was a question in the Discord channel. It's from Sönke, and he asks, could we scale down Fargate to 0 instances to save costs during IMAP not being used?
I guess technically, but you'll have to wait for those instances to return in order to fetch your email. I would probably not want to scale it down under 1 because you probably want to be able to fetch your email, right? Again, you could. It would just be really inconvenient. I've also tried scaling Fargate down to 0 in various cases, and it just never worked out really well for me to try and scale down to 0. I never generally recommend scaling Fargate instances down under 1.
All right, thank you. I see that someone is still typing, and while the person is completing the question, I wanted to ask you, why is this your last serverless talk, actually, Erica?
So honestly, this was kind of a working title, and then I was like, well, it's the last talk of the day. I'm going to talk about the last talk that I gave, but also, I think that serverless is part of how you build your cloud applications. So I'm looking at how do you build applications that are holistic and using the services that are available to you. It's not just serverless. Serverless is part of that story. I'm expecting that this might be the last talk that I give that is like, yes, this is just all serverless. I want to talk more about a more holistic approach to building out these services. Even this talk itself was very much focused around a hybrid type infrastructure, because I think that that's what most applications are going to be built around.
All right. I wanted to ask you, at one moment in your talk, you talked about IMAP versus POP3, and you said that you choose IMAP for your architecture. Would it be possible to do something similar actually with POP3, or would you say that's just not possible?
No, absolutely. In fact, the service that I used here, Dovecot, supports POP3, and it would just be a matter of turning it on. I just didn't really care to. But I certainly could have actually supported POP3 in this as well.
All right, and there is another question from Discord. Adrian145 says, thank you very much. Good solution, inspires me using AWS EFS. Would it be possible to share your presentation? And the next question also from the same person, so I read it at once. How big can grow the needed storage being manageable with IMAP EFS?
EFS supports massively sized data stores, so I would not be concerned about how much storage you need, especially for something like email, which doesn't use a lot of storage. EFS will scale to, I don't want to be quoted here and say the wrong thing, but I imagine that it's many, many, many terabytes, and it will be more than you need for for even a medium or even a large email installation, I believe. There might be some concerns about performance with the EFS, but I think that with email and IMAP, there should be no major performance concerns.
All right, thank you very much. And I think with this, we're concluding the Q&A with you. Thank you so much for being here. And maybe you can stick around a little bit in the Discord channel as well, in case there will be any further questions. So thank you very much for being here. And bye-bye, Erica.
Bye.
Yes, bye-bye. Thanks. So, and yes, unfortunately, this was our last talk, but you can, of course, still stick around there with the speakers and engage, and also with the other attendees. Feel free to use the Discord server as much as you want. And I want to thank again our sponsors. So we have AWS, we have Cthulhu, we have Codecentric, we have Lumigo, we have Sinnerschrader, Global DataNet, Opitz Consulting, Thundra, Kreuzwerker, and Cellular. So really, thanks again for being with us and staying with us during this special times. Also, thanks again to our speakers. This was really great. I forgot Nicolai here. Sorry for that. This was because of a switch. But thanks again to all of our speakers. I think we had really amazing content across really different areas of the entire software development and ecosystem. So this was really cool. And yeah, so last but not least, I can again only say save the date for 2021. We will keep you posted on whether we will be physical, hybrid, or virtual. We don't know yet. We still hope for a physical or a hybrid event, and we still hope that we can go. Yeah, we can use this really awesome location. And yes, so that's all I got to say. Jonas, anything to add?
Not really. Thanks to the team behind the scenes again. And yeah, good weekend to everyone, I guess.
Yes, thank you. And see you next year. Bye-bye.